Very good morning to all of you. And today we are into the second day of the workshop on recent advances in underground metal mining. So today we have 5 lectures, all very important subjects. Most importantly, we have two uh, speakers from Hindustan Zinc Limited. That will be our first 2 lectures of the forenoon. So I would like to introduce the speakers here. Is Mr. Pradeep Kumar. He is the head of geotechnical department of Sindeshwar Khurd mine. So SK mine, as you all know, it is the largest producing underground mine in India. It is one of the best in the world, in fact. It has got all advanced technologies. You can say that it's one of its kind. I think I recommend all of you to visit SK mine and Rampura Gucha mine. So let me just read out his brief biodata. He did diploma in mechanical engineering from GPC Bikaner in 2012. Followed by that, he did BTech in mining engineering from MBM Jodhpur College, and he was a silver medalist in 2015 batch. He enrolled in working as a working professional PhD program at IIT Kharagpur in December 2020. So he is now pursuing his PhD. He has 9.5 years of experience in working at geotechnical department. He is also first class mines manager certification, unrestricted. And he has trained in professional development program in hard rock mining at ISM Dhanbad. And he is successfully implemented underhand mining method at SK mine using paste fill, and worked in following projects like crown pillar extraction, double lift mining, paste fill design, and he is currently working as head of geotechnical department of SK mine. And I can say that he is also the team of he is the leader of their mine rescue team, who has won first prize last year. And he has also participated in the international mine rescue. He led the Hindustan Zinc team for the international mine rescue competition recently done at Peru, no? Where it was? Colombia. Yeah, good. So he is a very energetic and lively mining engineer. So we are happy to have him here, and so that he can present all the modern technologies they use in Sindeshwar Khurd mine. Secondly, I would like to introduce Shubham Vijayvargiya. He is the associate manager in mine planning department of SK mine. So they together will present 2 lectures continuously. And he is a BTech in mining engineering from College of Technology and Engineering, Udaipur. He is pursuing MBA in business analytics from Birla Institute of Technology, Pilani. He is currently working as mine planning and designing engineer in Hindustan Zinc Limited. He has more than 5 years of experience in mining industry, among which more than 3 years experience in mine planning. And he is also a first class mines manager. He has implemented drilling and blasting design in AGs and Deswik softwares at Sindeshwar Khurd mine. He has implemented backfilling reconciliation in Deswik CAD, planning and stope designing and scheduling for long hole stoping with backfilling method of mining in data mine software. So he is expert in all these softwares, and the implementation of short interval control in mine development areas. So they use the most advanced softwares and technologies available in the whole world. So we are very happy that we have such expertise here in India. So I thought, why not utilize their expertise and share their experiences here. So I invite both of them for this lecture. They will do it consequently, and we'll start with Mr. Pradeep Kumar for his lecture. Please.
So first of all, thank you very much, John Louis sir, for giving us the opportunity to showcase our best practices, what we are doing in Sindeshwar Khurd mine. So first of all, good morning and warm welcome to all the dignitaries of the dais. And let's start with the underhand mining. So we will start with the underhand mining. So underhand mining is one of the unique method that we have started in our Sindesar Khurd mine. So we will discuss this underhand mining. So first I will give some introduction about Sindesar Khurd mine. Then we will talk about what is the backfilling procedure. And in the backfilling, we will talk about hydrofilling, CRF filling, and paste filling. Then in the particularly paste filling, we will discuss blast hole stopping with the paste filling. And then we will talk about the underhand mining under the CPF. That is the new innovative method that we have started in from last 2 years. And then we will discuss about the ground control instrumentation, the new instrumentation that what kind of instrumentation we are using in our mine. So first I will give you the brief introduction of Sindesar Khurd mine. So Sindesar Khurd mine is India's largest underground mine, which producing 6 million tons per annum from underground mines. It's the lead and zinc mine. So it's having 2 decline. The width and the height of the decline is 5.5 by 5 meter. And as we have a 65 tonner LPDT, which is running in the ramp, so we have the ramp size like 5.5 by 5 meter. We have one shaft, which is 7.5 meter shaft, and this is 105 meter depth. It is Asia's largest vertical, deepest vertical shaft we have. That is 1 kilometer vertically. In Asia and worldwide, we have lots of deepest shafts, but they are like staple shafts, somewhere like inclination is there. It is Asia's largest 1 kilometer vertical shaft is there, and the diameter of shaft is 7.5 meter. We have one skip compartment, 80% can travel, double decker skip is there, in which 80% can travel, and one side we have 2 skip, and the capacity of one skip is 32 ton. So we have 64 tons 2 skip, which is continuously running. And then we have method sub-level stopping with backfilling, as well as underhand mining, the mining method that we have using. We have like the shaft capacity is 3 million ton per annum, and decline capacity is 3 million ton per annum. So combinedly, we are extracting 6 million ton per annum from the mines. For the ventilation purpose, we have 9 hidden air rages, which is circulating 1350 meter cube per second. We have 10 fresh air intakes. We have a peripheral type ventilation system in the mine. For designing purpose, we are associated with the Simfer John Lewis sir for the blasting, Vivek sir, and we have we are continuously committed with the Simfer for the designing part, and we have associated with the back engineering too. Also, we have latest software in the data mine, Dasvik, Flag 3D, and Leapfrog that we are using in the mine. So it is the, you can see, this is the surface topography of mine. So we have surface MRL is somewhere around 512 MRL. And you can see till the working where we are working somewhere around 1.2 kilometer below from the surface. And still we are producing 6 million ton from that deep mine. So we will start with the backfilling. So what is basically what is backfilling? Backfilling is whenever we are making a void due to the mining, then we are again backfill that part, like we called it stopes in metal mine, in coal mine is known as GOF. So basically, what is backfilling? Backfilling is again filling the void that we have created after the mining. So it is a backfilling. So why backfilling? Why we are doing backfilling? Backfilling will provide us the confinement. Due to that, we can extract the secondary stopes. It is helping us to overall stability. It is helping us to reduce the subsidence. It is helping us to prevent fires and explosions in the mine. So what kind of backfilling that we can do in the mine? So basically, there are like 3 types of backfilling currently available. Like 4 types. Sand filling is also there. So one is sand filling, one is hydraulic filling, one is cemented rock filling, and one is paste filling. So we will discuss one by one what kind of backfilling we have. So first we will talk about the paste backfilling. So in the paste backfilling, we having like percentage of solid somewhere around 78 to 85%. So the solid percentage is very high and water is very less in the paste backfilling. So what is the advantage of the paste backfilling? We can use fine particle as well as coarse particle both. We can use, and as is the water percentage is very less, so the water that remain inside the paste filling, we do not require to drain it out, because that water will be used in the hydration process. That water can be used. So no need to drain out the water like in the hydraulic filling. In the hydraulic filling is like we require coarser particle. We cannot use the fine particle due to their permeability issue. So in the hydraulic filling, we having the percentage of solid somewhere around 60%, and the remaining is 40% remain the water. And in this hydraulic filling, we are using coarser particle. We cannot use the fine particle. So we cannot use the whole tailing that we are getting. So we have to slime the tailing, and we have to utilize only the coarser particle in the hydrofill. So in that, we need to drain the water, excessive water that is there. So we have to drain the water. So as water is more, so it's required more time to consolidate, more time required for the consolidation. But in the paste fill, the water percentage is very less, so we does not require water to drain out. So the water remain inside that, it will be used in the hydration process, the water will be used. Then we will talk about the cemented rock fill. So one of our mine, Kayad mine, we are using the CRF method. So CRF method is simply, whatever the rock is there, we just crush the rock and we are mixing with the cement, and then we use in the void as a backfilling. It is known as the CRF. So basically, in SK mine, we are using the paste backfilling. So we will discuss today more about the paste backfilling. So as I earlier told that, so what is the CPB? Cemented paste backfill. It is a combination of mine tailing, the binder, and water. So we have three components there. One is the tailing. So mine tailing we are using. So we are using 77 to 78% of percentage of solid as a tailing. Then we are using the binder. So we are using two types of binder: cement, OPC cement, as well as the fly ash. We are also using the fly ash as a binder in the cemented paste filling, and we are using the combination of water. We are making the mine backfilling as a paste. So what is the advantage? As I earlier told, higher strength can be achieved. Drainage of water is not a big issue, and like in some cases we can utilize complete tailing. We do not require like coarser particle. We do not require finer particle. We can utilize whole mine tailing in paste backfilling in some cases, as it is gain earlier strength than the paste backfilling. So the stop cycle will be reduced. Like we are low porosity is there, so we can gaining the strength very high. Some disadvantage, it's not like the disadvantage. One, like we can say the drawback is there. So like it required a higher capital cost to install the paste fill plant, for running cost as well as installation cost. Both cost is very high. For if we talk about the paste backfilling, this is one drawback is there, and it is like in most of cases we cannot use like the gravity fill. Sometimes we required a separate PD pump, positive displacement pump, so that they can pressurize the filling, so that we can send the filling at very horizontal length. We can increase the horizontal length of flow with help of PD pump. So here is a flow diagram how backfill material is getting prepared. So we having tailing concentration in means whatever tailing that generating after the milling process, in that we having somewhere around 45% solid. So we having thickener. So thickener we are adding the flocculant in that. So after that adding of flocculant in the thickener, we having increased the percentage solid from 45 to 70%. Then that solid we are using in the filtration plant. There with the help of disc filter, we are increasing the percentage solid from 70 to 84%. Then we having a mixer in which 84% solid mixing with the cement. We are adding the cement as well as fly ash as a binder, And after the final product when will come, so the 77 to somewhere 80% of total solid will be there, and then we are distributing in the underground mines. So like this is again a process flow diagram of the paste fill. So this is the mill tailing. So this is deep cone thickener. So whatever the tailing generated from the mill process, we are sending in the deep cone thickener. So in the deep cone thickener, we are adding the flocculant in that. So whatever the whatever the particle that has been settled down, so we are sending it to FFT, filter feed tank. Then somewhere around 45 to 70% solid, because that 40% solid has been solidified, and now the solid percentage has been increased to 70%. Then we are sending this to FFT tank. Then we having disc filter. So from that 70% solid, increase here somewhere 84% solid. So here it will be like very cake type things will be there. So here cake conveyor is there. So 84% solid. From the cake conveyor, we are sending in the mixer, and then we are adding the water, which was the overflow from the deep cone thickener. We are sending in the mixer, and here we have the cement silo. So in the mixer, we are mixing the percentage solid like the mill tailing, the water, and the cement. So final product after the mixing, we are sending into the hopper, and then we having two paste plant. One paste plant is running by the gravity, as gravity play a vital role to transport the mill tailing and the backfilling, and one plant we having the PD pump. So like in that plant, we having the horizontal length is very high, so we have to pump the paste fill to a certain length, so we are using the PD pump, and in the one plant, we are using the gravity to flow the paste fill. So here is some picture of cement silo. This is like deep cone thickener. This is disc filter, where we are making 70% solid to 84% solid. And this is the photograph of cement feeding system. We having a one control room where all the data, moisture content we are maintaining. So this is a photo of control room. And this is the photo of underground reticulation system. So you can see that kind of pipe. This is the paste which is going inside the open stove. So it is the underground reticulation system that I have shown you. So this is one example of stove, how we are filling. So it was the stove, and this is the blasting boundary. After we are making it void, and we are preparing one barricade here. So we are having two types of barricade. One is 500 mm thick M35 short kit barricade, and one is that is bund barricade, which is like a combination of waste plus short kit. So we have two types of barricade is there. Once we are making the barricade, we are filling a higher percentage, 10% cement in the plug. It is known as the plug. So we are up to 9-meter height, we are sending higher percentage of cement. So we are making a plug. Once the plug will be settled down, after 48 hours, when the plug has been completely cured, so then whatever the bulk filling or main filling that we are putting, it is not pressurize the barricade, because the plug has been settled down. So no more pressure is coming onto the barricade. Whatever pressure is coming, it is coming on the plug fill. So this is the line diagram of like how we are we having the pipeline up to here, and we are sending the paste fill here. You can see after like 48 hours, we can send a 21-ton LHD over the cemented paste fill. It will be like a solid ground like this. After 48 hours, we can send a big machines over that. So it required a very disciplined manner to fill the void into that. So for that, we are using CMS. So before to planning anything, we have to make a pour plan. Pour plan is a plan where we are how much meter cube of volume we are going to put, what will be our process flow diagram, because it required huge cost to laying the paste fill line. If a paste fill line choke, it gonna impact huge cost to the company. So it required a very disciplined manner. For that, we are making the pore plan. So in the pore plan, we are determining what will be our underground distribution system, material, pipe, slump height. We have lots of measurement is there. First, we are taking all the measure, then we are sending the paste fill into the mines. So like you can see, in our mine, one thing is the CMS, cavity monitoring scan. So CMS is simply, it is infrareding lots of rays, and that got reflect back, and we are getting a profile of an open stope. So once we are getting a profile of open stope, so that we can know up to a height of 9 meter, we are making a plug, so that we can know with the help of CMS how much meter cube volume come in the plug, how much meter cube volume come in the bulk, and what is the position of stope. So you can see this is one stope we are making the Rhino. So we having data mine, Rhino, Flag 3D, lots of software is there. With help of Rhino and data mine, we are using the CMS volume in that, so that with the help of that, we can estimate whatever volume will come in plug. So we are, suppose that for, if we will take this example of this 255 S2240 stope, so we will send 2000 meter cube volume in plug, then we will wait for 48 hours, and then we will send 6300 meter cube in the bulk filling. In the bulk filling, we are using less percentage of cement compared to the plug, because whatever pressure is come of the bulk fill, it's come on the plug, not on the barricade. This is one example of one sheet that we are preparing. So in that, all kind of safety measures is the pore, non-routine, tight filling required, beazer pipe is there, diamond drilling hole required not. This is all the safety measures we are taking before sending the filling into the underground. So one major thing which come after, like flow model. Suppose that we are sending the paste fill with help of gravity, and if the process flow diagram is not accurate, that flow of paste fill will become choke and whole pipeline. And we here somewhere in the mine, 18-kilometer pipeline is there of the paste fill. So it is very, the flow model play a very vital role, very important role to calculate either this flow will go to the last pouring point or not. So this is with the help of like friction force, what will the friction losses will be there. So with the help of that, we are calculating is that, suppose that we are sending from paste plant, which is somewhere around 512 MRL, and we are sending somewhere like 1 kilometer below from the surface. So does that flow will go to that area or not? For that, we required flow model into the mine. And now we will talk about our mining method at SK mine. So this is one layout of like sub-level stopping method. So during the primary stop, so this one and this one, they all are the primary stop. So during primary stop, we having solo machine, solo DL421. This is one machine that can drill up to like 50 meter deep hole, and diameter can drill 105 meter to 115 to 165 diameter that can drill. So with the help of that solo machine, we are drilling holes from above level to down level, and then we are with the help of blasting, we are exploding the area, and then with the help of LHD. So at SK mine, we having two kinds of LHD. One is 17-tonner LHD and one is 21-tonner LHD. So in underground, we have like huge beast running in the mine, which is taking 21 ton in one go. So these are the big machine. So as we have to hold 6 million ton, that is a big volume. So that's why with the help of, we have the combination of 21 ton LHD to 65 ton dumper in the mine. So with the help of this LHD have a remote. So and also we can operate that LHD from the surface. So what will be the dream of a mining engineer? Like no one will work in underground. So it is happening in mine. So we have tele-remote operation. So one person sitting in the AC room and can operate the LHD, which is running in a like a very hot environment and in a very dangerous environment. So we have two types of tele-remote operation. One tele-remote operation is one surface is sitting, one person is sitting on the surface and operating the LHD from the underground. And second thing is there, the remote LHD. So what is remote LHD? Like person standing somewhere in the safe area, and with help of like when we are playing the video game, with help of like the remote, he is using his bogger to go into the dangerous area, open stope area, and doing the mucking. So this is the concept of remote LHD. So after the complete mine of this primary stope, we are backfilling the primary stope with help of paste filling, and after the after the primary backfill, we are going to mine the secondary stope. So with help of paste filling, we can recover secondary stope, which is known as rib in the, also known as the rib in the coal mine and some metal mines. So we can excavate the secondary stopes. So with help of paste filling, we can increase our recovery. We can take everything out. We can take the crown pillar, we can take the rib pillar. So no need to left the precious ore that has been given by the God to us. So we can excavate all things, the primary stope as well as the secondary stope. So once the primary stope has been mined out, we will backfill. So after the backfilling, it will sustain a vertical height of somewhere 115 meter in our mines. So you can see, imagine a height of 115 meter long vertical height, somewhere around 50 meter of paste fill still remains sustained there. But now we have reduced the stope size, so we having 30 meter stope height. So 25 to 30 meter stope height, that paste will remain sustained in a standing wall. That will provide, that will work at a side wall. So we can excavate the secondary stope by this method. Yes. Yes, sir. Yes, yes, draw point. Yes. 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 That's, yes, sir, that will come underhand mining. So my topic of this today is underhand mining. So, and as I earlier mentioned, we have two types of mining method. One is sub-level stoping with backfilling that I explained, and one is underhand mining, the below part how we are going to mine, that will come in the next slides. Yes, sir. Yes, sir. I will come to the in the upcoming slides. हाँ सर, 30 मीटर, हाँ हाँ। नहीं सर, वो बेरे पिलर हम नहीं छोड़ते हैं, वही पिलर हम नहीं छोड़ते हैं। वो जो आप सील पिलर की बात कर रहे हैं सर, अभी आपने उसको पूरा भर दिया, अब हम नेक्स्ट हम पेस्ट फिल में ड्राइव मारते हैं, then we are making a drive inside the paste fill. So we are not leaving any kind of barrier or seal pillar. So we are making a drive inside the paste fill. Paste fill में development करते हैं सर, हाँ।
But there is one more method before going into this underhand mining.
We are overhand.
Overhand mining sequence. इसमें आपने जो बोला ये जहाँ mine किए हैं,
इसके
एक seal pillar
छोड़ते हैं,
10, 15, 20 मीटर के seal पे वो डिजाइन करना पड़ता है, छोड़ते हैं, उसके बाद next इस तरह का एक level
और खोलते हैं।
And now what they are doing is after backfilling the top level and the bottom level once it is completed, बीच में जो ore छूटा हुआ है उसको mine करते हैं।
माइन करते हैं सर, टॉप डाउन मेथड है सर, वो एक्सप्लेन करूंगा आगे। So this is one again example of dike. Suppose that this is the primary stope, this is the primary stope. So once the primary stope has been mined out, we are backfilling the primary stope and we are making the secondary stope. This is the same photo, which one earlier has the 3D picture. This is the plan and section picture. And now we will talk about the underhand mining. As sir saying, how we are recovering, how we are going down inside that. So sir, suppose that sir, this is my backfill area. So first we are doing development inside the paste fill. So you can see this drive. So this drive we are making in the paste fill. For that we required certain amount of strength of the paste fill. So good thing is there. Suppose that what is the biggest hazard in mines. That is the rockfall hazard. But because why that rockfall hazard is so much dangerous? Because rock is non-homogeneous. It is elastoplastic capacity is there. It's not elastic. But in the paste, it's completely homogeneous mass is there. It is elastic material. It is like child material. Continuous, homogeneous, elastic material is there. So, like you are sitting in the room on the basis of what? We know that how much strength that pillar is gaining, how much strength that beam are gaining. Because we are, no, it's like homogeneous material. This beam is homogeneous. So we know that what is the strength is there. But in the rock, we having discontinuity. But good thing is there in the paste. Paste is homogeneous, elastic material. So we know the property of the paste. It is like cement block. We can development inside the paste drive and then making a drive inside the paste fill. Once this drive will be done, then we are doing drilling inside the bottom area and then again mining below that. So this is underhand mining. So currently underhand mining is practicing only in 2 mines of India. One is the Rampura Gucha and one is the Sindesar Khurd mine. Yes. Sindesar Khurd, which I am SK mine. Sir, yes, good thing is there. Like exposure time, more important is, sir, hydraulic radius. How much exposure area we required. So till now, we are exposing 500 meter square area. Like we having 20 meter strike length, so we are excavating 25 meter ore body width. 25 into 20 meter. So that much area exposed, we are exposing up to 4 months and 5 months. Still it's remain intact. Yeah, 5 by 5. But sir, once we are doing mining, so entire stope has been exposed. Yes, short kit and split set, sir. Yes, sir. No, sir. We have to put short kit and split set and again short kit. So somewhere around 100 mm layer of short kit will there, sir. First layer of 50 mm short kit, we are putting split set, then again 50 mm of total 100 mm short kit will be there, sir. So this is underhand mining, one example of underhand mining. And now important thing is why we require underhand mining. So it is one lithostructural model of our mine, which we have prepared in Leapfrog. Leapfrog is a software in which we can make our lithostructural model. So you can see how much complexity is there in the our mine. So this is our mine, and this is the area. You can see complex folding is there. Like, sir, actually we having like 2 things there. One is the core logging data, and second is the underground mapping, sir. So we, like I am a head geotech, I have one team below that. So they are doing regular mapping, and in the help of underground excavation, sir. With the help of exploration boreholes as well as from the underground mapping, sir. Like when we have exposure of 5 by 5, we are doing the mapping with help of Bantan compass, and we are taking data and we are projecting the fault upper level to another level. So you can see how much big fault. So imagine this is from here to here, it is 1 kilometer. So how much big structure is running? Like 1 kilometer big fault running into the mine, which is creating the complexity. So whenever we are going the overhand mining, due to that fault area, whenever we encountering any fault area, it started caving. It started caving because we having a fault area and it is under high stress. So it is started his profile losing. To mitigate that, we have started the underhand mining. Now in the roof, we having the cemented paste fill, which is very elastic. So the in the deep mine, where like suppose that this is our LVS of SK mine. So from surface to somewhere around 1 kilometer below. So now stresses is very high. We cannot go with the overhand mining because the stresses are induced caving is happening due to the stresses and due to the faulting and folding. Due to the complexity of structure and due to the complexity of stresses, the strata is behaving self-caving. to prevent that, we have started the underhand mining. So now, as in the roof, we have the cemented paste fill, and it is very elastic. So it is not cave, it is sustained in a very good manner. So now with the help of John Lewis sir and like back engineering and over also in-house modeling, we started like how much strength we required to go inside development. Like sir is asking how we are doing development inside the paste fill. So before going development inside the paste fill, we required certain strength. Once we achieve 780 kilopascal, like 0.780 megapascal strength of paste, so that it is a safe strength to go and can develop inside the paste fill. Sorry? We are getting 1.5 MPa somewhere. 2 MPa. After 28 days. Like, yeah, sir. So after 28 days of paste fill, when plug has been cured, when we will wait for 28 days, and then we are going to do development inside the paste fill. Yes, 1.5. It is like given by John Lewis sir himself. So, and then, yes, sir. That is enough, sir. If we will give more strength, then again issue will be caving. Because, sir, if it will having more strength, 100 MPa, somewhere around 100 MPa, so, sir, it will again start caving due to their stresses. Yes, sir, 0.78 MPa. It's like very...
That is the requirement from my numerical modeling. I found that 0.78 MPa is the requirement.
Required strength.
But their paste fill has got much more than that.
2 MPa somewhere around. Somewhere 2 MPa, sir. 2 MPa, sir. So now, for excavating a 5 by 5 meter opening, we required 780 MPa. Sorry, 780 kilopascal. But for exposing a huge area, 500 meter square area, we required somewhere around 1 MPa. But with the help of 1.5 factor of safety, we have increased up to 1.5 MPa. So this is one example, again one example. So it was the paste fill stove we have developed inside the paste fill, and we are doing mining below the paste fill. So you can see, this is the paste, and this is the paste drive. It's completely like no loss in the profiling. It's completely 5 by 5 circular profile is there. So it is the drive that we have developed inside the paste fill. And this is the profile. Profile is still remain there. We having a void created below that, and you can see the roof is still intact. The paste fill roof is still intact, and now we again backfill the area, the below area. So this process is continuously, and we are going down, 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 down this method. Sir, till now, somewhere around like 40 to 50 stopes we have mined out. But in Rampura Gocha, we have around somewhere around 600 stopes. Till now we have mined out, and in very safe manner. Sir, we having hangwall quartz mica schist, and strength is somewhere around 130 megapascal. 130 megapascal. But sir, again, if some hangwall still fail, so we have the remote loader, sir. No one have to go inside the open stope area. It remotely we are operating, and we are something fall, it will happen on the LHD itself. No person will be in danger. Paste, sir. Till now we don't have any fail in the paste, sir. Paste, like we have one footwall drive in the paste, which is running from last 5 years.
Plastic is not having much influence on the...
No, sir. No much influence in that area. Because, sir, paste, the good thing of the paste is elasticity. It's very elastic. It's like rubber. It observes everything. Whatever shock wave it will observe.
Have you done any study like propagation of blasting waves through the paste mass?
Yes, sir. One of our colleague, Ashish, did some study in that area. Then.
One more question. How many machines remain during the operation?
Sir, like your point is right. So what we can say like 2 remote loader in a 2-year time period. But it also, sir, we can recover, sir, with help of again one loader. With help of one loader, we having one tie arrangement. It will plug on to the balancing mass of the.
Any camera in the loader?
Yes, it is there, sir, but it is not that much effective. Like you are saying, it is not that much effective. Dust is there, dust environment is there. It is not that much effective. But with the help of like cable tie arrangement is there. With the help of that tie, we can.
Secondly, the
Sir, for the secondary blasting, we are not doing secondary blasting, sir. We are doing secondary braking. We having a one rammer machine that is also remote control operated. So we are sending the remote control loader into the mine and it is breaking down rock breaker. So like for the safety front, sir, Hindustan Zinc give huge cost and like huge R&D we did. Now we have completely eliminated the secondary blasting in the mine. So we are doing secondary braking into that. करते हैं सर शॉर्ट किट बोला ना शॉर्ट किट स्प्लिट सेट वायर मेश एंड शॉर्ट किट sir bolting will not be done because sir whenever we are start dealing with water it becomes slurry. Yes, friction support sir, friction support it's like dia of the hole is somewhere 38 mm sir, and we are sending 47 mm that split set into that, so it is expanded, so it is giving confinement to the side wall. Now we will discuss some about yes. Cost. Decline. 21 टन No sir, we are yes sir, to produce.
I think more than 25% you are selling.
Remove. Like sir, big.
ventilation for bus purpose, and when you go further deep, then you need a production shop. They have a production shop when it reaches over 500 meters.
500 deep. Then.
You need to have a decline for high production. Then you have 6 billion.
Because sir, if you want to send some big loader, LPDT, we require big size of dimension.
What is the capacity of LPDT?
Yes sir, 65 ton. प्राइमरी सेकेंडरी मैटर नहीं करता है फिर पेस्ट फिल मैटर करता है. रोक अपने यहाँ कहीं है ही नहीं, सीमेंटेड पेस्ट. मैं कंटिन्यू सर. जॉन सर. सर. Yes. Yes. Now we can start with like the instrumentation part. Guys, please attention. It can be like helpful to you too. So what kind of ground control instruments we are using in the mine? We will discuss about it. Like why we required ground control instrumentation. Like we need to know the behavior of the strata. We need to know how rock mass is behaving. For that we required ground control instrumentation. As in SK mine, we are doing back calculation. Suppose that we are putting some stress cell and we expecting a change in stress somewhere around like 2 MPa. So, and with the help of instrumentation, we are getting 4 MPa. So we are doing recalibration and we are sending feedback to John sir also. Sir also doing the recalibration. So for recalibration is one of the most important factor in the design part. Like in most of the mine, I can say, as I am a head geotech, so I can say in most of the mine, recalibration is not happening. recalibration is one of the must required things for a model. Suppose that if you are doing modeling and you expecting a hang wall deformation up to 2 meter. So if you have installed a MPBX in the hanging wall and we are getting the exact same numbers of deformation, so we can say that the data that we have taken in the design is right. Otherwise, either we are conservative, either we are more safe towards safety. So the calibration is one of the important factor, and the calibration we can take with help of instrumentation only. So today we will discuss about what kind of instrumentation we have in our SK mine, like MPBX, digital inclinometer, tilt meter, stress cell, EPC, instrumentation bolt, TAL10, and then we will talk about monitoring system. We having CMS, we have RFID tag system, and one is the seismic monitoring system. As we are working at a 1.2 kilometer below, we have a huge seismicity. To get that data, we required seismic monitoring system in the mine. So first we will talk about the MPBX. So most of the people you know how MPBX work, but still I am explaining with the figure. Suppose that this is our hanging wall. So whenever in the ore body we have one hanging wall, we have one foot wall. So hang wall have tendency failure toward the open stope. So we having one like drive known as the exploration drive. From where we are doing exploration, from that drive we are putting long hole, and in the same hole we are putting MPBX with different depth, like somewhere 25, 24, 22, it's like that. If any deformation started happening in the hanging wall, like only in the first anchor movement is there, so we can say the failure is very limited up to only the first anchor. If all the anchor having movement, so we can say mass movement is there, whole stope gonna collapse. So that kind of data we can get from the MPBX. Like you can say this is a mechanical MPBX, like we are drilling, we are putting anchor on that, then we are installing head over that. So this is one example that I told you, like this is the movement of only first anchor. This is the movement of second anchor. If all the anchor have movement, means a big mass is going to move toward the free face. A big failure can be there. So this is one example of over one stope where we have some little failure was there. So we are very well predicted that failure can be there with help of instrumentation. Like nowadays, digital MPBX is there. It is not a good approach to go in the hanging wall and measure the deformation, because hanging wall itself always having the tendency to move toward the open free face. So nowadays we have installing digital MPBX. So everything is mechanical, but the head is digital. With help of Geocon digital MPBX, we are installing the digital MPBX and we are taking the data on the surface. So MPBX data we are getting on the surface with help of digital MPBX. Multi-point borehole extensometer. So now, like sir, if you talk about the RMR, sir, so in the hanging wall we having like fair range, 40 to 60. Yes. In the ore body, good, like 60 above 60, but in the foot wall again, like less strength, sir, is there. So like as I told, one complexity is there in the mine. Like you can see, this is one dipping of the ore body. So earlier dipping of the over SK mine deposition happening along a fold. So you can see earlier dipping toward western, now dipping toward east. So due to that complexity, our shaft is somewhere in the hanging wall. So we have to put lots of structure. Like this is one example, 3D example of instrumentation that we are doing in our mine. So you can see all the magenta color, it is the stope that has been mined out and backfill. All the green color, it is the future stopes. And all the blue one is the running stope. So you can see we have even hang wall drive, and we are going to put long MPBX over that, and then we can get the data from the hanging wall. Digital MPBX is there, and this is one digital inclinometer. So in the shaft, we are putting 2 borehole, and in that borehole, we are sending this inclinometer. If any deflection happening into the shaft, we can get the data from the inclinometer. And this is like tilt meter. So this tilt meter is working on a radio frequency program, so it does not require any wire to snitch. So we are going to put this tilt meter in our shaft area. So how this tilt meter work? So if, suppose that this is a bench of open cast bench, if any movement started happening in the open cast bench, we can get the tilt data. So we are going to install this tilt meter in our shaft from 65 mRL to somewhere around half kilometer. We are going to put this tilt meter in our shaft. Like then the stress meter. So this is suppose that the primary stope is there. So as I earlier told, the recalibration of the data is very required. So suppose that we are doing some modeling and we are expecting some change in stress. To measure that change in stress is within the limit or outside the limit, we are going to install this stress cell. So if due to the excessive stresses, the rock hole got collapse, hole got deformed, and that deformation with help of the, like it is making by the steel having some different modulus of elasticity, and this is the rock, surrounding rock having different elasticity. But if the rock got deformed, that stress cell also gonna put pressure over that, and that change in stress we can get with the help of the stress cell. Its reading also coming on the surface at SK mine. Like you can see, like gradually the stress cell is in very like negative reading was there, and when we started that blasting, so sudden change in stress started happening into the mine. Like as I told that for the barricade pressure, we have to measure the barricade pressure. So we are going to install EPC, earth pressure shell, on the barricade to get the pressure, what is the exact pressure is on the barricade. So this is the EPC photograph we are going to put on the barricade and going to take the reading. So not now, sir, piezometer we are installing, like I told sir, in the paste field we do not have, sir, we have hydrofill, we have dismantled, sir. Sir, has been dismantled. The plant has been dismantled last 2 years ago. So we have completely shifted in the paste fill. So in the paste fill, we do not have an issue of the water. So we are not installing the piezometer. But in the tailing dam, we have one tailing dam, huge capacity tailing dam is there. There we are installing this piezometer, sir. But this EPC, we are installing on the barricades. So at the time of plug filling, so it's continuously increasing. Once plug fill has been cured, it's little bit decreased. But it's never going to attain again 0. This is instrumented bolt, like it required some time of modeling how instrument bolts work. This is a telltale, everyone knows from the like coal mines how telltale is going to reform. In the paste, we having one cold joint above that. The cold joint is the joint which is making between plug fill and the bulk fill. Like as I told, we are making the plug filling, and after 48 hours, we started the back filling. So there is a cold joint which form after the time gap between the plug and the bulk filling, and as well as change in cement percentage. In the plug we have higher cement, in the bulk we have less cement. So it is a cold joint formation. To get the deformation, is really deformation happening in the cold joint or not? We are putting this telltale. So we are installing the telltale 10 meter long hole, and we are installing telltale. If any deformation happen, we can get the data through telltale. Yes, sir. No, sir. Till now we don't 0. Yes. And this is one example of CMS. As I told, this is the monitoring system. I think that can be adopted by every mines. It is giving the complete profiling of the stope. We can do reconciliation. Suppose that a blasting engineer plan 10 rings. Is that 10 ring blasted properly or not? Is there any ore left? Is there any ore break is there or not? With help of CMS, cavity monitoring scan, we can get the profiling of that. So it's a camera is there. It is distributing lots of rays, and that rays get reflected back to the camera, and it gives us the profile like this. So you can see the green one is the plant blasting boundary, and the blue one is the blasting profile. After the blasting, what profile we get. So you can see, this was my plant, and we have left some ore here, and some ore here. So with the help of CMS, we can get complete detail of what is going inside a open stope. Sir, somewhere around 1 year. Like 25 lakh and then processing fee, something like this. So now yes, 70 lakh. Somewhere 1 year. Mota mota. So, sir, digital MPPX, everything is mechanical. Only the head is digital, sir. So the cost of one digital MPPX is 2 lakh, sir. Yes, sir. Yes, everything. Every device is mechanical, sir. Yes. Yes, sir. With the help of yes, sir. So as I told that shaft is in the hanging wall. So for if any movement happen in the bunton, so bunton, the shaft, everything is running on the bunton. So it is very critical role if any deformation happen in the bunton. So we have put this RFID on the shaft bunton system, and with the help of data logger, it is going upside. If any movement happening between two buntons, we can get the data with the help of RFID tag. This is the RFID tag we are going to put on the buntons, and this is like skip. We are putting data logger. Whenever that come in contact, we can see the real profiling of the buntons. And this is the real-time monitoring. This is like one system of Geocon. We having 64 channels data logger, two data logger. So in single data logger, we can put numbers of sensor. So MPBX, trace cell, EPC, all we can connect to the data logger, and we can get the reading on surface. And now we will talk about seismic monitoring. Like seismic monitoring system is like IMS is there, instrument mine survey system is there, which is giving us the triaxial geophone is there, and its location is there in the mine. So you can see like 1, 2, 3, 4, 5, 6 number of sensor is there, which has been installed in the mine, and it is making a loop. Every geophone is connected to each others. So if any seismic event happen in the mine, we can get their location, and we have trigger action response plan according to that. We have make the like you can see, if any event happen, we can get the coordinate where the real event happen, and we can do the mapping, we can do the damage mapping, we can do the inspection. If any damage is there, we can withdraw the manpower according to that. So with the help of this seismic monitoring system, we are implementing the TARP. Sir, 300 meter ideally. One sensor range is 300 meter. So it is array of numbers of sensor. Sorry, sir? Yes, it is capturing every blast reading, sir. If any blast is happening, we are getting the reading. Yes, sir. We have TARP, Trigger Action Response Plan. Yes, sir. Developed, and we are implementing. Yes, sir. Like, sir, not in this slide. Yes, sir. Yes, sir. So let me tell you, sir. Like if any event with magnitude more than 0.5 MPa. So if any event happen in the control room of mine, we can get the coordinate. Okay, in X stop, we having seismic event. So he immediately remove the manpower of surrounding areas. 0.5 m magnitude. 0.5 m event happen. So we are somewhere around like 2 stop distance. 2 stop, somewhere 100 meter area, we are withdrawing. If one event happen, somewhere 200 meter area, we are withdrawing the manpower. Yes, sir. Above from the working active area, sir. 300 meter. Yes, sir. Oh, financial. Can't share. Yes, in that, in every arrival of P wave, there is some characteristics which is different from blasting. Signature is there, like sir saying. Arrival of P wave or arrival of S wave, sir can understand. That will describe is that really seismic event or it is a blasting event, or it is a rock noise, or what is there?
They are from Hindustan, Hatti gold mine.
Yes, that's why interested.
They have reached up to 900 meters.
Yes, sir.
They are getting seismic.
Seismic event, yes.
एक करोड़ का है और 1 CR का है.
Thank you, sir. Any question? Thank you, sir.
Yeah, thank you very much, Pradeep. So this was a very interesting lecture, and I want all of you to even ask questions. ताली तो बजा दीजिए, लेकिन ask questions. There may be plenty of questions, I believe. So please write it down. We have kept a box here, query drop box. Please drop because there is not enough time. We have to move to other lectures. So in this query drop box, you can put your queries, and in the final session, we will address those queries. Okay. So, Shubham, you'll be giving now? Sir, actually, it's the continuation. So I invite Shubham Vijayvargiya. He's a mine planning expert from SK Mine. So I had already introduced him earlier. So please continue your lecture.
So, good morning all. I'm Shubham Vijayvargiya. I'm working as mine planning engineer in SK Mine. So, we will just discuss about some technology advancement in mine planning, what software we are using in mine planning and all. Yes. So we will move forward like introduction of mine planning, then mine designing criteria, what we are using, then mine development process, what is the mine development process what we are using, then mine design parameters, then short-term mine planning, long-term mine planning model, and then life of mine and rate of production plan. So I will just give a brief introduction about HZL. So we are India's largest lead and zinc producer. We are third largest silver producer globally. We are second largest lead zinc producer in globally, and we have world's largest underground mine in Rampur Agucha, and India's largest digital mines and synthesis coal mines. We have almost 75% market share of zinc production in India, and we have almost 25 years of mine life from today onwards. This is the introduction about SK mines. This is the longitudinal vertical section of our SK mine. As we can see, we have almost 12 lenses in our mine, among which this red color ore body you can see. This is the main ore body from where our 60 to 65% of production we are doing. Rest 35 production we are doing from auxiliary lenses like SK1, SK17, SK4 and all. We have almost 110 million ton reserve and resources, among which 43 is approx reserve and rest is of in resource contribution. Starting from 1990, we have discovered our resource in 1990. We have commissioned our project in 2000. From 2000 to 2024, we have from production start to 5.65 million ton. There was many technology advancement. Earlier we were using 7 ton LSDs, then 17 ton, then now 21 ton LSD we are using. Earlier we used to do 30 ton of trucks, then 50 ton, then now 63 ton truck we are using. So what is mining? As we all know, but with planning perspective, what is the mining? So, mining is extraction of valuable minerals safely and economically. While designing the mine, we used to take these two consideration in our top priority, like safety and economically. A mining process can be divided into these 5 pillars. First is initiating. Initiating lies environmental clearance, lease from government, like that. After taking lease and environmental clearance, we will plan the whole process, like how much the ore body, what will be our rate of production, 5-year plan, 10-year plan, like that. After planning process, we will do the execution. Operation is start, whatever ramp, shaft, whatever we are developing. Then, after establishing a complete mining process, we will make some system to control that complete operation. Then, mine closure plan. So we will move forward in this PPT, in this 5 pillar mainly. So why do we need mine planning? There are two major reasons of mine planning. First is, as any organization want to do maximum of their profit. So first is maximize the profitability. Second is to install confidence internally and externally. Internally means whatever we are planning, whatever project we are starting, there should be some like a limit. In 5 years, I will do this much of production. In 10 years, I will do this much of production. So within the team, to build a confidence, we need a mine planning. And externally, what is means, like in between stakeholders, who is investing in your company, you have some plan. You will show some plan that in 5 years, 10 years, I will move forward. So to build confidence internally and externally, we do need mine planning. There are 2 types of plan always. First is long-term plan and then short-term plan. A long-term plan, we can say, is the plan for the main proportional of the ore body. Like I have saw the LVS of our mines. So in mainland, 70% of the ore lies in that mainlands. So what is planned for that 70%? That is our long-term plan. Basically, more than 5-year plan is used to be long-term plan in our case. Short-term plan is step-by-step plan, like monthly plan, weekly plan, 1-year plan, 5-year plan, up to 5-year plan. We used to do in short-term mine planning. So mining cycle of SK mine, we can divide our whole mining cycle in this 6 process. First is development phase, where the mine planning process is 70% of our mine planning process. Then production phase. In development phase, again we can see 3 processes are there. First is exploration. So we have surface exploration and underground exploration. For surface exploration, we have Dyna, which can drill up to 1,000 meter. A hole can be drill up to 1,000 meter. Then further to build confidence, we have MCR and UCD for exploration purpose. We use 25 by 12.5 meter grid to build a confidence in ore body. Then after having some ore body shape, we use core logging, sampling and assaying to know the grade what grade we have. Then based on assay model or ore body, we used to make one block model. From that block model, we used to do stoping design. That block model used to divide into some parts. In our case, we have 2 type of stopes in our mine. Like first is 25 meter heighted and second is 35 meter heighted. So based on that ore body model, we used to make some stope design. Then after designing a stope, I will get to know that this much of production, this much of R&R I have in our mine. According to deck, I will decide the development. What development I need? Then crosscut drive. What is the size we used to adopt? Like which jumbo will come? Like that, resource planning and designing both part. Then after development and stope design, I will go up to production, drilling, blasting, then ore production, and then blasting. I will explain further in next slides. So, brief introduction about surface and underground exploration. So, for surface and underground exploration, we are using datamine software, datamine UG and datamine RM also. So, there are two type of model. First is resource model, and second is geological block model. Resource model is whatever I am getting from surface exploration, that is our resource model, which is used for long-term plan. And geological block model is whatever confidence I am getting from our underground exploration, that is geological block model. So we can see these are the hole which were drilled from the surface. These hole have three type of data. First is collar, second is litho, third is survey data. Based on these three data, those holes are being plotted in datamine software. Accordingly, wherever from assay data, wherever the ore was found, a ore body shape is being formed using that borehole data. The whole mine where I'm doing exploration, that can be divided into some grids. Like for surface exploration, we are using 100 by 100 grid, and for underground exploration, we are using 25 by 12.5 grid to increase the confidence level. So this is the basic process of block model formation. From that block model, two type of information we are extracting. First is geological information, second is geotechnical information. Geological information, what we are getting from that block model is basically ore body shape and grade distribution. In our case, grade used to vary from 2% to almost 7 to 8%. So the mineable grade is 4.5% basically. So we need to design the stope in very economically, so that I can manage my cutoff grade. So we can see, this is the picture of our block model. You can see different type colors in that block model. Red color you can see is the most high grade area, where 7 to 8% of our grade lies. Second is blue colored area, that is 6 to 7%. Likewise in cyan color and pink color. So this is the block model what we are getting from that exploration data. Second is geotechnical information. So when I will do the exploration, there will be some RQD also we will analyze. In logging data also we will analyze some things. So from that, some geotechnical information also we used to get. Like what is the rock type, at which depth, which rock is encountering. Like what are the clay zones, what is the RQD of that particular area, is there any structure in that particular area, or like any shear we can get from that block model. After block model formation, we will come on the stope designing part. So I will just spend 2 minutes on this slide. What is a stope? A stope is like we have hanging wall and footwall, two type of ore bodies there. In between, ore body will lie. So along ore body, that is the width. What terminology we are using? Along the ore body, it will be width. Across the ore body, it will be length. Difference between top level and bottom level is stope height. So how stope used to prepared? So whatever the block model I have received from the geology, based on our production rate, our payback period, at how much time I required the ore, first truck of ore. According to that, we used to design the stope. Like what height I need, I need to do. Like in our case, 25 and 35 meter. So from resource model, I will I will cut the ore body into some like finished dimension. Like in our case, 20 meter width we are using, 25 meter height and 35 meter height. Then on mine design part, there are some criteria, some factors what we are using while mine designing. So variables are ore body geometry. According to ore geometry, what method we are adopting, like according to ore body shape, transverse and longitudinal, both method we are using. We have some area where ore body width is like 30 to 35, 30 to 50 meter. There, in that area, we are using transverse method. While there are some areas where like ore body width is 5 to 8 meter, where at that case we are using longitudinal method. Then grade distribution. If grade is uniform, then I will go in transverse method. And if grade is like varying, then I will go to longitudinal method. Then strength of rock. If strength that has RMR, we have RMR, two type of RMR, like fair to good. In good RMR, we are doing underhand mining, and in fair RMR, we are doing overhand mining. Both type of mining we are using. Then ultimate mining method. There are some risk factor also. During exploration process, there will be some deviation, like there will be some deviation in holes, whatever we are drilling, and that quality is then ore body modeling and reserve estimation also. These are the some development terminology what we are using in our mine. First is capital development, and second is secondary development, or we can say revenue development. So there are two type of cost, capex and opex. So that cost has major part on mine development in our case. So it is highly required that we will optimize our development. So in capital development, what is the capital development is, that is whatever development, what we are doing in like on long term basis, on infrastructure, that has life more than 1 year, that is capital development. And every development that has life less than 1 year is revenue development. In capital development, like shaft infrastructure, footwall drive, ramps and all will come in capital development. And revenue crosscuts, what we are developing, like to reach up to the ore body, that will be revenue development. So we have two type of cost also, cost COPV1 and COPV2. In COPV1, capital development cost will not be included. In COPV2, capital development cost will be included. That will part of capex. So these are some mine design parameters. We used to design our mine in datamine software, datamine RM, datamine Studio UG. These are some parameters what we are using. So after developing RAM, we will let me explain one by one. In decline, we have 1 in 7 decline, what we are using. In decline, we have crossovers, like crossovers of minimum 15 meter length. At every 150 meter interval in decline, we use crossover to pass the vehicle and all. Then level access junction, all development from ramp, footwall drive and arc, that all are in arc shape only. Then pocket sumps we are using. At every 250 or 300 meter, we are providing pocket sumps to develop a decline. Then passing bay, then main pass as per DGMS regulation number 95 of 1961 MMR. We are developing main passes and get in box cubby also. Then again on mine design, previous slide was on, one second. Yes, previous slide was on up to ramp, up to level access, where we are reaching. Up to level access, what we are developing is lies in this slide. After level access, what development we are using is, first is level access crosscut. This is also 5.555 arc shape design, where LPDT is our maximum size of vehicle, that is LPDT can run. Footwall drives, then waste crosscut, ore drives, level sum, shaft access and airways shaft also. So this is the layout of our one of our level. After entering from ramp, level access, then we used to establish some mine services like power crosscut, like dewatering crosscut and all. There will be a ventilation crosscut for first, either it is intake or exhaust, whatever. So all the services will be developed in this area only. Then after developing services, we used to make a footwall drive. That used to be 30 to 40 meter from our ore body contact. Then we used to develop like revenue crosscut and all. These are some software what we are using in our mine planning process. First is data mine. In data mine, we have some version what we are using. First is Studio UG, Studio RM, Studio EM, AGs for drilling blasting, EPS for scheduling. So data mine we have 5 module. In Deswik, now we are moving from data mine to Deswik. We are in transformation phase. So in Deswik, we have implemented already UGN, CAD and UGDB. Now further we are going to implement scheduler, UGM and advanced survey. For SSR design and numerical modeling, we are using Flag 3D. For structural modeling, we are using Leapfrog, and for ventilation design, we are using VentSim. Then after mine designing, as I have told, we will enter into production phase. There are 2 types of model in, yeah. If we'll talk about that, then from underground exploration to final production, you are saying, right? Of that particular area. So that used to be within 3 months for underground exploration. I'm talking. Yeah. For surface exploration, it is 1 year. Yes. From there are two type of that we can see. From exploration to final production, it is 3 months for underground exploration. After starting a stope and starting and finish of a stope, that is 45 to 60 days. What we are doing at where. Yeah, 2 months, 2 to 3 months. So in production phase, we can divide our production process into 2 model. First is short-term model and second is long-term model. In short-term model, whatever production schedule we are doing is for quarterly plan or month plan. So based on short-term block model, whatever block model I'm receiving from underground exploration, from short-term block model to final monthly schedule, this is the complete process. These are the 5 things that is the requirement for a short-term model: grade, lithology, major structure, RQT, and mineralization. Then drilling and blasting design. So we are using 2 softwares on drill and blast design. First is Aegis and second is Deswik. In Aegis software, while designing a stope or a drill design, you need 4 type of file basically. First is mining boundary, second is ore body, third is central line of drill level, fourth is development, whatever development you have executed. These 4 files you will require while designing in Aegis. And fifth one is structural modeling, whatever data you have got from structural model, that will require in Aegis software. Now, what is the benefit of doing drill design in Deswik? Earlier we used to do in Aegis software, but now we are moving to Deswik software. What is the benefit is, you can design multiple stopes in a project while doing design in Deswik software. So that is, and you can also work 2D and 3D in Deswik software. While doing this Aegis software, you will do only 3D designs. So you can do both design 2D and 3D in Deswik software. These are some modifying factor on extraction of a particular stope. So if we can see, this is our planned mine boundary, and this is what the actual broken. So there will be some external and internal dilution also. So that you need to consider while planning the schedule. So external dilution is what? D, the that is indicated in red color. That is the external dilution. So what is the extraction is A plus B plus C divided by A, B, C and E. So A, B, C, whatever I have extracted, that is extraction. Overburden, overbreak, that is D part, with respect to A, B and C. Whatever I have planned, what quantity has overbreak, that is overbreak, like external dilution we can see. Broken ore tonnage is A plus D, extra broken plus whatever broken whatever I have planned. Then recovery plant, like how much of ore I have recovered and what was the plan, and what is the recoverable ton, recovery we can say. We used to see in, like we have 92% recovery in our stopes. 8% we used to lose in during mucking and during blasting also. These are some production schedules that were developed in EPS, like data mine EPS, like yearly production, monthly, 3-month production, weekly project. In production plant, we have 3-4 type of schedules. In every week, we used to reschedule our monthly plan. Like whatever delay is there in past 7 days, 10 days, whatever, we used to revise our plan on every weekly basis. Then month plan we have, then 3-month plan we have, then 1-year plan we have. Up to 3-month plan we have day-wise plan, and beyond 3 years, beyond the 3-month plan we have only stope-wise plan to build confidence in operations. I will just take 2 minutes on our shaft, SKM shaft. We have almost 1052 meter depth SKM shaft that has 2 compartments. The diameter of shaft is 7.5 meter. We have divided the shaft into 2 compartments by doing partition. One is for material loading, second is for manpower loading. On material loading, we have capacity of almost 3.75 million ton hosting per annum. Now we are expanding it to 4.1 billion ton per annum. Then speed of cage already it is known, 12 meter per second and 8 meter per second. Then we have a copy widener system for that. We have this you can see, like below 395 area is for production. We have established like 2 or 3 overpasses. Here are some overpasses. From this level to this level, ore will be dumped into overpass. Like we have almost we can say 300 meter length overpass. Ore will be dumped from that overpass. From here, LHDs are being used to dump that ore into crushers. So from overpass crusher to conveyor, we have conveyor in -490 MRL. So from conveyor, from here crusher to hopper, ore will go through conveyor. Then hopper to surface, it will be hauled to the shaft. So that is one of the deepest shaft in India. Then again on long-term model, short-term model was developed on geological block model, while long-term model will be developed on resource model. These are some long-term model what we are proposing. These are some design criteria for that. We have ore density of 3.2 meter, 3.2 ton per cubic meter, while waste density of 2.8. Broken ore density, including swelling factor, we are using 1.84 ore, 1.74 waste. Then stope designing criteria, as I have told earlier, footwall drive distance from ore body contact is 30 to 50 meter in good RMR area. Like in fair RMR area, below -85 MRL, it is 40 to 60 meter from ore body contact. Stope height, 25 to 115 meter we are using. Currently, and we are using 25 and 35 meter interval only. Stope length at a time we used to take 30 meter stope length. If ore body is greater than like 30 meter, then we used to take it in panels. There are some scheduling criteria. Advance per blast is 4 meter. In any decline, we used to take almost 90 meter in a heading. If there are multiple headings, then we used to take 110 meter. Like for production schedule, we have per stope per day is maximum 1500 to 2000. Production days in a month, we used to take 25 except 4 days. Production per crew per stope is 25,000 in a month. Paste fill rate, we are using 175 cubic meter per second. Long hole drilling, for long hole drilling we have one type of machine, DL421, that is solo, that can drill up to 50 meter of length. Then vent sim modeling. For ventilation designing, we have vent sim model. You can just see the 3D animation of ventilation designing. Red area, you can see it is return airway, while blue area is the fresh air intakes. According whatever quantity we will require, you can give the data to this Vensim model. He will design a ventilation model for that. One more thing, to drill a 300 meter approx, we can say 250 to 300 meter, we are using raise bore operation, which is also a big thing. Like we have almost 12 shafts what we have drilled in last 6 months from raise bore operations. A mine layout that consists of these 6 things. Then resource planning. Whatever I have designed, I have to bring some resources like some machines and all. For resource planning, we are using this time use model. So first is calendar time. What is the calendar time? Is 1 year time, whatever the 365 days. Then schedule time is extended loads are like public holidays in which mines are closed. So that is schedule time. Then availability time, what is the, at what time machine is available among that schedule time is the availability time. Then except like unplanned breakdown or planned downs, the time is available time. Then from available time, there will be some utilized time and some will be standby time. So utilized time will be for our mining operation. Then from that utilized time, how much the productive time and what is the operational delay. So final product is just real time. From calendar time to real time, this is the most working time what we are getting is ready time. So based on this time uses model, like if I will give an example of jumbo. In jumbo case, like our in business plan, what we used to consider is like 78% available time. On of that 78%, 21% jumbo utilization what we used to consider. So 21% will be utilized time, considering 113 meter per machine per month. We are using 113 meter per machine per month. We used to plan in that way in business plan. And we are achieving almost 105 meter per month per machine from like Sandvik Jumbo and M2Cs. And all. This is the LSD productivity curve. Then calculating mine life. So Taylor's formula we used to calculate our mine life, that is 0.2 multiplied by tonnage to the power 0.25. So based on this, our mine life is almost 13 years, we can say. And almost 21 KT per day production we are doing from an underground mine. So I will just spend 5 minutes on this slide. We are the most digitalized mines in India, we can say. So our digitalization can be divided into these 4 pillars. First is real-time monitoring, second predictive maintenance, third one is reliability improvement, and fourth one is advanced automation system. First, real-time monitoring. For real-time monitoring, which whatever machine running in underground, we have almost 250 machines at a time which are running in underground. So to track this much of fleet, we have to establish one like digitalized system where I can see where is my machine at that time. So for that we are using Optimine software. Optimine software used to provide us a 3D model of our mines. You can track real-time position of a particular machine from a digitalized mines control room. So that is real-time monitoring. Then predictive maintenance. We have installed multiple sensors in our machines, like in LPDT, in LSD, for solos also, for jumbos also. So that sensors used to capture the data, real-time data, like for example, like fuel oil, coolant temperature, whatever. So those data will be collected by a maintenance team in every shift end. Based on that data, only the maintenance will be planned for next shift. So that 1.5 hour between shift changeover time, it is very difficult for maintenance team to find out the problem. So that is helping us to identify the problem quickly and to resolve it quickly. That is predictive maintenance. Reliability improvement, that is also like tele-remote system, as sir have already explained. In between shift changeover time, we use our machines from surface. From surface, we can run almost 3 to 4 solos in a shift. So that has almost considering 45 meter per hour productivity, almost 100 meter they can drill in 2 hours per solo. Tele-remote operation for grade recovery optimization, for RFID network. Yeah, for RFID network, what I will explain is for diesel capturing. We have installed RFIDs in every machine and diesel pump station, that nozzle. So whenever machine will go to diesel pump station, though those two RFID will be in contact, then only you can fill the diesel in that particular machine. You cannot fill any manual diesel in any machine. Advanced automation system, then belt watch, digitalized DSR we are using. Optimine software also provides us digital DSR. Whatever the work has been done in last shift, you can extract that information on one click from that Optimine software. Thank you. Yes, sir.
Had you not done any digitalization there, so what would have happened?
You're right. Sir, it was if I will talk about last 5 years, like before 2017, there was no digitalization. So impact is, as I have told, tele-remote operation. In a shift, a solo can perform at stretch mark like 5 to 5.5 hours maximum. But after introducing digitalization, you can drill in rest. Right. Earlier, what we are using 5 to 5.5 hours of working hour for a solo. I am talking. Now, using tele-remote operation, I can use that 2.5 hours also. What I was losing in shift change over time. So that is directly additional to our productivity. Like for a one solo, we can drill up to 120 meter extra in a shift using digital process. Second is diesel, as I have explained. earlier what was happening, almost 10 to 15% of our diesel used to waste. Like people used to transfer diesel from one vehicle to second another vehicle in the underground. So that is being captured by RFID now. So that is improvement of 10 to 15%. Numbers. Yeah, productivity parts also. Yes. You can we can take actions on operators also based on that data. Availability improvement is there. 72% was the availability in 2016. Now of LPDT we are considering 79%. So on that part it is improvement. Thank you.
We have more time. We have more questions. So this is very interesting. The first and second lecture combined.
So like in leapfrog, like one in leapfrog and data mine, one master file is there. So every time you do not require to like upload a data. We just had it is automation. One what we can macro file is there. So we just have to run the macro file and the all data it will automatically select the data with the help of that macro. Means no need to rerun all things. If we run a model and we have need to add more data, when macro file is there, it will automatically search the data and it will clear the data in that file itself. Sub-level caving not there. Sub-level stopping, yes sir. Yes, actually for the stop purpose, we have one fixed pattern of that holes. So we having like 16 holes pattern is there. So first we are making a raise with help of that stop itself. And like one slice of raise we taking and then stripping along the boreholes. Like no separate raise is not there for the stopping purpose, but raises, main passes, that are there, but is not for the stopping purpose. For the stopping, raise is making with the help of. Yes, sir. No, actually stop for like stop. We have one stop is like this. Like one stop is like this hole, one entry is above, one entry is below. So and that gate is like a barricade. We have to prepare the gate, and we fill from the upper level, and it is filling goes up like.
I think I can understand in cut and fill mining
Yes,
you have
sledges for main person entry, not required. Yeah, we having like sir saying we have separate football drive. For every stop, we have one separate drive. Like you can see, edges is somewhere like you can see two edges here. Yes, for the ventilation purpose. And we have one football drive here, and this is the stop, the green one and the magenta one. These are the stop. Every stop different separate entries there, separate return is there. Like every stop have different returns. Like we are working at a certain depth, and we have to make our football drive safe. So we are keeping very far this football drive, 45 meter away from the main ore body.
What is the distance of barricade from the floor?
6 meters, sir. Yes, sir. Yes, for every, like, there is a restriction, like we have shown you vent seam. It is not like possible to calculate by some person individual. 0 cube. Like every level we have restriction. We can deploy only 3 loader or 2 LHD. It is like it. Yes, it is like that. No. In this plan, not only 2 ridges here. Like this is like intake ridges, but in the extremities we have the exhaust ridges is there. So intake will come from here and going to the extremities and going up to the surface.
We used to have ridges like ridges in football drive. From football drive, we used to make some ducting arrangements, and auxiliary fans used to be there.
Moving towards to this kind of mining method instead of cut and fill. So if you have any query, you can contact them. You can take their contacts also, and whatever issues are there, you can deal with. So yesterday also we spoke about blasting, ring blasting. So here the stoping will require ring blasting, not like what we are doing right now. Stripping. Right now we are doing stripping. Instead, what you will be doing will be ring blasting. So there will be a slot raise, slot opening, and then rings will be blasted. Can you show the yeah, this is how the rings will be. So yesterday there was a lecture on that. So all these details, I think that we will make it available. Please, I request कि आपका जो presentation है PDF form में चलेगा, वो इन लोगों को दे दीजिए. Advanced to extreme end so it will be made available to all of us. Souvenir में details नहीं है, it is just an abstract. Main ventilation it is only abstract will be available, but the details, the presentation, you can keep in your database over
स्पेसिफिकली एजिस में बोलेंगे. एजिस में हम लोग 4 टाइप की फाइल यूज करते हैं सर. फर्स्ट इज माइंड बाउंड्री, सेकंड इज ओवर बॉडी, थर्ड इज डेवलपमेंट ड्राइव, फोर्थ वन इज सेंट्रल लाइन, रेफरेंस लाइन, व्हाटएवर यू यूज. Yeah, drilling level. From where either in up hole or in down hole. From drilling level.
वो imaginary line रहेगी क्या सर? क्योंकि आपको और बड़ी सीधा रहेगा.
नहीं सर, उसमें सर्वे का डेटा आता है सर. सेंट्रल लाइन सर्वे एक सेंट्रल लाइन लेके आता है हमेशा डेटा, उसी से.
वो जो लाइन बोल रहे हैं ना सर,
लाइक डिजाइन लाइन की बात करेंगे तो वो एक स्ट्रेट लाइन होगा सर, बट देयर विल बी सम लाइक डेविएशन, कुछ ओवरब्रेक भी होगा, कुछ अंडरब्रेक भी होगा.
उसी के पैटर्न में फिर रिंग को डिजाइन
बिल्कुल.
Okay, any more questions? Okay, then we will move on. So please request Pradeep Kumar and
चालू है ना, इसमें क्लोज कर दो, कंटिन्यू चलते हैं.
I would like to call upon Director Finance, MOIL, Mr. Manganese, to felicitate all the speakers from Hindustan. Thank you, sir, for facilitating them. Now we move on. Actually, not to avoid much waste of time, we decided we'll serve tea here itself, so that we don't have to go outside. So now we have our next speaker. I would like to invite Mr. Nagesh Shenoy. He is Executive Director and Unit Head of Manganese Copper Project of Hindustan Copper Limited. Please come, sir. So I will read his brief biodata. Mr. Nagesh Shenoy, after completing his BE mining from Bangalore University, joined K3 Copper Complex of Hindustan Copper Limited as GED and was posted at Kolihan Copper Mines. He has obtained the first-class mine manager certificate of competency in unreserved and unrestricted category and conducted by DGMS in the year 1998. He has vast experience of more than 33 years in both open cast as well as underground methods of mining in both public sector as well as private sector mines. He is a lifetime member of the Mining Engineers Association of India and has served as secretary of the Bellary Hospet chapter of MEAI for more than 4 years, during which period he has organized several technical seminars and an international seminar. He has also obtained a master's in finance, MBA, from Sikkim Manipal University in the year 2009. Presently, he is working as executive director and unit head of Manganese Copper Project, Hindustan Copper Limited. So he is now from Rajasthan. We are coming to much closer here. So here also they have a success story to tell. So Mr. Shenoy, he is the unit head of Manganese Copper Project, and he will be presenting the blast hole stoping design they have done there and the success they have obtained when they moved from open pit to underground. So over to you, sir. Thank you.
Thank you very much, sir, for your introduction. Good morning, or good afternoon, everybody. It's nice to see, even on the second day, such a nice crowd here, everybody interested and asking good questions also. whatever I'm going to present today is not any research paper or something like that. It's a case study of what we have actually done at Malanjkhand Copper Mine. A story of a unique mine. Why do I say unique? Because this is the mine which is a flagship mine of Hindustan Copper Limited, which contributes to 70% of the revenue of the company. It is a mine which was initially an open cast mine. We have transitioned to underground mines seamlessly. By the word seamlessly, what I mean is we have done conversion from open cast to underground without any break of production at any cost. And over and above that, we have even achieved a record production since the inception of this mine. So this is a success story of this unique mine, which I'm going to present to you. This mine has got a very long story. More than 100 years before this lease was granted to Hindustan Copper Limited. During the British time itself, from 1872 onwards, work has been going on in this area. Several agencies have worked here. Several personalities have worked here. Several departments have worked here until the DMG of Madhya Pradesh has worked. And then finally, in 1973, this lease was granted. Hello? This lease was granted, am I audible? Yeah. This lease was granted to Hindustan Copper Limited. Until then, a lot of work has been done on this mine, on this geology of the mine. Even after that also, a lot of drilling and all that has been done. This is the initial stage. The total acquired area of this project is 2016 hectares, and the mining lease is 479.9 hectares. This mine was originally designed by RTZC, and it was planned to produce around 58 million tons of ore at the rate of 2 million tons per annum with a life of 32 years, including the pre-production period. Along with that, a concentrator plant also was planned of matching capacity, and the mine and the concentrator plant started production in the year 1982. It was inaugurated by the then Prime Minister of India, Srimati Indira Gandhi. And as of 1st of April 2024, we have produced nearly 86 million tons of production, out of which 82 million tons is from open cast. Planned was 58.8 millions. We have produced up to 82 million tons and 4.25 million tons from underground. This is what you're seeing is the original plan, which was designed by RTZC for mining up to 376 MRL from the surface, a depth of 204 meters. And let me tell you, when this mine started, it was conceptualized that it will go underground at a future date. So in 1992 itself, a detailed study was done by Mishi Metal Exploration Corporation, and a detailed report also was submitted. Then what happened? There was a delay in the commencement of the underground mines. So what happened was, we had reached the limit of production, but as I said, this is the flagship unit of the company, and 70% of the revenue is generated from here. We could not stop the production from here. If this stops, the company finances are affected. So we had to redesign. So MCP, our internal team, redesigned this mine in the year 2009, and we added 10 million tons of this production to this 58 point. And so we went up to 68 million tons at 1.2% grade. That was again, we increased the depth from 376 to 340. And this was planned that with this, we can at least survive for another 4 to 5 years. Then finally, on 30th of September 2011, the underground expansion plan was approved by the government. However, due to some statutory clearances, delay in statutory clearance, we could not commence the underground mining. A tender was floated, and then LOA is issued in 2011. However, due to the delay in statutory clearances, the underground development could not be commenced. So we had to again go back to the drawing table and find out how we can sustain the production. That is when we roped in Indian Institute of Technology, Kharagpur, and then several designs were made, ultimate pit designs were made, and another 10 million tons was added with the plan to at least continue mining from and do the production from open cast till the time underground development and production is started. These are some of the pictures of the open cast mine, how it was in 82, then 2007, and the present pit. Now coming to some important milestones of MCP as we go from open cast to underground. In 82, ore production started. In 92, hydraulic excavators were, shovels were introduced. In 2009, 100-ton dumpers were introduced. In 2015, the development of the underground mine started. And then in 2022, the production from underground started. So after the statutory clearances were obtained, the contract for the underground development was awarded on 9th of April 2015, an EPC contract, which included a lot of infrastructure development, including the declines, the shafts, the level development, ore passes, crusher chambers, and all the other infrastructures. The main infrastructure included a service shaft, which was 665 meters of depth, production of 6.5 meters dia, a production shaft of 695 meters depth and dia of 7 meters, and then there are ventilation shafts at the two extremes of the ore body, and then declines. Decline of 1:7 gradient of dimension 5.5 by 5 meters. Decline is presently used for hauling of the ore from the mines to the surface because our shaft is not yet equipped. We are in the process of like tendering for winder. It's already tendered, winder and shaft equipping and all that. So as of now, we are doing our production from the declines itself. So what I want to show here is a surpack image of the entire mine. We have got the open cast mine, and below this, whatever development we have done as of now, the stopes which we have extracted, and the decline development of north and south. And these are the two ventilation shafts. This is the service shaft. This is the production shaft. All the 4 shafts have been sunk and lined. We are waiting for the tender to be opened, and the work for this, equipping of these 2 shafts and the installation of winder is going to take place very soon. So what, in the open cast era, we used to use the AutoCAD software for planning. Now we have introduced Surpack for underground, and all the planning right now is done through Surpack. This is the LV section of the entire mine. What you see here is the outline of the open cast mine. This is the bottom of the open cast mine, 340 MRL. Below this, we have left a crown of 40 meters. And then after that, there are levels which are opened here. I think you can see from. Yeah, this is the first level, 296, just below this crown pillar. And the level difference of the first and the second level is 60 meters. Subsequent levels, it is 75 meters. The entire design of this is done by IIT Kharagpur. Now, as I said, there are ore passes, waste passes. It is planned to install crushers over here. There will be 3 crushers at the bottom, each of 770 tons per hour capacity. And this is the production shaft and service shaft. Service shaft will have cage, a double deck cage of 100 men capacity. And the production shaft will have 4 skips. And the hoisting capacity of the production shaft will be 1540 tons per hour. These are the 2 ventilation shafts, which are at the extreme, and we'll be having the ventilation fans over here. As of now, these declines have been developed. The north decline. Blast furnace like grinding and supplying is in bulk.
So actually, one point is that when you design a base plant, you have to decide what is the source of the material and the raw material. So
In the calculations for the finances of this holder had taken, he had considered BSP itself.
okay,
He had considered BSP, transport from BSP to our unit and all that. On that basis only we have done.
Hey, sir, question is, sir, after how many days later we are extending the secondary stove? Like how much clean time we are giving for like one?
Because we have not reached that stage. We are filling the primary stove.
Okay.
We have taken secondary stove where the ground pillar is more than 60 or 100 meters.
Because, sir,
I would like to say in North Mine they have very good RMRs, 70 to 80, and not many difficulties are faced, and that's why they have gone for PSPS in one of the section there.
Where the ground is big, 60, 70, 80
Ground
meters.
is more than that.
But what he is asking is different. Paste fill ka strength.
strength पूछ रहा हूँ मैं.
अच्छा, strength you have asked.
1 MPa, 1 MPa, 1 MPa is the 1 OPC and 9% GGBS. GGBS have high calcium content.
Only 1%.
Pozzolanic activity is high. Hydration index is
For
low.
the plug,
That
it will be
9%
increased.
is flow.
For the plug, it is around
No,
3 or 4%.
the minus 20 microns is supplied by OPC. That is the only thing. Coarser particle is getting it from GGBS. That is why they are using 1% OPC.
They have done for first plug they have done.
Actually, it's a binder only to
Just to
reduce
find the
the
minus 20 microns, they are using.
tailings. Only to reduce the fineness of the tailings. You can use cement itself. You don't have blast furnace like you can use the cement itself. It may increase the cost.
No, it will increase the
It
cost.
may
Not
because
may.
no, nowadays what we are getting is almost equal.
You say 43 grade means if you are getting a long-term MOU with this thing, yeah, then I think the cost.
That time, and if you have a plant, in-house plant, definitely.
Yeah, then it's okay.
Thank you.
For ventilation, we have two railways on boundary.
Yeah. For ventilation, we are having 2 ventilation shafts at the extremes, and then that is 6 meters. Yeah. And then the declines, as of now, the declines act as the intake, and the shafts act as the exhaust. But our main fans will be coming in another 6 to 8 months. Fans will be installed at both the ventilation shaft. Then what will happen is even the service shaft and production shaft with the declines will become the intake. And we have engaged Professor DC Panigrahi for the ventilation design. So after his study now, what has happened is he has recommended 2 more raises, 4 raises, 2 for intake, 2 for exhaust. So that will be maybe another 2-3 years once we go still deeper. Now we are mining from the first level, the second level we are doing the production between first and second level, and we are doing the development over here, and we have gone to the drill level of the bottom one, and then this has gone, I told you, south has gone about 1.6 kilometers, north has gone 2.5 kilometers. So we have yet to reach the bottom. So till then we'll have to install our fans.
One more thing is, I would like to add that right now they are operating the first level, and their backfilling system has just started now. So right now they are doing with lot of precautions, like
Yeah.
60 meters
Yeah.
they are leaving and mining. But in the subsequent levels there will be lot of changes.
Changes.
Stoping parameters will require lot of changes, because when you have a full-fledged backfilling system, then your lots of options will come. So their target is 5 million per annum.
Yeah.
Then I think we
We are confident that by 28-29 we'll be achieving our 5 million ton target as what we have planned now.
So it's an interesting mine. I think I personally would suggest that those who are working in oil, those are delegates here and the senior management, they should visit this mine. At least in batches we should visit. And there's one more mine I will definitely would like you to visit is the Rajpura Dariga mine. Because they have very difficult rock mass conditions there. In their north load, in fact, you can even push your hand through the rock. Still there, they are doing mining. They are sloping, they are doing sub-level sloping, blast-hole sloping, all they are doing there with the help of shortcutting and split sets and wire machine. They are supporting the roadways, and now they are doing the mining. I very much recommend you should visit Rajpura Dariba mine. and that's a very treacherous mine. So you should see that. And already some officials have visited Impa, Mahagiri mine. That is also highly fractured rock, highly jointed fractured rock, very similar to your manganese mine. It's a small mine.
And they are using hydrophil.
They are using hydrophil with sand because they don't have mill tailings available there. With river sand and cement, they are doing it. So, and there also they have a stope height of almost 50 meters, 60 meters, and the stope wall stands very much stable for several months together because they are mining is a little bit slow. They have restrictions in production. They cannot increase because they have planned as a capacity. They have restriction in sale also, but I think now it's a little bit relaxed now. But their plant capacity is now the major bottleneck. So they are doing very slow mining, and this wall is standing for many months or even years together. So you can visit these mines and learn from them, because we need changes now. we can see that some changes has to be done. So for that, this knowledge, this experience, will always help. I'm really thankful to Dr. Shenoy for coming here and delivering his experience of the Malanskan copper project. So I would like
just 2 minutes.
Yeah.
Yeah. For hydrophiling was tried, study was done on that also. But for this method of mining, where we have to, where there is no pillar left, paste is the only option because it has to stand that length also. We can't give any ore in situ. So this was the method which was recommended. And as John sir said, I personally invite everyone to come and visit our mine. It's a lifetime experience for everybody. Please do visit us. And this success story wouldn't have been possible without a good team and the support of institutions like SINFER, NIRM, IIT Kharagpur. Thank you very much, SINFER, also for giving me this opportunity to present here. Thank you.
I would like to request Kariya Saab to felicitate him.
Excuse me, sir.
Thank you, sir, for helping us with the felicitation. And thank you, sir, for your very good lecture. So, now moving on, we have time, still 1 hour time left for lunch. So, I would like to invite my colleague, Sri Prashant. He is a senior principal scientist at CSIR SINFER. He will be delivering.
दिख नहीं रहा HDMI
सर आप वहाँ जाइए, वहाँ जाइए।
Hello. 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 While this is taking place, I would like, at the outset, I would like to thank the organizer of this workshop to. It's okay. नहीं वो लगता है नहीं they are doing it.
Yeah, meanwhile, I will read his biodata, brief biodata. Sri Prashant, he obtained B.Tech in mining in 1996 and M.Tech in open cast mining from Indian School of Mines, Dhanbad in 2000. Sri Prashant joined mine backfilling department of CSR Silver as scientist in December 2001 and is presently working in the same department as senior principal scientist. He has completed about 130 R&D and consultancy projects. He has 29 research publications to his credit. He is extensively engaged in the area of underground mine backfilling, paste backfilling, rock mechanics instrumentation for strata control, environment-friendly disposal of industrial waste such as coal ash, slag, etc. in underground and in surface mines, and computer-aided designing. He has received National Award for Fly Ash Utilization by Ministry of Power, Ministry of Environment and Forest, and Department of Science and Technology for R&D on the use of fly ash for stowing in underground mines. So,
मैं दे रहा हूँ.
प्रेजेंटर भी चाहिए.
अभी था ना प्रेजेंटर.
Hello, very good afternoon to all of you. And at the outset, I would like to thank the organizer of this workshop for inviting me to give a talk on mine backfilling and in underground metal mines. So I'm just skipping to the main topic. And so, as part of my presentation was made by Pradeep in the initial stages, so it will be like helpful for me for the explaining the second part. My presentation will be divided into three parts. First, I will be focusing on different types of backfilling, which is the practice in underground metal mines. And then I will be focusing on the two types of backfill, that is the paste fill and the hydrofill. And then I will be going towards the different kinds of studies which have been carried out in our laboratory to characterize the material for backfilling purposes. So this is the brief layout of my presentation. So going in the first part, what is a backfill? So as told already, anything which if you take out a material from underground, it has to be backfilled. So that is the basic definition of backfilling. It can be a one material or a mixture of materials, different materials. So the then depending upon its function, the backfill is divided into basically two types. One is bulk backfilling and another is exposable backfilling. So bulk backfilling is mostly uncemented backfilling, and the main function of this bulk backfilling is for waste disposal, number one, to provide confinement, for ground control and to prevent subsidence, and to prevent wall closure. It doesn't have any cement on it. So it is not an engineering product. It can't be changed. It can't be designed. It is just like a bulk filling and just for ground control. The second part, that is the interesting part, is the exposable backfill. Under this, all the cemented backfill comes under this, category. So it consists of cemented materials that are placed into stopes where the fill possesses sufficient strength. Why we need a sufficient strength? So as many of the speakers have told that when the primary stopes is excavated, then secondary stopes will be excavated, then it has to have a self-standing height. It has to have self-strength. So what are the strength? It should be having some cohesion value. It should have some uniaxial strength value. Young's modulus and Poisson's ratio is one of the important parameters that has to be considered. So these factors are of prime importance when it comes for cemented backfilling. Usually, way back in 1950s, before that, filling was usually done simply by adding fill material to water, and it was hydraulically stored or maybe pneumatically stored or through conveyor belts. But since 1950s, all the paste fill, rock fill, sand fill, and aggregate fill was added. Cement was added in its prefix. So it all became cemented backfill, cemented aggregate fill, cemented paste fill. It was categorized like that. So moving to the next slide. So these are the few famous methods, which is prevalent in India, which uses backfilling in conjunction with stoping method with conjunction with backfilling. So overhand cut and fill, underhand cut and fill, it is well explained. Some of the SK mines and Rajpura Darima mines is using it. And then comes the delayed backfilling methods with sub-level open stopes, shrinkage stope, and room pillar. Sub-level open stopes have different variation in India, like some of using blast hole stopes, some are using VCR methods, vertical crater retreat mining, and all that. So as you must be knowing everything, like first they do that primary, secondary. This is the usual scheme for backfilling with cemented backfilling. It's like primary stopes are excavated, then secondary stopes are left, then the third, like 1, 3, 5. 1 is the primary slopes, then 3, then 5. These are attacked first, and then subsequently 2, 4, and 6 are taken. This is a sequence of extraction. By now, it is well known. If you have any questions, you can ask me now. Because after the primary stopes is excavated, it should have strength to self-stand. That is the main. It has to have a strength to withstand the exposable height of the stope. So this is the major system of mining which is used in conjunction with backfilling. So now coming to different types of backfilling. I think this has become Chinese, I don't know how, but it was gravity and it was pumping. This is pumping. I don't know, it's like some error is there. So there are, like a human body, there are 3 parts of a backfilling system. One is the heart that pumps. So heart is represented by the mixing plant, where all the ingredients of a mix is prepared. So ingredients what are the ingredients? Ingredients is water, ingredients are tailings, ingredient will be sand, ingredient will be OPC, ingredient will be replacement of OPC like slag or maybe fly ash. So these are the ingredients which are the main, which are used to form the fill material. And then the distribution comes. So distribution comes with we have to find what is the horizontal extent where it is to be distributed. What is the head available? So if suppose the depth of the mine is good enough, then the gravitational head is enough for transporting the fill material. So depending upon that, we decide what kind of transportation system we need. Either through gravity itself or we need a pump, because if the horizontal distance is like 2 kilometers, or maybe 3 kilometers, and if the vertical distance is like 1 kilometer, so the gravitational head won't be sufficient to push that fill material to the extreme end. So there comes the difference in the head and the extreme end is provided by the pumping system. So we actually do the hydraulic profile and hydraulic gradient. You must be knowing of that. Do you have an idea of hydraulic profile or hydraulic gradient? So hydraulic profile and gradient is like that. From the what is the head we are getting to the extreme distance, we draw a straight line. That is the head available, and the profile is the profile of the pipeline. The pipeline profile should not get the hydraulic head, because if it cuts the hydraulic head, there will be stagnation. The flow will be it will be blocking the flow. So that is the design criteria. Then after it is placed to the stopes, what we do the dewatering, densification and monitoring part. The monitoring part usually consisting of monitoring of the both paste plant as well as the monitoring of the at the barricades and and the stopes itself. So this is a brief schematic description of different types of backfill thing. So this is the rock fill, this is the hydrofill, and this is the paste fill. As you can see, as you are seeing that in hydraulic fill, in cemented hydraulic fill, we need a complicated barricade system and a good drainage system, because the ratio of water is like we put generally 70 to 75% solid and remaining 30 is water. So we need an elaborate drainage system for hydrofills. That is not the case in paste fill. In paste fill, the barricading system is kind of simpler, because the load coming on the barricades are less, because the hydrostatic pressure buildup is less, and most of the water which is sent in paste form, like 85% concentration is solid. So as told by Pradeep, it is used for hydration work, like cement hydration. Calcium oxide to calcium hydroxide has been formed as a cementing material. So there is no need for any hi-fi drainage system. And then comes the rock fill. So what is rock fill? Rock fill is what we get from the mines when we drive or like a crosscut, or when we have a drive edge. The material which is produced from the mine itself is used as a filling material. So here we see the development is going on, and it is going to the LVDTs, and it is directly going to the underground mines. So and it is not like that. Rock fills can be used both in primary stopes as well as in secondary stopes. And in primary stopes, they usually mix the rock fill with hydrofill. So hydrofill is what? Hydrofill is mixture of tailings and cement. It forms the matrix. Okay, it forms the matrix within which the rock fills are placed. So we need suppose in the primary stopes, what is done, like rock fill is placed beforehand, and then hydrofill is placed, cemented hydrofill is placed. The main purpose of cemented hydrofill is to form the matrix. And in certain cases, what happens that initially the hydrofill is placed, and then the rock fill is placed to form a mesh, like a matrix form, to have adherence between different boulder size of the rock fill. So usually the ratio of hydrofill to rock fill depends upon the kind of strength you need. So that is the main governing factor in the ratio of mixing of rock fill and hydrofill. So this is and usually what the mine people do is that in primary stope, usually they use hydrofill, cemented hydrofill and rockfill mixture. And in the secondary stope, they usually just fill the secondary stope with rockfill without any adding cement to it. It will reduce the overall cost, because secondary stope doesn't require a free face, because it is already filled with, which like adjacent side will fill with cemented fill. So that is not the important thing to do. So when we come to hydrofills, the main factor is which has to be taken care of and underground is to form the barricades. Okay. So in bulkhead generation, two things is to be done. One is the one we have to find out the plug, and then we have to design the barricades. So during plug filling, it is not that instantaneously the plug is filled up to 7 meters height. It is done in casual cycles. Why it is done in cycles? Because if you put instantaneously 7 meters of plugs filling, then the pressure at the barricades will be very high. So what we do it fill in cycles. Suppose the design parameters of a barricade is 250 kilopascal. And what we do, as told by Pradeep, we have contact pressure cells over here. We monitor the filling, monitor the pressure which is coming on the pressure cells, and during the filling and post filling also. So if the design strength is like 290 kilopascal, and if the reading is like 200 pascal for during filling, then the filling is stopped, and when the pressure reduces to another like 150 kilopascal, then again the pressure, this bulk filling is done, like this thing is done. So that has to be taken into account while forming the plug. So plug is usually having more cement because when it solidifies, it takes all the load from the bulk fill. So this is very important because it takes the load on the barricade coming after the filling of plug is less when you compare to plug fill. So that is the thing. So in plug fill also, here there are decantation towers, decantation pipes, corrugated pipes having perforation on it, and it should be laid before the sewing operation start. The pipeline should be laid from the top level to the decantation level, and there are different perforated pipelines also, which dissipates the water during the plug formation. So there is a combination. But in case of paste fill, that is not the requirement because the water is very less. So these are the decantation pipes, as you can see. So this is the rock fill, and this is the aggregate fill. And in filling, the most important factors which we consider is the size. The size does matter in case of backfill material. So this is the thing. Next slide. So what are the different criteria, difference between high density fill, low density fill, paste fill, and rock fill? This is usually the placement state is like 50 to 60% solid by weight is used for low density fill, is classified for low density fill. 60 to, actually it is 75. 75 is for high density fills. 75 to 85 is for paste fill. That is the solid concentration. And in rock fill, it is dry. So underground transportation is either through borehole or via pipeline or through gravity. For high density fill, it will be cemented, and for low density fill, it is uncemented mostly. Paste fill, it is like through borehole, via pipeline, through gravity, or it can be pumped also, depending upon the horizontal distance it has to travel. Then rock fill is done by raise, winch, or mobile equipment, LBDTs, or conveyors to use for transporting the waste material to the voids. So binder application is, as I told, it is uncemented for low density, high density is cemented, as well as uncemented depending upon the end use. Then the cemented only is, paste fill is cement only, OPC grade 43 is used. And pozzolans, why we use pozzolans? Cement actually contributes 75% of the total cost of backfilling. So mine management usually try to replace with the binder alternative like pozzolans. What are pozzolans? Pozzolans are siliceous or aluminum siliceous material having free lime. When it contact with water, it produces cementous properties to increase the overall strength. So usually all the mine management are replacing sand with some extent with pozzolan material. And rock fill, as told, it is uncemented, but it is used in combination with cemented hydrofill. So water to cement ratio. Water to cement ratio is an important factor which we have to consider with respect to the strength development. Suppose if the higher water to cement ratio, the lower is the strength, so, and vice versa. Paste fill has got low water to cement ratio, so that is why the strength development by the paste fill is very high. And similarly, is suppose cemented fill is either rock fill is either 1:1 hydrofill and cemented hydrofill and 1 rock fill in the ratio 1:1 or 3:1 depending upon the strength requirement combination. The placement rate is like lowest for low density fill because the density is less. Suppose 50% solid by weight, so therefore the filling rate is also less. Similarly, it goes to 100 to 150 for high density fills. Usually, it is a general average filling rate, and for paste fill, it might go to 250 to 200, depending upon what is the requirement. So, this is now it has been increased to more than 200 recently. It's like with improved pumping capacities, and for rock fill, it is 100 to 400. And now it comes to segregation. What is segregation? So, if the water is high, what happens that the finer particles, it moves to a larger distance because it is the water content is high. In case of low density fills, what happens when you put the pore into the voids, the cement being lighter flows away from the point of pore. So if you take out the cores from the backfilled area, we won't get even strength. It will be the strength is not even because of the cement segregation. Here in case of hydrofill, that is the maximum thing. But in case of paste fill, that is not an issue because the solid content is high and the cement is evenly distributed within the fill mass. So it is more reliable. As Pradeep told, it is so reliable that they can drive a haulage road inside, they can drive a working road inside it. And for rockfill also there is segregation. So why is the segregation in rockfill? So larger size boulders like 13 centimeters, 15 centimeters, they fall in the same range. But the beach formation for smaller particles like aggregate fill kind of thing, they move to a greater distance inside the stope. So the density of packing is very different. So that is the main issue for rockfill. So to eliminate that, they should have different points of pouring to increase the evenness of pores. So that is the thing. Stiffness, low density fills like slurry fills have got low stiffness because of the segregation in cements and all that. And paste fill has got low to high, and rockfill has the maximum stiffness. Grain size, now grain size is like top size is 2 mm and usually not more than 10%. Why we need, usually hydrophils usually is having, there is a thumb rule that 10% of the particle should, 20% of the micron size should not be more than 10%. Means like the final particle should be restricted. Why it is restricted? To have a percolation rate of 10 centimeter per hour. If the percolation rate is 10 centimeter per hour, then 70% of the water percolates out from the stope. If it is a thumb rule, we found what we do in the laboratory is we do what the constant head permeability test, and we found out what is the percolation rate. If it is more than 10, then we can go for this hydrofill on the basis of the results. And so 15 in paste, we need 15% of the particle must be finer than 20 microns. So when we mix sand or water, and when we pour inside, when we pour the water and sand slurry, what we see a segregation, quick segregation. So there is no retention of water in the rocks, in the coarser particles. So what is the difference between paste and the normal fill is that paste is having 15%, what sir has told, that it needs finer particles. Why it needs finer particles? Because it traps water inside the voids. So what is the function of that? So when the water is entrapped into the fine particles, it forms a lubricating material. And the flow inside the pipeline is a plug flow, with the finer particles going to the periphery and the coarser plug being in the center of the flow mass. So it acts as a lubricant. And if it is fine, it will retain the moisture, which is very important for transporting. So that is why fines and total tailings are required. We are not classifying any tailings while using paste fill. So binder quality requires a large number of binder for low density fill because it gets segregated. So we need more cement for that to achieve the same strength. So binder quantity is usually low for paste fill because for lesser cements, as the cement is evenly distributed, we get the same strength. And for rock fill, usually, binder is for moderate binder quantity is used, and basically the binder quantity is provided by the hydrophils. So barricade is very expensive for low density slurry fills and cemented fills, which is inexpensive for paste fill because in paste is a highly viscous material. So we need only muck and a little bit of shotcreting. That is good enough to retain the paste fill. So the cost is less, and moderate binder and rock fill it is not necessary. It's like for barricade because it itself retains the angle of repose of the material, forms the end of it. So water runoff is excess for hydrophils, and there's a lot of pumping costs involved. Water runoff is negligible for paste fill, and no water runoff is for rock fill. So capital cost, the highest capital cost is for paste fill. Initial capital is like 100 crores. SK mines, they have used like 100 crores. But for hydrofill plants, the capital cost is relatively less. And for rock fill, it is moderate capital cost. Operating cost is lowest for cemented fills like paste fill. And operating cost is very high for hydrofills. And high operating cost is for rock fills also. Just summary comparison between the paste fill and the hydrofill. So slurry fill is classified as low and to high density solids. Low means like up to 60% solid by weight, and 60 to 70%, it is 75 actually, 75% solid by weight for high density cemented fill. So it is transported in pipelines through high vessel velocity. So there is a formula by Condoleezza and Duran and Condoleezza which founds the critical velocity. What is the critical velocity? Critical flow velocity is that velocity below which the materials start to form a layer inside the pipeline. So the flow is, this is the kind of homogeneous flow when the concentration of the particles are evenly distributed across the cross section. Second one is the heterogeneous flow where the concentration of the particles are on the higher side at the lower end of it. Third is the saltation flow where the particles is moving in small jerks, like little bit jerks and all that. But there is no layer formation at the bottom of the pipe. The layer has no of solid particles. And the flotation with stationary bed is that kind of flow where the velocity, critical velocity is the slurry is flowing just at the limiting critical velocity, and there is a layer formation at the bottom of the pipeline, and the area of cross section is getting reduced because of the layer formation. So what is the ideal thing? The ideal thing is that the material should flow in a heterogeneous manner throughout the having a uniform concentration distribution along the cross section. What is paste fill was first used in grand mines in Germany in 1980s, and it is just like akin to a toothpaste. So what we use in the morning when you go out, when you do like this, the toothpaste, it does not fall itself. We need to squeeze it, okay? That squeezing is called yield stress. I will be coming on that later part. So before the yield stress, before the paste attains the yield stress, it remains inside the Colgate, inside the tube. So that is the thing we need to have a minimum stress which requires the paste to flow. So what is a slump test? Slump test is the test which has been carried out in the lab which determines the consistency of the fill. It is an inverted cone. I will be explaining in the later slides what is a slump and how test will be carried out. And as per Golder Associate, a paste can be defined as a mixture of solid and water that has no water bleed when kept idle. That is the standard definition from Golder. So what is the difference between the two methods? Paste fill, low permeability with little or no water bleed, hence binder and leachate washout is reduced. So there is not an issue of leaching because usually the environmental people usually are concerned with leached out water. So in case of paste fill, that is not an issue because water is very less. Reduced mining dewatering cost as water is less. Enhanced filling rate because high concentration. Hence mining cycle time is reduced. We can go because of the enhanced filling rate. Laminar flow in pipelines reduces wear and tear because as I told you earlier, finer particles is in the periphery, so the wear and tear of pipelines is very less. Usually they use seamless pipes for paste fill, that is having high endurance for pressure gradients, and prevents possible liquefaction. So what is liquefaction? Liquefaction is a phenomena which like when you pour a material, slurry. So between the pores there are water inside it. So they exert a pressure, that is called a pore water pressure. So when that solid mass having saturated or partially saturated with water, if it is fully saturated, all the interstitial particle spaces are filled with water, okay? And when the dynamic loading comes, like cyclic loading is coming, so what happens that at an instance, when the resonance is there, so particles is vibrating with the natural frequencies. And when the frequency, external frequency, like from blasting it comes, so the whole mass becomes fluid because the pore water pressure exceeds it, the limiting, the confining pressure. So the whole mass becomes fluid. So that is the main thing, that is the main danger for low concentration fills. But in case of a paste fill, that is not an issue because whatever water is there, that is for hydration and all that. Prevents possible liquefaction is there. So what are the hurdles for this paste plants? So high initial investments. Usually mine manager doesn't want to put their money before they get the returns. So that is the main thing. strict PLC control is required, because PLC is very important, because a slight change in the moisture content, a slight change in the moisture content of a paste fill produces a huge change in the pressure drop. So that is a very important to be noticed. So they should have a strict control of what are the ingredients getting placed inside for making a paste. So that is very important. And relatively new technology and many technical aspects are not fully understood. But I think people are learning from their experience as of now. And so slurry fill is relatively simple, small infrastructure, less operating cost, requires minimum technical supervision, lower capital and operating costs and all that. This is simple for hydraulic fill. So what are the hurdles? Excessive water needs to be recovered and pumped, so pumping cost increases and all that. Reduced fill strength due to cement water segregation, already explained. So increased, because some of the slimes which get through the decantation pipe, it has to be pumped out, so the cost increases in that respect. Bulkhead dewatery facilities construction and curing process interrupt the mining because of the low cycle, higher cycle time of the hydrofill. The mining cycle increases and the production, there is a loss in production. That is the thing. Now, I will just touch out the design factor. What are the designing parameters which are taken into account for designing a slurry fill plant and designing the paste fill plant? So, first we will look out the mining environment and geological condition at the site. Okay. So, what are the mining environment? Mining environment is rock condition, including the hanging and footwall, the host rock and the country rock. And the ore, mine operation period, at what time will be the stope will be exposed, and mining method and its classification, what kind of mining method is going to be installed for that particular kind of scenario of country rock, and mining geometry, that is the height, the length, width of the mining object, what are the primary stresses which is involved in this water principal stresses, major and minor, that has to be taken into account. Then the geological condition, like whether there is faulty, whether there is dike, this has to be considered while designing in the designing parts itself. Then what is the purpose of the backfilling? Depending upon the mining method, whether what kind of backfill we are going to put, whether we need cement in it, whether we are used for waste disposal, depending upon that we will decide. Okay. Now, when that is decided, then the material characterization is done in lab. What are the things which we do in the material characterization? First, we carry out the physical characterization. In physical characterization, we find the pulp dense specific gravity, bulk density, then percolation rate, then void ratio, porosity. All these are the physical parameters which have to be tested before classifying a material for hydrofill. For paste fill also, we do the same thing, but in that case, size is the most important thing, and the strength what it gains, and at what percentage of cement. That parameters we play with to find out the ultimate target strength of the stopes. So this has to be done before, and then define operation parameters so that the material backfill matches the target properties. Then after the target properties has been defined, suppose we need 1 MPa strength, okay, for a particular fill. So after that is defined, then at the fill plant, the operator should mix the same ingredients. Suppose 1 MPa we are getting for cement of 5%. Just imagine, just an instant. So the operator parameters should, and with a pulp density of like 1.5. So the pulp density has to be, what are the variables? The pulp density, the solid concentration, the velocity, and all that. So it has to be synchronized in such a way that we get a mix which is favoring our fill plant. After that, what we do, the economic evaluation. Suppose what is the binder cost coming, how it can be replaced with a different material. After that, then documentation of mine backfilling system. What are the things which has to be done? How many hours it has worked? What is the filling ratio? How many cubic meter of the fill has been poured inside this wards? This has to be taken into account and put into a record book, online record book. So to keep a record for that. So what is backfilling purpose? It may be pillar recovery. That is a simple. It's like what here that it is explained over here. Sill pillar recovery, working platform, ground support, waste disposal, mining on top of or sides or under the backfill. That is the things which are the parameters which has to be taken into account. So backfill placement operation includes dewatering, placement, and monitoring. The monitoring part is to be done for both the paste plant, for the plant as well as for the underground. So what are the monitorings which have to be done? We have to monitor the pressure which is coming on the barricades. We have to monitor the velocity, and then we have to monitor the density. So there will be a instrumentation at the paste plant also. What kind of instrumentation is that? Density meter is there, then velocity meter is there, then at the barricade pressure cells is there, and if it is hydrophile, piezometer should be installed to find out the variation in the pore water pressure. So this is the main basic outline of a paste fill hydrophile plant. So the material from the mill comes to the hydrocyclones. Hydrocyclones is basically uses centrifugal force, principle of centrifugal force, which to reduce the to size, basically classify the tailings into coarser and finer particles. So the top particles, the particles coming out from the top of the hydrocyclone is sent to the ash tailing ponds, and the coarser particle which is required for hydrofill is taken into consideration for backfilling purpose. It is diverted to the backfilling plant. So it will then it is going to the settled storage plant. There is a mixing plant. There is a cement silo, and in one the cement silo will be replaced by partially with an ash or a GGBS silo to replace the cement. And there is a water. Then there is a continuous mixing, and it goes to the underground. So hydrocycloning can be done in, if we want strict control, then we can have two circuit of a hydrocyclone if we got strict control of the particle size. Otherwise, we can go for one this hydrocyclone also. Classified, so what is the requirement? Classified tailings, not less than 20% of the particles, less than 10 microns, to achieve a percolation rate of 10 centimeter per hour. So this is considered, this is determined in our laboratory. So if we get a percolation rate of 10 centimeter per hour, it means that water, 70% of the water is percolated out from the stope after 24 hours. That is a thumb rule what we have seen in different mines. So tailings are pumped out directly to the mill tailing. That is a simple what I have told, what is the difference between concentration. Fines are rejected as overflow and coarser particles discharged as underflow with density of 50% by weight. Then underground reticulation at desired concentration. The desired concentration is manipulated by adding more solid and less water to it. So now coming to the paste fill design. So paste fill, basically it is composed of three components: water, tailings, and binder. So tailings are usually more than 75% by weight. Binder is like, it varies, like OPC is 9%, they can replace it by maybe 5% of slag or maybe 5% of ash, depending upon what gives them the design strength. So first the material properties, as I have told you earlier, it will be determined in the laboratory. Then the grain size adjustment will be done, because as told by sir itself, they didn't have for paste filling plant, didn't have the finer particles. So they use cement. So that is called the grain size adjustment. So we plot a curve, and then we find out whether that curve is having a minus 20 microns particle size, at least 15%. If we are not having that, we introduce some finer particles to match that grain size. That grain size is called a Fuller curve. We superimpose what materials, what we got from the field, and we superimpose into the Fuller curve, and we matches out. So suppose that it is not matching it, so the final particles are added to it, so that it matches the curves. The Fuller curve is that curve that gives you the maximum compaction, maximum interparticle. It's like there is less interstitial space between the particles. So the pressure gradient estimate, this is carried out by closed loop test. They mix up a particular mix with a particular pulp density, and they flow it into the pipelines. And they do the pressure, what is the drop in pressure for a particular pipe diameter and for particular velocity. Then on that basis, travel distance estimate is done, and on that basis, plant location is decided, whether it is located on the surface or whether it is located in underground. So underground, there are two types of plant, that is fixed plant and the mobile plant. In fixed plant, as if the plant is fixed, we need a pump system. And then for surface plants, we need either it can go through gravity or through pump. And then the same thing follows. So what is a paste, and difference between paste flow and the normal hydraulic flow? A paste flow, as told, is a plug flow. The pumpability of paste depends upon its rheological properties. What is the rheology? Rheology is the deformation of material when subjected to external force. That is what rheology. I will explain it on more on while we touch upon the laboratory studies. It does not obey, the paste does not obey Newtonian flow. It is follows a non-Newtonian behavior. So what is the difference between Newtonian flow and non-Newtonian flow? In Newtonian flow, the stress is directly proportional to strain. Yani, means when you pull the grass down, the water flows itself. That is a Newtonian flow. There is a straight line between stress and strain. But in case of pump, paste flow, we need to have some initial stress to make the paste flow. So that is not that behavior is a non-Newtonian behavior. So this is the plot of a non-Newtonian flow. So this is the shear rate and this is the shear stress. This is kind of a little bit scientific part. So I'm just telling you in the layman term. What we do, we have a rheometer with us in our lab. Suppose we make a paste of 70% solid by weight, and we do a rheological study. Rheological study mainly relates this shear rate with the shear stress. If we get these two values, then we can find out the yield strength. The yield strength is that this is the yield strength. This is the yield strength. This is the squeeze, what I was talking about. This is the squeeze which you require for making the paste to flow. So with this, this is the generalized rheological model, what we follow. And usually there are two types of models which suits our Indian condition. That is the Bingham plastic model. That is, we know the value of shear stress and we know the value of this viscosity. It's like by knowing the two unknowns, we can find out the yield stress. So for Bingham plastic fluid, relation between the pressure gradient and flow velocity is given by a Buckingham equation. So the pressure gradient, that is very important for us. This is the pressure gradient which we need to find. And by rheological study, we find out the viscosity as well as the yield stress. By this we can find out, we can predict the pressure gradient for a particular diameter. Here, D is the internal diameter of the tube or the pipeline. V is the average slurry velocity, length of the pipeline which we are taking into account. So by this formula, we can predict what is the pressure losses. And on this basis, we can find out what is the distance it can travel for a particular scenario. It's like a full pump, as I told before, full scale pumping loop test on paste of desired consistency is necessary to determine the pressure gradient, head loss of various combination of pipe diameter, flow rate, and throughput. So this is the factors to be. Results of loop test will determine the operating pressure and the choice of pipe and the flow rate. All these factors, all these things what we are doing is a designing factor for what kind of pump we need. Because piston pumps are used for paste backfilling, reticulation of paste backfilling. So these factors act as an input for determining the paste pump. So Pradeep has already showed this cycle and all that. So the tailings come from the tailing plant and it gets through a deep cone thickener where the concentration is 58 to 62. It goes to the filtration where the filtration disc filters where the solid concentration increases to 83. And then it goes to mixing with cement, OPC, water to form the required pulp density. And then it is reticulated to the underground through positive displacement pumps. So what are the three essential things? Dewatering, mixing, pumping, and transportation. These are the major components of a paste plant. So there is disc filters what I was talking about. Disc filters works on the principle of alternator suction and blowing part. So paste materials are placed inside here, having a concentration of 60 to 70, and the disc rotates. So when the disc is at the lower portion, like half of the trough is filled, there is a suction. So and when it rotates to 180 degree, there is a blowing part. So during the suction cycle, the final particle sticks to the outer surface of the disc, and while it rotates, when the disc is inflated, the cake gets displaced into the conveyor belts. This is a diagram of a deep cone thickener. And these are the different dewatering techniques which we use. But mostly, we in India use this combination of deep cone thickener and disc filters. This high density thickener, cyclones, centrifuges, tank dewatering, just to mention few of them for dewatering purpose. So mixing is done by two process in a paste plant. That is continuous mixing, and then another one is batch mixing. So continuous mixing plant requires higher maintenance and properly calibration, because as I told, a slight difference in the particle size and the moisture content will reduce a great difference in the pressure. So that has to be taken into account. The mixer is screw type mixture, and it cannot respond quickly to incorrect paste means passing to the underground distribution system. Sorry. This is a batch mixture. Batch mixture is self-calibrating. Suppose if a wrong pulp density is formed into the mixture, so the agitator of the mixture is driven by a pump. So the pump, the power consumption of the pump will be changing depending upon the consistency of a paste. So it gives a feedback signal to the water sensor to increase the water quantity so that the pulp density is maintained. That is the case for batch mixing. So it is easy to control, and it can, this is the main thing. I don't know. Anyway, so the transportation to the underground is done by three methods basically. One is the gravity system, which is a combination of vertical and horizontal pipelines, where the vertical head is converted into horizontal length in steps. Another one is that pump is installed at the bottom, and the third configuration is that pump is installed at the surface, and the discharge is taking place through a longer horizontal distance, then it going to the vertical downward location. So there is in the first configuration there is no disruption of surface activities because it is inside the mines. And the main disadvantage of this kind of configuration is that space constraint is there, so maintenance will be an issue for that. And then in the second configuration, it uses both horizontal and vertical gravity, it's like pressure. And in the third, easy installation, inspection, maintenance with no disruption of main shaft. Disruption due to surface activities will be there, and because if there is something happens to the pump, the whole system will be stopped. Filling up, because filling operation mainly depending upon the pumping of this facility of the pump. Then high pressure takeoff at this point, because there is a vertical head, therefore the high pressure is developed at the bottom of the pipeline. So this is the pump which is used for pumping the paste. That is a double acting piston pump. When one piston moves up and the other piston goes down, so there will be a constant flow. And because of this, there is some pulsation, which is reduced by pulsation dampeners, what they use inside what they use in the plant. So the pumps manufacturer are basically Pusmister, Swinch, Able. These are the few pump manufacturers that are supplying pump for paste plants. So now I'm coming to the laboratory studies, what we do in our labs and how we classify things. So we get the proper like raw materials from the disk filters for material characterization. Then we get the mill tailings, we dry it and do a coning and quartering, and we get a representative sample for mill tailings. Then we get the different pozzolanic materials like fly ash, then slag. We do the sampling by coring and quartering, and OPC. All these things are the parameters on which we do the laboratory studies. And it basically involves first time XRF characterization, that is the chemical composition characterization of a material, different film material. Then we go for particle size analyzer. It is a laser based, we use a Malvern based laser particle size analyzer. Then we mix the paste and prepare the paste of required pulp density, and then we do the slump test to find out the consistency of usually we get the target slump and the target strength from the mine management. So with that particular target strength and target slump, we have to change the cement binder content, so to achieve the target strength. And and the main objective is our main objective is to replace the binder with OPC binder with different substituting material. So that is the main thing that is to be done. Then we go for after slump test, we prepare the molds. Then we go for testing, geotechnical testing. This is the compression testing, and this is the triaxial test. Then the sample is failed, and we get the result. Suppose target UCS is like 1 MPa. Then we, after making the molds, we cure it for different days, 7 days, 14 days, 28 days, and 56 days. This gives the idea at, suppose the target strength is 1 MPa, and suppose with a particular mix, we are getting the strength in 28 days for a cement percent of 10. Suppose we reduce the cement percent to 8 and we increase the fly ash content in cement. The binder is 10%. Initially, we do a 10% test, that is the control sample. Then we start on reducing the binder content and we add on ash or slag to it, so that we can see what is the effect changes in the strength parameters in different curing periods. After we get that, then we can say to the client that with this binder replacement and with this curing period, we can achieve the target strength with these days, with this many days. And then we can go for microstructural analysis and SEM analysis. So these are the main laboratory studies which we do at SIMFA. Now physical properties, as I told you, that particle size distribution, we do specific gravity, bulk density, particle morphology, this is done by SEM analysis, then void ratio and porosity. Relation between slump and water content we find out, then paste rheology from the rheometer we find out to find out the yield stress, then the factor of safety for a particular stope dimension, that is also important. So where we get from, like how do we get 1 MPa strength is required. So we do some numerical modeling as well as analytical analysis. So with a particular stope dimension, with this, what is the factor of safety of the fill material, we find out in the lab. This is how we decide with a given dimension what factor of safety we need to be having a safe fill. So void ratio is the ratio of volume of the void to the volume of the solid. It ranges from 2. We have got a mercury intrusion porosimeter with us. It gives us the porosity value as well as the void ratio value. So with the help of this instrument, we found out this parameter. So usually size is important parameters what we have told. So materials are classified as uniformly graded and well graded. So what is a well graded, difference between well graded and uniformly graded particles? In uniformly graded particles, as you can see, the size distribution is very narrow. It means we have got similar kind of particles of, suppose we have a glass tube and we put the marbles of same shape, then it means that the void ratio will be high because the particle size are of same size. Therefore, the void ratio and porosity will be high. So next type of gradation is the uniformly graded. Here we get evenly distributed particles. We get smaller particles as well as the larger particles. So the voids between the larger particles is filled with the smaller particles. So we get a more compact fill. So that is a very important thing. And this is the main governing factor which changes the kind of fill we are going to adopt, kind of filling system we are going to adopt. So this is done by a laser-based particle size analyzer. This is some of the results from SK Mines, GGBS and SK Tailings. These are the comparison study. So CU is the yardstick to measure the whether it is well graded or not. CU is called the coefficient of uniformity. D10 is the particle's diameter at which 10% of the material by weight passes. So D10 is a suppose you are getting this D10. So what is the value of D10? Anyways, I will just skip it. So this is the SEM setup we are having at our lab to determine the elemental composition. This is the basic XRF output, and this calcium oxide is it's like different parameters we found out in the lab. What are the chemical composition of a particular tailings, or maybe fly ash, or maybe GGBS, or maybe mill tailings. So these are the morphological studies output. This is the ash. There is a cyanosphere. This is the morphological study for tailings. So this is the hydration index and lime saturation factor. What we do is for pozzolans, we do the chemical composition analysis, and from the output, we do the hydration index study and the lime fraction. So hydration index, if we have a hydration index of 1 or more than 1, it means that it has got reactivity of pozzolans is more. So it will attain more strength because it will having more calcium oxide. So calcium oxide should be more. So we can have a good hydration index. So it should be more than 1. If it is more than 1, it is suitable for as a pozzolan. This is a yardstick, just a yardstick. Same is for lime saturation factor. It is a ratio of calcium oxide, silica, and silicon oxide, and aluminum oxide, and iron oxide. So this is the slump test, what I was talking about, what we do. Slump is the subsidence. Like if we pour, if we mix it with the required pulp density and we pour it, this is the subsidence. Usually it varies from 0 to 200 to 300 mm. So we can see the difference. This is a slump of 184 and this is a slump of 94. What is the difference of the subsidence which is taking place? So it usually tells the consistency of a field, how it will behave when it is poured inside the stope. So when we go on increasing the water content, the slump also goes on increasing because the spread will increase because the flowability will increase. It means that the flowability is increased. So these are some of the samples for rheological studies. Rheology is, as I told, study how the study materials behave on response to applied forces. And it establishes a relation between shear stress and the shear rate to determine the yield stress and changes its viscosity. So usually, as I told you earlier, the Bingham model follows, it is more suitable for extrapolating the yield stress. So we use that model. And we can see as we go on increasing the concentration, the yield stress also increases. So that is the thing. So this is the formula which is used for determining the factor of safety. This is an analytical approach given by Michel way back in 1982, and it has been modified by different authors. So the factor of safety is given by different parameters, and if you know the factor of safety, and this formula is a simplified version of this formula. If you know the factor of safety, suppose factor of safety is 1.5, then we can change this parameter into this, and then we can get the value of C. What amount of C we require for a particular width and dimension of the stopes. And similarly, what is the UCS strength what we have to get for a particular width of exposure, height of exposure. So this formula we use for determining the factor of safety of the material for a given stope dimension. And so there is one analytical, sorry. And second one is the numerical modeling approach by which we can find what is the cohesion and the UCS strength required. So this is a flag 3D model, what we usually do. And now we also do carry out studies on paste backfilling performance. So we take out cores from the backfill area portion, and when these subject it to different geotechnical studies. This is the extracted block. We take out coring processes there. Then we take the cores and then we subject it to uniaxial strength determination, and then the UCL samples are prepared, and then we found out whether strength gain in the underground mines is same as what we get in the laboratory, and what is the discrepancy between the laboratory value as well as the what we are getting in the field. So what we found that usually there is a discrepancy of 10%. 10% less value is there in the field. So this is the kind of rupture what we are getting. This is a shear failure, this is a tensile failure, and this type of failure represents, the mixture of combination of both. So I'm trying to hurry up because you must be feeling hungry now by now. So these are the projects which is going on as of now with us. And one is we have done a geotechnical study for Malanchkad also. We are having two projects from SZL for replacement of OPC with GGBS, and scientific study is going on for paste backfill and RDM for top-down methods, and that is it. And we are doing some studies for INFA also. So that's it. Sorry for keeping.
Thank you very much, Mr. Prashant, for his deliberations on backfill mining. So I will request Karia Saab to felicitate him. भाई साहब उसको टेप करने बोलिए, लोग गिरेगा. Thank you very much, sir. And thank you, Dr. Prashant, for his lecture. नहीं इसको मत हटाओ, इसको जरूरत है लेकिन उसको नहीं काम नहीं कर रहा, पुराना वाला हटा दीजिए और इसको टेप कर दीजिए, टेप करने से बस है वो. So now we'll break for lunch and we will assemble here by around 2:30. Okay. Thank you, Kariya sir.
चिपका देता हूँ। ठीक है सर, कर देता हूँ।
ये इसका है, पेन ड्राइव निकाल दिया, पेन ड्राइव निकाल दिया उसने. तो इसमें ऑफ करना पड़ता है, तो बैटरी खत्म हो जाएगी. शूट नहीं हुआ। बाबा ये थोड़ा बंद कर सकते हैं क्या? लगाएंगे इसको थोड़ा ऑफ करना है। बहुत ठंडा गया थोड़ा।
आपका इसी में होगा ना?
हाँ
ये लगा इसी कर लूँगा, डायरेक्ट ओपन कर दूँगा इसी से।
हाँ अच्छा, एक सेकंड देखते हैं चलता है कि नहीं। ठीक है सर, आप पर लगाइए
है ना? दिखता ही नहीं है बॉस।
मैं देखता हूँ।
नहीं ठीक है, चश्मा लगाता हूँ, चश्मा लगा लेता हूँ बॉस।
हाँ ठीक है,
दिख गया ना बस। हाँ तो खोल लीजिए
फर्स्ट वाला
कितना मिनट खत्म करूँ बताओ सर। फिर बोलो, फिर भी
हाफ एन आवर तक ले लीजिए।
चलेगा? चलेगा हाफ एन आवर चलेगा?
चलेगा सर, कोई प्रॉब्लम नहीं।
आ रहा है क्या? नहीं आ रहा। ये फिर इश्यू क्या है बोल इसका?
नहीं ठीक है।
ये अच्छा इसमें अटक जा रहा है क्या बस?
नहीं,
तो इसको इधर कर दिए।
नहीं कोई प्रॉब्लम नहीं, कोई प्रॉब्लम।
उधर बहुत अटका था वो नागिन इस केस में। चलेगा ना? कोई दिक्कत नहीं अभी? तो ठीक है।
This one? ये दो प्रेजेंटेशन दिख रहे हैं, इसमें कौन सा है? वेलकम जी, ये है क्या?
No, 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 sir. This is not brief overview. Yes, sir. This one.
So, before we start the lectures today, just a 5 minutes presentation. I will invite Head of Mine Planning Division, Mr. Malleshwar Rao of Gemco Technology Services Limited of AP Birla. Yeah, please make it.
Good afternoon to everyone, sir. Myself, Malleshwar Rao. Basically, I am a mining engineer with M.Tech in Environmental Science and Engineering and MBA in Strategy and Leadership. We are from CK Birla Group, GTS, Gemco Technology Services Limited. It is a very new company, just started 2 years back. But we are having more than 50 plus experts with having more than 20 plus years of experience and approximately more than 10 plus young engineers with innovative mind and a lot of innovative knowledge in research and development. We are end-to-end service providers from basic bid consultancy, including bid advisories from selection of blocks, how we have to select the block, and due diligence for each and every type of due diligence, including selection of blocks, selection of MDOs, and selection of mine, what are the methods and all, transaction advisory, feasibility reports, as well as trade-off studies for different mines we are doing. As a technical services, we are having own drill rigs, including geophysical and geochemical instruments which are required, and remote sensing instruments we are having. We will do from identification of blocks to complete exploration and resource modeling. We are using different mining exploration and geology softwares, including Micromine Origin, Leapfrog, Serpac, and Minex for different geological modeling. For any block, definitely we will work with two minimum softwares. One, after doing one geological model, we will revalidate the same with some other software to know the resources exactly, because resource and reserves estimation is one of the more critical important to validate and to evaluate the mine capacities. And after the completion of exploration geology division, they will hand over the same to mine plan division. In mine planning, we are having different softwares, including Micromine Beyond. First, initially, we will validate the geological model with the Micromine Beyond. Then we will have Deshvik software. With the Deshvik software, generally we will do mine planning and design, including different modules like scheduling, UGDB, underground drill and blast, and optimizer is there to validate the resources and reserves properly. And then after, we are having some other softwares like we are having Hexagon. It is also very good software for underground mining. And also we will use Minex for some of the coal blocks. And also during design itself, we will use FLAG 3D for geotechnical plants and washeries. And we are having independent digital technology division, which can provide end-to-end digital mining solutions like automation, fleet management system, and fuel management system. Already some of our friends told in morning how to trap the fuel with RFID like that. We are having our own indigenous fuel management system, and anti-collision device systems are there we are having, and different types of techniques. And we will do project management. All of our engineers are expertise in both in operations as well as in mine planning. So we will help our clients in debottlenecking. If any problem is there, we will design it, and we will go personally till it will be succeeded. Because of the expertise, lot of experience in their fields. Suppose I am a mining engineer with more than 22 plus years of experience, having expertise in different types of underground coal mines, like we have worked in under the river, like in Godavari, below the Godavari river we have worked, and also we worked in different coal mines like deepest coal mines in India, as well as we worked in biggest open cast mines like 42 cubic meter shovels and 62 cubic meter dragline combinations. This is simple end-to-end solutions where we will provide bid consulting, ground exploration, mineral reserves and resource estimation. Most of our experts are having JORC certified persons and NI 43102 certified professionals. We will do resource and reserve estimation as per the JORC code 2012. And also we are having footprints in different countries for feasibility studies. This is the main organogram, which is headed by Chief of Technical Services, Mr. Dr. Surendra Bakla, having more than 36 years of experience in Coal India as well as in Adani and also in Gemco. And Ramesh Kumar, he is head geology, having more than 21 plus years of experience. Out of this, more than 16 years of experience in different countries, including UAE and South Africa. Myself, Malleshwar Rao, head mine planning with 22 plus years of experience in different fields. And Amol Bhosle is a head engineering He was having most of the experience in Australia and in India. And Karthik Shankar, he is our head digital solutions. We can provide different safety solutions and digital mining solutions, end-to-end solutions for digital mining. These are already I have explained. Exploration geology, we are doing this all. We are having our own survey equipments for both. We will do survey for underground open cast, including drone survey, DGPS survey, topographical survey, underground correlation survey, volumetric survey with LiDAR and all. And technology solutions, we will provide it. These are our footprints. Thank you so much. Really, today's session is very, and yesterday's session is very wonderful workshop. We are very much thankful to John Liu sir and all the MOIL management and CSR management for conducting this type of techniques. These are our accreditations, JORC, SAM codes, APA, AE and MPPA and SAM codes. These are the software bank which we are using for different. First one is survey, and second one is almost most of them are geology related. Third one is mine planning, and fourth one is engineering and designing. Thank you. Thank you so much.
Thank you, Mr. Malleshwar Rao. I would like to call upon the next speaker. I would like to welcome our scientist in charge of Nagpur Research Center of CSIR Simfer, Dr. J.C. Jhanwar, for his brief lecture. So I would like to read his biodata. He is Chief Scientist and Head of Research Group of Mining Technology and also Scientist in charge of the Nagpur Research Center here. Dr. Jagdish Chandra Jhanwar graduated in mining engineering in 1987 with honors, with first rank from the University of Jodhpur, and secured the University Gold Medal. After working briefly in the industry, he joined CSIR Simfer, Dhanbad in 1989. He is currently working as a Chief Scientist, Head of Research Group, Mining Technology, and Scientist in charge at the CSIR Simfer Nagpur Research Center. He has worked extensively on industry-sponsored R&D projects, mostly related to air duct blasting in open cast mines, slope design and slope monitoring, stability assessment of pit slopes and waste dumps of open cast mines. He has obtained higher level diploma in science and technology from BITS Pilani, ME by research in the field of air duct blasting in open cast mines from VNIT, and PhD in the field of slope stability in open cast mines from VNIT Nagpur. During his scientific career of over 35 years, he has published over 105 technical papers in journals and conference proceedings and has successfully completed over 120 industry-sponsored projects in the field of blasting, rock mechanics, and slope design. He is a recipient of the CSIR Technology Award 2011 as a key member of the high-wall mining team at CSIR Simfer, and has delivered invited lectures in blasting and slope stability at Simfer, VNIT, WCL, SCCL, University of Jodhpur, etc. So with this, I would like to welcome Dr. J.C. Jhanwar for his presentation.
Thank you, Dr. John. A very good afternoon to all the esteemed colleagues, from my own institute, dignitaries from MOIL Limited, distinguished delegates from the industry, MOIL, Hindustan Zinc, SMS Limited, and other INFA and the industries. We will discuss in a very brief about the stability of pit slopes. with special reference to metal mines and with more special reference to the mines having underlying working of underground workings below the open pit working, which are still working or inactive open cast workings. So before we do that, what are the different issues which really govern the stability of pit slopes in open cast mines? Major issues in metal and other non-coal mines. Then how do we go ahead with the safe and optimal extraction of minerals from open cast mines? Then what does happen or how does it make special when we have presence of active underground workings below the open pit? As we can see, classic examples of Rampur Agucha mine, Malanjkhand, and soon we will be having at Dongri Buzurg also in some years to come. Then characteristic of pit slope materials which really govern and which really dictate the potential stability issues which might come as we go ahead with mining. Then how do we manage the pit slope? How scientifically we can manage the pit slope so that we can extract the minerals with best of economic levels and with best maintenance of safety concerns, which really takes two components of scientific slope designs and continuous assessment of the slope performance as we go ahead with mining both open cast and underground. We just highlighted different issues, key issues which really govern the stability of slopes in metal mines especially. Sometimes we do have presence of very weak materials in terms of soil as an overburden, a top cap of soil. It could be as low as 0.5 meter to as high as 6 meters, 7 meters also at sometimes. Then effects of groundwaters and infiltration of rainwater into the slope, especially during the rainy season. Then quality of slope rock mass. We can characterize the slope rock mass which really constitute the slope. How do we characterize this? As a rock mass, not as an intact rock, but rock mass, but it is very weak. So from the Indian perspective, we are covering a rock mass which is as bad as very weak and as good as very strong category in terms of rock mass rating, in terms of quality of rock mass. Then sometimes how difficult or how complex the rock mass is from the structural point of view and how much jointed it is, because sometimes we have massive rock mass conditions, sometimes we have sparsely jointed, somewhere we have moderately jointed, and sometimes it is very closely and randomly jointed, which really behave differently in terms of pit slope stability. Then one of the most important issues is that we often have non-uniform occurrence of ore bodies and mineral deposits in the non-coal open and metalliferous sectors. Then presence of underground workings, as we have seen, as we are having at Malanjkhand, mainly, and at Rampur Agucha mines. How does the pit slope dictate the stability of underground working, and how does the overall stability of underground working dictate the stability of overlying pit slopes? Then loading of pit slopes due to dumps which are located in close proximity with the pit slopes. The more important factor is presence of important surface structures or any habitats near the pit slope boundary. And then execution of the scientific pit slope design, how best we can execute this design which have been given scientifically, which have been designed scientifically, and how do we monitor the slope behavior as we go ahead with the mining practices. We are having pit depth from as low as below the 50 meters, then 50 to 100 meters, 100 to 200 meters, and more than 200 meters. Because depth is a critical factor which really govern the overall behavior of pit slope stability. That's why pit depth is a significant parameter. How the ultimate slope, how the overall slope will behave, not the base level slope, but the overall slope, how does it behave, that really guided by the how deep it is, how high the pit slope it is on overall scale. Now, before we go ahead, we should understand the impact of underground workings. As we say, when we develop an open pit, it results into stress shadow, which affects the underlying rock mass. And this phenomena occurs as the removal of overburden material relieves pressure from the rock, altering the stress distribution inside the workings. Then also it alters the principal stress orientations in the rock mass, and then it creates the stress concentration zones, then generates the tensile strain zone near the pit walls. Tensile strain zones may develop near the pit walls, potentially propagating downwards. These zones pose a significant risk for creek formation and propagation, further impacting the stability of both underground and open cast workings. Now, because now, especially when we are dealing with, when the workshop is centered around underground metal mining, so we are concerned more with the scenario where we do have the overlying and open pit working and underlying underground working. So how does the interaction takes place? That any deformation in pit slopes can induce additional loading on the underground support systems, which may compromise the stability and effectiveness, and such deformation often require enhanced monitoring and reinforcement strategies to ensure safe and operational efficiencies. This I am stressing upon because anything, any movement, any disequilibrium in the open pit slope might result in adverse stability condition in the underground working. So it is more important when we have underground workings, then it is more pertinent to maintain the stability of pit slope, even if it is not working. Because we open up underground working only when we have reached the ultimate depth in the open pit, both in the case of Baramchkand and Rampura Gusha mine. But doesn't mean we leave the ground, of course we leave the ground pillar, but still, as long as we have open underground workings active, till that time, we have to ensure the stability of pit slope in all its formats, as long as we have active underground workings. That is why it becomes all the more important. Underground excavations do influence the global stability of pit slopes through stress relaxation. This phenomena can alter the stress distributions, potentially leading to slope instability or collapse if not properly managed. So as I said, it's vice versa. Means when we do have overlying open cast workings, then it is more important to maintain the structural integrity of the underground workings also in all its forms. So both of it is equally important. Then fracture network development. The development of fracture networks can create connectivity between surface and UG workings. And this connectivity may lead to unintended consequences such as water ingress, migration of horizontal hazardous materials, necessitating careful planning and mitigation measures. So that is why we are stressing upon, because once we don't have open cast working. As you can see in Agusha mines, they still have around 300 monitoring points, which are actively monitored every week through laser scanner, through radar, and total station based. Now, how can we manage the complex interactions which might take place between the open cast and underground workings? And key strategies for effective mining management. First thing, implement robust modeling approaches, which my esteemed colleague, Dr. John, will put more light into that. Then we can develop appropriate ground control strategies in underground, establish trigger action reaction response plans. Now, just saying that TARP we have to manage, we cannot copy a TARP developed for a mine X to a mine Y. Here I would like to stress upon that for each and every site-specific conditions, we have to develop a specific empirical models, a trigger levels, threshold levels suited to that given geomining condition. Even within the same pit also, the same trigger action response plan cannot work for both footwall and hang walls, because hang wall behaves differently and footwall behaves differently, both everywhere in metal affairs mines at least. So the meticulous monitoring, interpretation data are essentially required to derive appropriate models and to derive the threshold levels, and finally to TARPs for different stages, whether we have to remove the mine material, mine machinery at the ultimate stage, at what level we should do. And whether it is displacement alone, or it is rate of displacement, or it is rate of velocity change, that is acceleration. So that also comes only when we critically analyze the data of displacement with respect to time, and that can be possible only when we make it very important, we realize the importance of monitoring of slopes, open cast, especially when we have underground workings below, then only it is possible. So implementing a trigger action response plan is possible only when we go ahead with a systematic and comprehensive monitoring plan coupled with the periodic interpretation data. Then maintain comprehensive monitoring systems as per requirement. It could be visual monitoring, it could be monitoring through total stations, monitoring through real-time monitoring through radar, laser scanners, and drone-based photography systems. Now coming to the characteristics of slope mass. In terms of soil, the unit weight could be from 50-90 kilonewton per cubic meters with a cohesion of 12 to 42 kilopascals and friction angle 11-17 degrees. These are the, and for rock mass, if you characterize the Indian mining condition, Indian metal affairs mining conditions, non-coal mines, we are dealing with rock mass which is poor to good, significance RMR in terms of 25 to 80 rock mass rating, with a cohesion of as low as 175 kilopascal to 800 kilopascal of rock mass, not of intact rock, because it is the rock mass which plays more important role, not the intact rock. So we have to calibrate our test results into the rock mass characteristics, both in terms of cohesion and angle of frictions, which is, I have put it here large range for applicable for non-coal and metalliferous mines. 20 to 45 degrees is the realistic range of phi and cohesion. So these are three pillars which really govern the structural stability of pit slopes. We are having different kind of rock mass in limestone mines. Then coming to iron ore mines, it varies a lot, sometimes from RMR 25 to 65, which is the rock mass is sparsely to closely jointed, and overall stability guided by stock mass properties. And bend scale stability is often governed by structures present. As I told you, as we go deeper, as our slope becomes more and more deep, the behavior of overall slopes changes accordingly. For example, for the range of 20 to 50 meter, it is more dependent upon the feature structure because there is more likelihood of a single structure feature to dilate into the slope and cause instability on a bend scale. But as we go deeper, means when our slope height becomes more than 50 meters, 75 meters, 100 meters, and 200 meters, the overall slope will behave differently because lots of structures get into the slope mass, and all these structural features and interact rock, which constitute the rock mass, and then rock mass as a whole will behave depending upon the interaction of different joints and the closeness of joints, how the rock mass is jointed, whether it's sparsely jointed or closely jointed. So that guides the ultimate strength of rock mass, shear strength of rock mass. Now, with other metalliferous, we can discuss the barite mine. We have covered one of the largest, single largest barite deposit of Asia, that is barite mine of Andhra Pradesh Mineral Development Corporation near Tirupati. There we have designed both pit slopes and waste dumps. Now the height, the pit depth is touching around 240 meters. They are still planned to go ahead. Here also again the hang walls behaves differently and the footwall behaves differently. Then we have covered for this wollastonite mine also. Then this is one of the world's largest marble mine of RK marbles. Then rock phosphate mine of Vedanta. The intact rock, when we talk of intact rock, which really constitutes the rock mass as a whole, can be classified as medium to very strong, and the rock mass can be classified as fair to very good. But each mine has a varied and diverse geomining conditions from the structural stability of pit slopes. So we have to analyze each slope in a different environment from different perspective. This is the classic case of Rampur Agucha mine. As I told you that they have extensive underground workings below the worked out open pit, but still they are maintaining the open pit slope as if they are still working in open cast. So these I want to stress upon that even if you have very smaller underground working or extended underground workings, maintenance of pit slopes, overlying underground workings becomes critically important as long as the underground mining operations are going on. Now coming to now this applies to all types of pit slope, whether we have underground workings or we do not have underground workings. So we have tried to divide into two aspects, how the different two components constitute the management of pit slopes. One is slope design execution. Then one is assessment of slope performance. Both are equally important because what happens generally industry people does, you design our slope, give the report, and they go ahead with their own way. So what we stress upon, it is the design is one part. Now it's execution as per the design parameters, and then assessment of slope performance, how the design works. That is all the more important. Assessment enables us to review the design, and make some corrections as we go ahead. As we enlarge the working, we go deeper, both downwards and laterally as the workings open up. So the slope design guided by characteristic of rock mass, how the shear strength, how it behaves from the shear strength point of view. Then how the rock mass can fail at bend scale, at middle scale, and overall scale level. That is possible only when we make a detailed characteristic of geomapping, geotechnical mapping, structural mapping, and identify through analysis mode, then what kind of slope stability instability can occur on bench scale and overall scale. Whether it is plane failure conditions, wedge failure conditions, or toppling failure condition, or when it is closely jointed, it could be more or less like circular failure conditions. Then assessment of input parameter. This is most critically important, that because there are many tools available for slope designs, but assessment of input parameters is a very vital parameter, is a very vital component. How do we assess the input parameters, both of shear strength, to be input into our models for designing the slopes? So this really requires the detailed insight how the slope could behave potentially when we go 50 meters, below 50 meters, then as we go deeper, how the slope could behave. So it requires real insight into real experience, judgment, engineering judgment, laboratory testing, analysis, calibration, modeling, and then your own insight, experience, how the slope behaved at different levels, how the slope have failed. Because failed slopes give us very critical information as how the input parameters might have worked at that time, so that can be used for new design of slopes. Then detailed analysis of stability from different tools. Then finally, based on all the characteristics, we formulate the slope design, a workable slope design, which is the slope which is steep enough to be economical and flat enough to be stable. That is optimization of slope design. Now, parallel to this, when we execute the design, given design, we have to assess the performance of slope. This is more important than designing the slope. And this is really here what really Indian mining environment, I should say, not lacking, but we are somewhat lagging behind. Because we ask the designer to design the slope. We execute it also, but we don't monitor the slope. So this is how really it can't give us the desired results. So through visual observations, periodic monitoring, real-time monitoring, and interpretation of results for stability assessment. So we cannot give a single panacea for all the problem that, yes, this mine will require real-time monitoring. No. We have to begin with visual monitoring, detailed visual monitoring, then periodic monitoring, analyze the data. Now you decide which kind of monitoring system you require in your specific mine. It could be total station-based monitoring. When your interpretation, those data require, yes, your slope is moving at a progressive rate with respect to time, and your movement is progressively increasing. So it is steady state. So for that section of slope, you may require a real-time monitoring or some semi-real-time monitoring, say, for example, once in 2 days, or once in a week, or once in a fortnight. But that depends entirely upon a scientific interpretation of the monitoring data. So the classic example slope design at different mines. As I told you, why do you need slope monitoring? It provides information for detecting potential instabilities, unstable slope sections, slope points within the overall level, which side, footwall side, hanging wall side, upper level, middle level, lower level. So it is really critically important then assessing the performance of slope design, how the slope is behaving vis-a-vis mining. It could total station-based system, manual, semi-automatic, and automatic, 3D TLS-based systems, airborne drone-based systems, and radar-based systems. We have 3D terrestrial laser scanner-based system at our office, at our center. This we have used at Rampura Agucha mine also, and Barite mine also, and these are 3D model generated based on the 3D laser scanning. Now, what are the key points we can take upon? That management of pit slopes involves the understanding and control of slope deformations. It requires an appropriate mix of theoretical knowledge and judgment, engineering judgment. Effective slope management can be achieved through an execution of scientific pit slope design coupled with meticulous monitoring and interpretation of slope behavior. The approach is guided by the basic geological data, geotech characteristics, groundwater behavior, and good measure of engineering judgment. Detailed investigation might include rock mass characterization, potential failure mode identification, structural features, then most important, estimation of physical mechanical characteristic of slope rock mass, and assessment of phreatic surface inside the slope. Detailed stability analysis and sound judgment are important to formulate a scientific pit slope design. So these are the different components which really goes into the formulation of final slope design. It may include visual observations, monitoring systems using total station, 3D TLS, and advanced techniques depending upon the size and severity of pit slopes. So one system cannot fit to all kinds of slope conditions. Now, we will sum up that significance of slope management, pit slope, whether it is medium scale, large scale, whether it is having underground workings or not, but especially in metal mining conditions, because all underground workings invariably might have had in yesteryears open cast workings. Anywhere, even Dongri Buzur support, for example, we are open cast working, sooner we will be having underground working also as well. So the significance of pit slope management will continue to increase with the increase of size and scale of open pits Indian geomining scenario. The conditions might vary widely. Slope forming rocks could be very weak to very strong, rock mass from poor to very good. Sometimes it is poor in metalliferous mining condition also, and sometimes it is excellent also in some cases. The periodic geotechnical review of rock mass with slope stability and slope design with the progressive expansion is really required, because one-time design cannot satisfy the whole project life. It has to be periodic. It has to be tested and calibrated in the field, and when we reach a specific depth, we have to again recalibrate our design process, our design fundamentals, so it has to be periodic exercise only. Execution of optimum pit slope design coupled with a comprehensive slope management are fundamental to a scientific pit slope management exercise. Periodic and more effective coordination among mine management, regulatory and scientific bodies are likely to further help in achieving the twin objectives of mineral conservation and sustainable operations through safe and optimum mineral extraction from open cast mines. It is really very important. I highlighted this point because what we see here, there are three pillars of in this aspect. One is miner, one is scientific body, and one is regulatory bodies. So all have to be interacting in a very close manner, in a very periodic manner, to arrive at what the scientific agency is giving the design that must be implemented in that spirit with the active support, active interaction of regulatory bodies as well. Then only we can achieve the overall objective of mineral conservation with safety. So if we just put in picture, then we have three: science and technology, regulation, with combined with the three meets together in a more coherent way, we can get optimum mineral extraction with safety, which really gives us conservation of minerals within sustainable mining objectives. So thank you very much. Thank you very much. इसको निकाल दो. क्या निकाल दीजिए, इसको निकाल दीजिए सर बाद में.
Now I would like to request Chandrakar Saab to felicitate Dr. J.C. Jhawar. Please come.
No, it's my pleasure to introduce Dr. John, the coordinator of this workshop. He is the person who is behind this workshop, along with the active association, active support from the MOIL Limited. So he has been working tirelessly for last around 1 month, inviting lectures, sending communications to different agencies, inviting lecture notes, etc. I've been knowing Dr. John for last over 25 years, ever since he joined SIMFER, and he has been working for more than around 20 years at Nagpur Center. So I've been working very closely with him, but still as a formal, he is a leading expert, and we are very blessed and very fortunate to have him here at our Nagpur Center, and he has been working very actively and solving the real problems of mining of almost at all the mines of Hindustan Zinc Limited, Hindustan Copper, and we are working very closely with MOIL Limited for last around more than 35 years at all the underground mines. So Dr. John here at Nagpur Center leading the rock manganese activities, all range of rock manganese R&D activities at Nagpur Center. He is chief scientist working in Nagpur Research Center. He did his BTech from honors in mining engineering from the IIT Kharagpur in 1994, and he did his PhD from IIT Kharagpur again in the year 2000. Dr. John has done postdoctoral fellowship at Korea Institute of Geosciences and Mineral Resources, South Korea, for the last 27 years. He has worked at Dhanbad also headquarter under Dr. P.R. Shevde, a leading global expert in rock mechanics. He is no more here with us. He has been working for the last 27 years as a scientist in CSIR SIMFER at different capacities. His major areas of research include rock mechanics, design of mining methods, numerical modeling, ground subsidence, engineering, etc. Dr. John has been the recipient of many prestigious national awards, which includes CSIR Young Scientist Award in year 2003, and CSIR Technology Award as a leader in high-wall mining in 2011. He has published and presented over 90 research papers in various journals and proceedings, national international journals of repute, book chapters, and conferences, and has published and has produced 6 patents and 2 copyrights. He has also authored a textbook on high-wall mining, only textbook on high-wall mining perhaps. And let me tell you, besides this, he is a real asset for us. He's an intellectual expert, we can say, and interacting with all the leading metal producers of India for solving the real-life problems. And he's instrumental in furthering our R&D activity in rock mechanics at Nagpur Center. So thank you very much, Dr. John. So we are very fortunate to have him here as your next speaker. Thank you.
Thank you, Dr. Jawar, our scientist in charge, for a very elaborate biodata. Of course, I don't deserve that much praise. What I would like to say is this is the last lecture of this workshop. We have a little bit technical snag anyway. I would like to give a brief idea about the numerical modeling techniques. So already in the past lectures, we have seen the application of numerical modeling in various stope design parameters, crown pillar design, etc. So I would like to give an idea about how it is being done, from where we start, what are the data you need to gather, and how we proceed about doing, how to do the modeling, how to define the problem. So it's a very simplistic way, I would like to say. And finally, I would like to present a few case studies, simple case studies which we did initially, and then we will go to a little bit stope designing methods. Examples are mostly from Hindustan Zinc. I can name the mines, no, there's no problem, no? Because they have a little bit secrecies here and there. So first of all, before we start numerical model, many people do numerical modeling just like a fashion. So everybody is talking about digitization, modeling. So, but sometimes you don't have to do modeling. Numerical modeling is only a tool. It is just a tool like many other tools, like empirical design. Yesterday, Mr. Ayan Giri had explained about empirical design methods for stopes, stability assessments and all. So there are a lot of empirical methods, and olden times people used to do even physical modeling. वो भी आप लोग देखे होंगे physical modeling, rock like material बना के lab में they used to do physical modeling. Nowadays people don't do that. So this is only a tool. So this tool can help you to take decisions. What should be our stope size? What should be the supports we require? So here, first and foremost thing, before we go underground, start digging, we should have an idea about what is the in situ stresses, pre-existing stresses. When the earth is formed millions and millions of years ago, at that time there were pre-existing stresses happening due to many other activities, volcanic activities and all. So in every area there is a pre-existing stress. That includes vertical stress as well as horizontal stress. And in horizontal stress, in one direction you have the major principal stress, the other direction you have minor principal stress. So this idea of in situ stress is very, very important before we start doing any numerical modeling exercise, because these are the primary input parameters. We create a virgin model before the mining starts. So there are many methods to measure the in situ stress. Most frequently in India, hydrofracturing is one method which is being used. There are other methods like overcoring, acoustic emission methods, and there are some theoretical equations also. As Dr. Jawar has said, my guru, Dr. Chevre, he had proposed a theory on in situ stress, and he derived an equation to find out that. We still use those equations wherever measurement is not available. In oil mines, here the direct measurement has not been done, so we still use that equation for predicting the in situ stress. But in SK mines, several times they have done the hydrofracturing test. It's a bit costly, but at least it gives the idea that what are the pre-existing stresses there. Next thing is geotechnical mapping. Mr. Pradeep Kumar has already explained this using, they have very advanced software like Leapfrog, where they can get the structural model of the mine site. The entire area, entire mine lease, and up to the, till the end of your ore body, you should have a structural, so we should know. It is like a doctor who a surgeon trying to operate upon your body without knowing the anatomy. It's a similar thing. You're trying to do mining, and you don't know where the fault is, and where the folding is there, where the shear planes are. So you should have a pre-mining idea that what we are actually going to deal with. Third thing is you start doing boreholes. From exploratory boreholes, you will get plenty of data. So you can get the RQD of the rock mass at the different types of rocks, what are available, what are the grade of the ore we are dealing with. And at the same time, we also get information about faults, shear planes, folds, whatever surprises we may find in the Mother Earth. Next thing is we take out the core samples from there and do the lab testing. So I will give a few slides on the lab testing which involved, because in none of the lectures it was covered, so I thought I will give you that. And then we estimate the rock mass properties like RQD, RMR, Q system, and other rock mass parameters. There is a software called Rock Lab which is freely available. It uses Hook and Brown failure criterion to give a rough idea about rock mass strength. So what is the difference between rock and rock mass? Many people confuse with this. Actually, intact rock is that when you drill a borehole, you get solid pieces of core, which is devoid of any major discontinuities. That is called an intact rock. But when we talk about rock mass, it is the size of this room, which contains so many joint planes, fold planes, faults, everything. So the overall strength of a rock mass you cannot directly determine in the lab. Core sample you can take it in the lab and test it for its strength. But for a rock mass, there are empirical methods, indirect methods using this rock mass classification techniques. So we can use the software rock lab to give a rough idea. But of course, this need to be calibrated from the field conditions. So as Pradeep had said today morning, that you have to validate your model from feedback from the mines, from the instrument readings, from the extra breakage you got from the laser scans. So I would like to give a brief about what are the important laboratory testing which a rock mechanics engineer need to be aware of and he should be doing. First and foremost thing is uniaxial compressive strength. This you all might be knowing in the lab. You put a specimen which is usually it's a core specimen. You cut and polish the sides and then load it between two platens in a UTM machine. So the load applied divided by the area, surface area of the cylinder, that gives the stress. So there is a difference between load and stress. Stress is actually the load concentration. So if I apply 10 kg load on a large area and 10 kg load on a small object, there is a lot of difference. This will give much higher stress because the area is much less. If the same load is applied here, you don't feel anything there. So that is stress. Load concentration is called stress. And you load it until the material fails. When the material fails, we call it, that is the uniaxial. The stress at which the material fails is the strength of that material, uniaxial compressive strength of the material. Second thing is tensile strength. There are two modes of failure of any material. One is shear failure, other is tensile failure. There is nothing called compressive failure. When you apply compression, it fails actually in shear. So there are only two types of failures. So how to find the tensile strength of the rock? The same way you compress it, you have to pull it out. But a rock specimen, pulling it in both directions is extremely difficult without causing bending stresses. So people have found out an indirect method to find the tensile strength. That is called the Brazilian tensile strength. You take a disc, and then the thickness of the disc will be half of that of the diameter, and then load it between two platens. So it vertically splits from the top to bottom. And there is a formula for finding the tensile strength. Third thing is triaxial compressive strength. As we know, any material, if it is in a confined state, it can take more load. So if you keep on increasing the confinement and you keep on loading it, it fails at a much higher load. So if you do for multiple times with different confining stresses and find the ultimate load of the ultimate strength of the material, you can plot this graph. This is called the Morse envelope. So Morse envelope is actually, it is in this axis is normal, is the stress confining as well as the normal stress, and this axis it is the shear stress. So you can see that if at zero confinement, it fails at the uniaxial compressive strength value. When you increase the confinement, it's the stress at which it fails keep on increasing. So you can see that if you plot this on a circle, it follows an envelope. The tangents, if you join the tangents of these circles, it forms an envelope. And the other graph towards the right is actually called the failure criterion. If you plot the confining stress against the failure stress, you can see that that also falls over a curve like this. So what does this criterion? This criterion is very, very important to find out whether your rock mass around your roadway or stopes is failing or not. Any stress state, a combination of sigma 3, sigma 1, inside this curve, inside this envelope, it is in a stable state. If it is outside the curve, it is in a failure state. In fact, this envelope won't allow it to cross. It is an envelope. If you won't allow it to, the stress state will not allow to cross this envelope. So this is called a failure criterion. every material has got a failure criterion. And usually it is in a curvilinear fashion. Earlier people approximated it as a straight line, but later on people found that it is not a straight line, it is actually, it's a curve. So people proposed lots of equations to fit this, that is called failure criterion. My earlier boss, Dr. Chevre, he had also proposed one criterion for rock masses, Chevre's failure criterion. We still use it. And other parameters which we require is the deformation of the rock. So how to get how much your rock would deform. That is, the two parameters involved are Young's modulus and Poisson's ratio. I think you all know this, you studied this in physics. So from this triaxial strength, you can find out the cohesion as well as friction angle of the material. And there is another way of finding it is by direct shear test. That is, between two platens here, you put your specimen and then shear it across and apply a normal load and shear it across. At certain stress, it fails. So if you plot the shear stress versus the normal stress, you can see that when the normal stress increases, the shear strength also increases. From here also, we can get the cohesion as well as the friction angle. Another one you people must have used in your field is called point load strength. It is a very rough estimate. For modeling and all, this value will not work. You need proper UCS testing. So point load strength index, you can carry that machine. It's a small machine. You can carry it underground, take out any rough size specimen or a core sample, and then put it between these two conical platens, and then you fail it. So from the failure load, you can calculate what is the point load strength index. And from the point load strength index, there is a rough estimate to calculate uniaxial compressive strength. Next thing is, this is very important. Most of, in the roadway, you can see that rock mass fails at some parts, some places it stays stable. There is a reason behind that, because rock material, even if it has attained its maximum load, it doesn't fully fail. It's still, even a failed rock can still stand there and take some load. So that is called post-failure behavior. And this is very important in our numerical modeling, because every material has got a post-failure curve. So that is, here it has failed. This is the peak it has obtained. This is the peak it has obtained. And from here onwards, the plasticity, from elastic state, it has moved to plastic state. So, so here, unless we know the post-failure behavior, it is very difficult to model rock, because some rock has already failed, but that doesn't mean that it will fall down. It may stay there for some time, or it keep on taking load. So that is the grace period we have. Blasting, the roof may start going into this stage. It must have crossed this peak stage and will be traveling here over a period of time. So by that time, we have to muck out. That is the most important thing, and backfill if possible. So this is very important in numerical modeling. So I'm coming back to the original slide. So this is all about lab testing. If you have any queries in between, please ask. Else I will continue. So now, before going into the modeling work, now we have gathered the in situ stress data, and now we have gathered the rock mass properties through testing, as well as our geotechnical mapping, etc., and calculation of RMR, Q system and all. So now, what all things we require? First thing is, we have to check the geometry of the excavations. What kind of excavation we are dealing with. We have to first study the plans, sections, and the geometry. And people sometimes model the ore body geometry, but ore body geometry is not what finally happens. As we know that when we do mining, we need to cut many corners. Ore body may be having a shape like this. Geologists, they supply an ore body with this kind of shape, but we cannot do mining like this. We have to do mining in between two levels, and the drilling pattern and all. So we have to consider the stoping geometry, the mining geometry or the stoping geometry. Then some problems you can define in 2D, but all problems cannot be defined in 2D. Like if you have a long tunnel, say 1 kilometer long tunnel, आपको पूरा 1 किलोमीटर का टनल मॉडल करने की कोई ज़रूरत नहीं है, आप उसका एक representative section ले लीजिए, that will give the idea about the whole tunnel. So you can simplify the model into 2D. If you have like symmetric pillars, like in coal mines you have Boden pillar, so you don't have to model all the pillars. You can take a quarter shape of a model, half roadway and half pillar. You can use it using planes of symmetry. So like that you can simplify. So now preparation of 3D geometries. So you have to first of all create the stope geometry using your CAD softwares like Surpac or Datamine or whatever. From that geometry has to be thoroughly studied, whether that is the actual geometry, whether any mistake is there or not. So that has to be first verified. And next thing is representation of geological discontinuities, like fault planes, shear planes, joint sets. These are all, sometimes some certain things are very crucial, discontinuities are to be separately modeled. Otherwise, it has to be incorporated. Otherwise, joint sets and all, those are part of the rock mass classification system. You can take constitutive properties. But certain, like if you have a fault plane, major fault plane, that has to be specifically modeled. Otherwise, it gives wrong results. Now, coming to instrument data collection. So why this is important is because whatever modeling you have done, you have to verify it with your field conditions. Because modeling, as I told you in the beginning, it is just a tool to help you to design. But whether the properties we have taken is correct or not, sometimes you have many guess values, like in situ stress measurement किया नहीं है, but फिर भी modeling करना है. So what you can do, you take guess values or theoretical equations. But whether how much it is really correct or not, so that these things have to be verified after the numerical model, and also from the field you have to collect data. Like MPPS data, it gives you the deformation of rock mass. Whether you are getting the same deformation which is predicted in the numerical model. If it is not, then you have to calibrate the model. That is called model calibration, validation and model calibration. So what all instrument data can help us in doing this? So one is this MPBX and stress cell data. The change in stress. The stress cell doesn't give absolute stress at that place. It gives the change in stress. आप जिस दिन लगाए हैं उस दिन zero reading है. उसका बाद जो stress add हुआ या कम हुआ, only that change you will get. So modeling also, if you want to compare, you have to first model the stage at which you put the instrument. Then you go back to the stage at which you did the further excavation, and then compare the stress change at that particular location. And roadway stability from displacements. From displacement measurement, there are many telltale, many instruments. And CMS, laser-based cavity monitoring system, this is a very important tool, because you have modeled a stope, and the modeling showed that up to 2 to 4 meters there will be a plastic zone. And in the CMS shown much more than that. That means I have taken higher properties for my rock mass. It has to be much. So we need to calibrate our numerical modeling and our input parameters based on the field data. So now, as I said, an overview of numerical modeling. This is a little bit basics. I hope I won't bore you. What is numerical modeling? So earlier, people used analytical solutions. They had equations. They tried to derive equations to find out stresses at each points and all. One example I can give in your rock mechanics textbooks. If you have read, rock mechanics was a subject in mining to all of you, I think. So, but we must have forgotten. So this is an equation which was derived, that if you have a circular opening, and if it is subject to a stress level of sigma, at any point outside this opening, you can find out the radial stress as well as tangential stress. radial stress is a stress occurring towards the excavation, and tangential stress is occurring across the excavation. You cannot derive an analytical solution for that. अब जितना आप आइंस्टाइन भी हो आपसे नहीं हो पाएगा. तो उसके लिए people have come out with different methods. Initially they used optical methods to do it, and later on finally we came to the idea of numerical simulation. So numerical modeling as of date is the only way you can find out the stresses around an opening. So only very few problems can give a closed form analytical solution. Only very, very few problems, like a simple beam. These things we must have studied in our BTech. But numerical modeling offers a versatile of problems can be solved using numerical modeling. So what is different from the numerical modeling and the analytical modeling? So numerical modeling, the basic concept is that breaking down of a complex problem into simpler ones. Say like we have a rectangular roadway here. So there are rock mass around here. So हमको सारी point में इसमें इसका stresses जानने की कोई ज़रूरत नहीं है. हमको discretely जानने से बस है, जैसे 1 meter distance में या half meter distance में. So what you do is you discretize. This is called discretization. Discretize the area where you are interested into smaller elements. And for each element is linked to the other. So there are certain governing equations, which I am not going into it because it becomes more theoretical. There are governing equations which controls how the stress transfer from one element to the other. So we can, by modeling this and using those governing equations and using a computer, you can evaluate the stresses occurring on each and every element. So the centroid of each element, we can get the stress levels. So that's all we require. So later on, then you can analyze the stresses using the failure criterion to see whether the rock mass in that particular zone is going to fail or whether it is going to remain stable or not. So this is how the concept of numerical modeling came. And when initially people used to hand calculate the stresses around this, they used to take several days to do that. But when computers came, they prepared algorithms to run this, and then from element 1 to the last element, it keeps on looping and looping, and finally it gives the solution for all the stresses around this opening. So what are the numerical modeling methods we have? Broadly, there are 4 methods. One is called finite element method. That is the most popular one. And it is used in a versatile of applications like aircraft modeling, mechanical engineering, civil engineering, mining engineering, and all geotechnical applications as well. And next one is called boundary element method. This is now almost obsolete now. Earlier times, as you know, when the computers just started, the computational time was a bit of a restriction at that time. So they invented this method called boundary element, in which, like as I earlier said, here in this, the entire domain is discretized. But in boundary element, only the boundary of the excavations are discretized. So it gives very quick solution. Otherwise, it takes a lot of time, and those days when Pentiums and 486 and all were in operation, it was very difficult to run finite element models. So boundary element gave a quick solution. But the problem, it has got certain limitations, like only near the boundary of the excavations, it gives correct values. All other areas, it gives extrapolated values. So third one is finite difference method. This is called an explicit solution scheme, in which here also, similarly, like finite element method, the entire domain is discretized. It takes a lot of time again to run. And FLAC 3D, which we all use, it follows finite difference method. And the fourth one is the most advanced one, that is called the distinct element method. So in finite element method and finite difference method, we consider one element welded to the other. So it is called welded contact. So it is a continuum mechanics. That is called continuum mechanics. But if you have discontinuous, discontinuities like a fault plane, so how will you model in finite element method? It is very difficult to model. So they have evolved this new method called distinct element method, in which you can make blocks. You can do block modeling, and then you can apply properties for the joints, planes, and fault planes, etc. And you can allow the blocks to move within. They are not fully welded to each other. So 3DEC, which is software which we have, we use it for modeling, specific modeling for discontinuum mechanics problems. So briefly, finite element, as I already told you, it is a very versatile and very flexible tool. ANSYS is a very popular software. Nastran, Abacus, these are all being used these days. But it requires good amount of computer memory. So nowadays you have supercomputers, multi-core processors. So with the help of that, you can run this. Boundary element, as I told you, it has limited application. Now it is almost obsolete. But there are some software still with rock science, I think. They are still using boundary element. It gives very quick solution. But its accuracy inside the rock mass is a bit questionable. Finite difference, as I told you, it's a similar pattern. Only the solution scheme is different compared to finite element. Otherwise, both are very similar. The softwares, popular softwares, FLAC and FLAC 3D, which we use. And finally, distinct element method. Here, certain problems like caving, slope failure. These things involves block movements, actually. So to simulate that more accurately, you have to use distinct element codes. So that is a UDEC, 3DEC, PFC code. These are some softwares which are available, and we have with us in SimFer. So for a preparation of the numerical model, I already explained this. You need to know the geometry, the rock properties, the elastic constants. Elastic constants is Young's modulus, Poisson's ratio, and density. These are the basic things you require to start a model. But to study how it is going to fail or whether the stresses are causing the material to fail, you need rock mass strength parameters like UCS, etc., and RMR for rock mass. And in situ stress field, this is very important thing which you should know before starting the model. And there is something called boundary conditions. Boundary conditions is like, as I explained here, say if we are talking about a tunnel here, so around, at least say if the tunnel is say 5 meter by 5 meter size, say about 50 meters beyond that, the rock mass is unaffected. We can assume that the rock mass is unaffected by this. So you can place a boundary of this, when you are modeling this, you have to place the boundary far away from the roadway. And bottom is this, you can consider it as a fixed boundary. It doesn't move. So again, after some 40-50 meters below the tunnel, we believe that the rock mass is stable. And on the top, say if it is surface, then it is called a free boundary. Like that, we can construct the model by defining the boundaries. So boundary conditions are very important in modeling. Say for example, you didn't fix this boundary, the left boundary, it has to be fixed in vertical. It should not be allowed to move in horizontal. If you forgot to give this thing, this model will never converge. It keeps on running for hours and days together, but you will not get the results. So applying boundary condition is very important. So what are the steps involved in numerical modeling? First, you have to create a mesh. Like as I told, discretization. So the finer the mesh, the more accurate the results are. But when you refine the mesh, it takes more memory and it takes more time to run. Say if the mesh created is of 5, we check the the size of the model. So if it is 4 gigabyte, 10 gigabyte is the size of the mesh, then it will take almost couple of days to run. So if you can reduce the mesh size, then you can run it faster. But you are compromising on the accuracy. and the extent of the mesh. Say, for example, Pradeep is modeling SK mine, a part of SK mine. So a kilometer away, it is not affected. 5-6 kilometer away, there is Rajpura Dariba mine. The Rajpura Dariba mine is not affected by SK mine. So we should know to what extent this excavation would affect. So usually 200 to 300 meters away from your last excavation, the rock mass there remains unmoved. So that way we have to define the extent of the mesh. And next thing is you have to set the gravity parameters and apply the in-situ stress field and the applied forces. Sometimes you don't have to model the entire mine up to the surface. You truncate it at some certain height, and above that you apply the vertical stress from the surface. So that way you can truncate the model. So this will all help you in running time. And set the boundary conditions and set the material properties and the rock mass properties. So these are the essential things before running the model. And now, before you run the models, there are stages in which you have to run the model. This is very important. Many people run the model in one go. In one go, you will not get result. You have to run it in stages. First, the virgin state has to be simulated. That is pre-mining state. Next thing is, but before running the next stage, you have to initialize all the displacements and velocities to 0. And then you make the excavations in stages. ऐसा नहीं कि आपका माइन तो एक दिन में नहीं बना है. Different period you have made different stoping. So you have to make the excavation in different stages. Stage by stage you have to excavate. And then equilibrate the model at every stage. And every stage, wherever it is of your interest, you analyze the stresses, displacement, and stability, and then that will help you in modeling. So planes of symmetry, as I told you, in mathematics, these are some of the advantages. We can cut short, like if you are modeling a tunnel, you don't have to model the full tunnel, you can model half the tunnel. Because if you take the central line, both the sides have the same stress values. So there are some methods to truncate your model by using planes of symmetry. So planes of symmetry really helps us sometime to make the model run faster, because the number of elements will be less. So these are some important things like extent and fineness of the mesh, and solution and post-processing. So once the model has given its solution, now it is now your turn. मॉडल अपना काम कर लिया, अपना स्ट्रेस वैल्यू सब जगह दे दिया, अभी आपका पारी है. नाउ यू हैव टू सिट एंड एनालाइज, एक एक सेक्शंस देखेंगे, 3D में देखेंगे, कहाँ स्ट्रेसेस ज़्यादा है, कहाँ कम है, कहाँ लाइकली फेलियर है, एंड कहाँ पे स्टेबल है, और अपना पिलर का साइज रिड्यूस कर सकता है. अगर मान लिया पिलर काफ़ी स्ट्रॉन्ग है, दिख रहा है, कोई यील्डिंग नहीं है उसमें, तो अपन इतना बड़ा पिलर क्यों छोड़ेंगे. So हम लोग पिलर रिड्यूस करके नेक्स्ट साइकिल रन करेंगे. So then again you check. So you can optimize your mining parameters based on numerical model. That is the advantage of numerical modeling. Earlier, in the absence of this, people used to do field trials. मैंने 20 मीटर पिलर छोड़ा, बहुत स्टेबल है, चलो 10 मीटर करके देखते हैं. 10 मीटर किया, वो पिलर कोलैप्स किया, तब आपको पता चला कि 10 मीटर नहीं चलेगा, आपको 20 मीटर. तो नाउ यू कैन डू दिस इन न्यूमेरिकल मॉडल एंड देन अप्लाई इट इन द फील्ड. So continuing with the case examples, now I would like to, so this is all about the theory about numerical modeling. Those who are interested in learning numerical model, you can go through it, and then there are textbooks available. There are even a lot of material in internet available. You can learn it. So I would like to give a few examples. This is a very old model actually. I run at least 10 years ago. This is a case study of Rajpura Dariba mine where we optimize the crown pillar. So we use simple 2D modeling for this. So this is the Rajpura Dariba mines LVS, where part LVS, where vertical retreat mining was being done using hydraulic filling. And ore body is steeply dipping, and width is 7 to 25 meters. And individual stopes had a width of 15 meter in strike. and stopes extracted using sublevels of 20 to 35 meter interval. So in primary, secondary sequence with hydraulic backfilling they are doing. In situ stress was measured there. These are the measured values of in situ stress, and this was done by National Institute of Rock Mechanics, NIRM, as well as Messi India Limited, and somewhat these are the values. So the major horizontal stress you can see at the surface, it is 12.9 MPa, and then gradually it increases as it goes down at this gradient, 0.025 per meter, megapascal per meter, it keeps on increasing. And minor principal stress, it's 10 MPa at the surface, and it goes at 0.01 per meter. And vertical stress, it is almost the density of the rock. 0.0 unit rock pressure comes to be 0.0297 into the depth. So this was measured, and then the rock properties used, major rock properties used for this modeling are given as this. So an RMR of 55 was there. But here the problem is something else. Problem is here you can see that there is a shear plane, this green color patches. These green color patches are shear planes, both at hanging wall contact as well as footwall contact. So this was playing a big havoc there. So here they had to define the crown pillar between two levels here. These two levels, they had to define the crown pillar. So here in this mesh, you can see that wherever your area of interest is, there you will have fine mesh. So you need results close by. Where you don't have interest, like on the surface, I am not interested, I am not studying the stresses there. So there you can have a coarse mesh. You can have larger element size. So this is how you need to prepare a model. This is a simple example. So here you can see that we did study for a 41 meter thick crown pillar, and this was the stability aspect. So here the, other than blue patch, this is the yield zones. So here from field study we have found that if the yield zone from the top and the bottom, these two merge together, that is not a favorable scenario. That can cause a pillar failure. So you need a core of the pillar which remains unyielded after mining. So 41 meter thick pillar, you can see that the crown pillar is highly stable. But if you see the 31 meter, then we reduced it to 31 meter, you can see that the yield zone from the bottom and the top, they both merge together, and this can cause a cable bolts. So with this, we can get an idea how much should be the crown pillar. In L2 lens, here again, this red one is the ore body, and the green patch is the shear plane. Here also again we did the model, 25 meter thick, because here the ore body is thinner. So 25 meter thick crown pillar was giving very good stability, but 15 meter thick, when you reduce it to 15, it fails completely. So we found that 20 meter is an optimum. So this is just an example how, so finally what we recommended those days, this was long ago, so it's now not relevant. In South Lode, the recommended thickness was 35 to 40 meter. And in the North Lode, the recommended crown pillar requirement was 20 to 25 meter. And along the strike, the ore body width varies. So we had a differential type of crown there. So wherever the ore body is wider, there the crown was thicker. And wherever it was thinner, we could further reduce it. So this was the Rajpura Deriva case example. This is one interesting mine, Kayad mine, you might have heard. So Kayad mine is a mine near Ajmer, and here the ore body is very peculiar, I should say. It is a chair shaped, shape of a chair. So in the top portion, the ore body is very steeply dipping, and in the bottom portion, it is flat. So here in this mine, due to several practical difficulties, you cannot have a hydraulic fill or a paste fill. So they are going for CRF, that is, Mr. Prashant has already explained what is CRF. So, cemented rock fill. So the waste rock, you mix it with cement slurry and then dump it into the stove. It's very cheap actually, and it gives very good strength also. So this chair-shaped ore body was excavated. The top portion excavation was very simple. Sub-level stoping methods they used with of course they started from the bottom and then filled and went up. It was very easy. So how we going to mine this flatter portion? So for flatter portion, this is the block, the red color block that they call it the block 3. So for that, we came out with a modeling. This is the numerical model we created. These are the stopes. So the blue, the green and the red are alternate primary and secondary stopes. So transverse way, we were mining this. So but here, if you leave, and there is one more thing about this mine is the surface is very sensitive area. It has mosque, temple, and vegetation, agriculture land, and also villages. So the surface is very sensitive. We know that like in coal mining, flatter deposits, if you mine, it results in subsidence. There is no scope for subsidence because it's a very sensitive area. So we have to mine this flatter ore body without causing a subsidence. So how much ore we need to lose? So here we did modeling, and then in stages we did. First modeling of the primary stopes. Primary stopes means alternate transverse stopes. It was okay, and it was anticipated that there won't be much yielding to the surface. But when we did secondary stopes, alternate secondary stopes, not all the secondary stopes, alternate secondary stopes, the yielding goes up to 10 meter into the roof. 10 meter into the roof, there is yielding. But this is also manageable because we have cable bolting system. So with cable bolting, up to 10 to 12 meter yielding can be managed. But now if you mine completely, the yielding height goes up to 30 meters. That is beyond the scope of our any artificial supports. So we need to restrict the mining. So finally, we decided that instead of leaving all the tertiary stopes, if we leave all the tertiary stopes, so many stopes has to be left out. So that is too much loss of ore. So we decided we will leave some post pillars in between. When we mine the tertiary stopes, primary and secondary will mine fully, and tertiary stopes we will put pillars. So here we designed a post pillar in this. Here, this side, the north side stopes has a maximum width of 30 meters. So here we don't require a post pillar. But the southern side stopes is pretty long. This is almost 100 meters from this end to this end. And this is also 100 by 100 is 1 hectare land. So 1 hectare land we cannot expose just like that. So we put post pillars carefully designed of different sizes. And then we finally did the modeling, and we found that we could restrict the yielding to 10 to 12 meters into the roof by doing this method. So by leaving hardly 5 to 6% of ore, we could extract that entire horizontal shaped ore body. So 12 meters was the maximum yielding, and when they did mining, they applied cable bolts in this fashion. This is the fan-shaped cable bolting, and they did CRF filling. This was the blasting pattern, and here you can see that with CRF, very good shoulder formation has been formed. And while blasting, one thing what they did is, because in CRF, we cannot fill up to the top, because it is done by your dumpers. Dumper carry this material and dump into the stove. So the height of the dumper, that roadway remains open. So instead of, so if you blast it completely, then it becomes a very wide stove back. So in order to control the stove back, they blasted in such a way to form shoulders here. So there are some holes here drilled which was not charged. The top holes were not charged, and like that, in this figure you can see that even after blasting the entire stove, the roadway remains almost intact. So this is called proper shoulder formation. And in secondary stopes, you can see this is not so good shoulder formation. Here it has overbroken. Primary stopes had very good shoulders, but not in the secondary stopes. So this is how it was done. And on the top, 250 MRL, there was a exploratory drive. So that was abandoned sort of, but they reopened it and put MPBX from there downhole, and they found that none of the MPBX showed any significant movement. That means the subsidence was controlled there, and it resulted in zero subsidence. So CRF is also a very good option for doing for stopping in case if you don't have mill tailings. So some mines, they do the development. Okay, so there is not much time. We need some time for discussions. Okay, one more case example I will show you. This is the modeling of split set friction bolt. This was presented in Asian Mining Congress. If any of you have attended, must have listened to it. This is a split set. You know, it's a C-section. It's a what you call a molded sheet of metal, sheet of iron. It is in C shape. You can see here. So this concept is very simple. You have a hole which is undersized, say 38 mm hole, and the diameter of this split set will be 42 mm or something like that, 42, 43 like that. So it is larger than the hole size. But it has got a taper at the front. So using the taper, you force this using your drill machine, you force it into the rock mass. So once it goes into the rock mass, the C-section closes and it offers friction between rock and the bolt. So this is a very simple technique to support your rock mass. Initially in HZL, this was used only for for secondary supports. Short size split sets were used for pinning the your wire mesh. And then resin bolts were installed as a regular support. But now DGMS has given permission only in Jawar mines. Some mines they have given permission to use it as primary supports instead of resin bolts for temporary roadways. Because this has got certain advantages and disadvantages. Main advantage is it is much cheaper. It compared to resin bolts, it's maybe half the cost or even less. And it is quick installation. In 30 seconds, you can install the bolt. And it instantly comes to action. A cement bolt takes several hours for it to fully come into action. By that time, lots of rock movement must have already happened. Some loose formation at the collar must have already happened. But this one instantly comes to its action. And resin bolts also within few seconds, within a minute, it comes into action. And one main advantage is when you blast, because in ore drives and ore cross cuts, you need to blast it. So when you blast, this resin bolts are very difficult to separate out from the rock. It gets stuck to it. And then it always causes problem with your loader. When the loader goes to pick, at that time a rod must be standing like this. But here, there is no physical contact, it's only frictional contact, so it separates out quickly. And steel split set tested in Jawar mines, it gives up to 15 ton of load. Even in SK mines also they have tested and they have gone up to 15 to 16 tons of load. And there are a different type of split set using fiber split sets. So fiber split sets are flexible in nature. That also gives a 10, 12 ton of load. And it can be used in seismic zones where you have, there are chances of seismicity. So sudden burst of rock. So it gives a flexibility. So it cushions the throw of the rock. And then this fiber split sets are flexible, and in some cases it is cuttable also. So like in coal mines, you have this continuous miners. So they ask, because the wall, it becomes the coal wall, the pillar wall goes high as 4.5 meters, 5 meters. So there they ask to install bolts. So if it is steel bolt, the machine cannot cut through that. But these bolts can be cut. But the disadvantage is it is a thin sheet and it is open both the sides. So it is susceptible to corrosion and rusting. So, and the C section loses its temper over a period of time. So that's why it is used, it is allowed, permitted as a primary support only in temporary roadways, which has only few months life. So, and its load bearing capacity is definitely lower than that of the resin bowls. So here, I will skip, quickly go through it. So this is the case where I said that in highly weathered rock mass, it is very difficult to install normal rock bolts like cement bolts and resin bolts. Resin bolts churning and all, it causes problem. So here, this is very effective. So the split sets were very effective. And then split sets, and along with split sets, if you use shotcreting and wear meshing, it gives a very good supports for the roadways. And in paste fill redevelopment, in paste fill also you cannot install resin bolts. So there also it is very handy. In all this paste fill redeveloped roadways, they are using split sets quite effectively. So we have done some numerical modeling how it really works and conducted pull-out tests numerically, and we got very good results. And then I'm not going to the details of it. So Mr. Nageshwar Rao had covered this portion, how we did the modeling of this. And we found the effect of bolt length, the bolt diameter. If you vary the bolt length, bolt diameter, how its strength varies. So this was done in a detailed parametric study. And we conducted tests in Jawar mines. And you can see this is the pull-out load. You must have seen it in your mines. Pull-out load measuring device. And then this is a pulled-out split set. So we compared the numerical modeling value along with the field-tested value. We got very good correlation here with the correlation coefficient of 0.82. So we can say that this is the numerical modeling value is the ideal value. That is the maximum it can give. It assumes uniform contact between the rock mass and the split set. But in reality, it won't happen. Sometimes due to undulations in sometimes the diameter of the hole may vary. At the collar, it may be a little bit more. So like that, but we gave from the testing, we got 82% efficacy. That means very good drilling and very good installation of split sets. So that's all I would like to end here in my talk. Thank you all very much for your patient hearing.
Thank you, Dr. John Louis. To felicitate Dr. John Louis, I would like to invite our ED sir, Prashant Karaya sir, to felicitate with shawl and sreefal and present a memento. Sir. प्रोजेक्टर बंद कर दो, वो लाइट आता नहीं. Hello, hello, hello. थैंक यू सर. और अगला पड़ाव है कुछ क्वेश्चन आर का. सो उसके बाद वैलिडेटरी फंक्शन. तो मैं आपसे अनुरोध करता हूं कि जो साथी आपके बाहर हैं आप सबको बुला लें और एक क्वेश्चन आर के लिए मैं मंच तैयार करता हूं. बाहर देखना, ज्ञानेश्वर वो है क्या, सुशांत और ज्ञानेश्वर, ये ऊपर कहाँ से जुगाड़ है? सर फैकल्टीज बैठेंगे ऊपर, प्लीज। डॉक्टर सरकार आ जाओ। जो स्पीकर हैं वो प्लीज दे आर वेलकम ऑन द डैश। जो लोग हैं वो आ जाएं, जो स्पीकर्स अवेलेबल हैं वो ऊपर आ जाएं। If you have any questions related to any topic in this 2 days national workshop, आप पूछ सकते हैं।
आप लोग को कैसे लगा? बहुत ज़्यादा बोरिंग था क्या?
आप क्वेश्चन बोल सकते हैं, अपना फीडबैक भी दे सकते हैं।
Suggestion and any feedback, what would you feel, what would you like to implement the field, because then only the workshop, the objective of workshop can be met. This is how we differentiate between seminar and symposium.
आप लोग नेक्स्ट टाइम कम से कम करेक्ट कर सकते हैं।
The most important part workshop ये interaction the most उसका main वो है, central part है workshop। So I would request at least 2 to 3 delegates from each organization.
Please, sir.
Please.
Sir, introduce yourself. Sir, I am Akash Mata. I am from Gunggaon Mine Mall. मेरा क्वेश्चन है सर, जो न्यूमेरिकल मॉडलिंग के ऊपर आप बताए सर, तो न्यूमेरिकल मॉडलिंग का हर पैरामीटर्स में जैसे हम लोग जो प्रैक्टिकली जो फेस करते हैं, आज माइन का इस पार्ट में अलग स्टार्टा मिलता है, थोड़ा दूर जाए अलग स्टार्टा मिलता है, तो हर पार्ट का अलग अलग मॉडलिंग करना पड़ेगा।
यस सर। मॉडलिंग में वही एडवांटेज है आपको, जो डोमेन है उसमें आपको ओवर बॉडी है, हैंगिंग वॉल है, फुट वॉल है, और यह ओवर बॉडी में भी अलग अलग टाइप का रॉक मास है। तो उसमें क्या है कि आपको अलग अलग प्रॉपर्टीज दे सकते हैं।
नहीं, मेनली सर ओवर बॉडी ठीक है सर, ओवर बॉडी के साथ साथ हम लोग ड्राइवेजेस भी हैं,
ये वो तो फुट वॉल में या हैंग वॉल में, तो हैंग वॉल का प्रॉपर्टी अलग दे सकते हैं। इवन ओवर बॉडी के अंदर में भी मैंने वो जो शियर प्लेन बताया ना, तो गरीबा माइन का, उसमें भी ओर बॉडी का प्रॉपर्टी अलग है, शियर जोन का प्रॉपर्टी अलग है, क्योंकि शियर जोन बहुत ही वीक है।
तो उसका सपोर्ट डिजाइन अलग करना पड़ेगा।
नहीं, उसका मॉडल करेंगे। अगर शियर जोन में आपका रोडवे आता है तो आपको उसका सपोर्ट डिजाइन अलग रहेगा, अलग देना पड़ेगा। इसलिए हम लोग जो अभी कॉम्प्रिहेंसिव इधर हिंदुस्तान जिंक का सारी माइंस के लिए कॉम्प्रिहेंसिव एसएसआर निकाले हैं। उसमें क्या है कि डेप्थ वाइज, रॉक टाइप वाइज एंड आरएमआर वाइज, रॉक मास प्रॉपर्टी वाइज अलग अलग सपोर्ट दिया है। सेम सपोर्ट नहीं है सभी रोडवे में, और साइज का भी हिसाब से। देयर आर लार्ज एक्सकवेशंस, जैसे रैम्प का जो पासिंग वे है जहाँ पे आपको गाड़ी क्रॉस करते हैं, वो 10 मीटर वाइड है, तो वहाँ पे केबल बोर्ड्स और लंबा चौड़ा सपोर्टिंग है वहाँ पे। जैसे सम्प है आपका, वर्कशॉप है, अंडरग्राउंड वर्कशॉप है, और रोडवे भी अलग अलग साइज का है, 4x4 से लेके 5.5x5.5 तक है, तो सबके लिए सपोर्ट सिस्टम अलग है। तो इन लोगों ने कॉम्प्रिहेंसिव चार्ट बनाया है। तो और इन लोग उसका जो सपोर्ट्स का जो चार्ट्स है सब जगह माइंस में, अंडरग्राउंड में भी, सरफेस में भी सब छाप के रखा है, ताकि आपका 4.3 बाई 4 मीटर हाइट का जो रोडवे है उसके लिए ऐसा ऐसा बोर्ड लगेगा। और 5 रैम्प के लिए वो आर्च शेप है, उसका जो ऊपर में डी शेप का है, तो उसका अलग सपोर्ट रहेगा। तो ये सब मॉडलिंग करके निकाला है हम लोग। तो वो जो एरिया का जो रॉक मास है वहाँ का रॉक प्रॉपर्टीज से स्पेसिफिकली डाल के उससे रॉक लोड हाइट निकालते हैं, उसमें से सपोर्ट डिजाइन करते हैं।
इवन जी सर, आप यादव का डॉक्टर जॉन मतलब जो है, इवन विद इन ऑयल माइंस आल्सो, some around 15 years back we have conducted a comprehensive study for all underground mines at that time, and I think we had designed support system for Tribal, Hindwal, Football at different levels for Balaghat, Utwa, Chikla, Beldongri, Mansar, Kandri at that time. So, but this exercise has to be, I think, repeated periodically, because as you go deeper, rock mass बदलता है, उसकी property बदलती है, support system में भी काफी better changes आते हैं, so we have to evolve accordingly. So हमारा session ये रहेगा कि अब जो हम नीचे जाते हैं, जो advance करते हैं both laterally and vertically, rock mass का properties which requires suppose a unique support system that also undergo changes. तो अपने को जो investigations है, जो scientific investigation है, that needs to be repeatedly done on periodical basis. Time कितना होना चाहिए, that depends from mine to mine, both for ore body and for country rocks, involved footwall, at least for underground, mainly for underground drivages. जो drivages permanent रहने वाली हैं, जो footwall drivages हैं, crosscuts हैं, उनके लिए support system है. So that is most important.
One more thing, हम लोग पहले डिजाइन किया फ्रॉम न्यूमेरिकल मॉडल, बट अभी एसके माइन में जो हम लोग जो एसएसआर बनाया था, उसमें भी हम लोग पिछले 1 साल के अंदर में काफ़ी चेंजेस फिर भी लाए। उसका रीज़न क्या है कि अभी लोग का माइन 1.2 किलोमीटर डीप चला गया। अभी क्या होता है कि साइड से बहुत सारा फेलियर आता है, रूफ से ज़्यादा साइड बल्जिंग बहुत ज़्यादा है। तो इन लोगों का जो वायर मैशिंग और शॉर्टकटिंग था, पहले ग्रेड लाइन तक था, ग्रेड लाइन एंड रूफ ग्रेड लाइन टू ग्रेड लाइन था। इनिशियली दे स्टार्टेड फ्रॉम शोल्डर टू शोल्डर, अभी ग्रेड लाइन टू ग्रेड लाइन कर रहा था। इवन दैट वाज नॉट सफिशिएंट, अभी फ्लोर टू फ्लोर कर रहे, सीधा फुल आर्च। आप वो डायग्राम फोटोज दिखाया होगा, सीधा नीचे से लेके इस एंड तक फुल वायर मैशिंग एंड शॉर्टकटिंग प्रॉब्लम। दिस वाज अ चेंज डन फ्यू मंथ्स बैक अगो, बिकॉज जो अप्रूव्ड एसएसआर उसमें वो नहीं था, बट वी हैड टू इनकॉर्पोरेट दैट, बिकॉज द चेंजिंग कंडीशंस के साथ आपको बदलते रहना पड़ेगा।
और स्पेशली इनवेरिएबली हैंगवाल तो वीकर है ही, as far as our knowledge working almost all the mines of oil limited, हैंगवाल is relatively weaker than footwall, so it requires specific support system। और अभी तो इतना इवोल्यूशन हुआ सपोर्ट सिस्टम में कि कितना भी वीक हो भी हैंगवाल डायल्यूशन रोकने के लिए, और तो जो वर्क आदमी आपके तो स्टॉक में एक्टिवली मैन पावर रहता है, तो वहाँ सपोर्ट बिकम्स मोर क्रिटिकल फॉर डॉक्टर रिकवरी ऑल्सो एंड फ्रॉम द सेफ्टी पॉइंट ऑफ व्यू ऑल्सो। सो इसीलिए पीरियोडिक इन्वेस्टिगेशन ऑफ द साइंटिफिक कैरेक्टरिस्टिक्स ऑफ दैट कंट्री रॉक एंड अकॉर्डिंगली इवैल्यूएशन ऑफ द सपोर्ट डिजाइन, both should go hand in hand as we go deeper and as we advance laterally also.
One more thing, ये जो सीमेंट बोर्ड्स आप लोग यूज करते हैं अभी, वो इतने इफेक्टिव नहीं है। वो मोस्टली उसका प्रॉब्लम क्या है कि उसमें कॉलर सपोर्ट जो है प्रॉपर नहीं मिलता है, इसलिए अप टू 1 फीट टू हाफ मीटर वो अनसपोर्टेड ही रहता है, उसके बाद वो सीमेंट बोल्ट एक्शन में आता है। तो यू नीड टू अपग्रेड टू रेजिन बोल्ट्स, पर रेजिन बोल्टिंग जो है आप मैनुअली नहीं कर सकता, इट इज़ वेरी डिफिकल्ट टू डू, उसके लिए आपको मशीन्स चाहिए, रॉक बोल्टर्स चाहिए। रॉक बोल्टर आपका जो करंट इंफ्रास्ट्रक्चर में रॉक बोल्टर को लाना बहुत डिफिकल्ट है, तो इसलिए दैट्स व्हाई आई वांट टू प्रेस दैट यू पीपल व्हेन यू गो बैक टू योर माइंड्स यू शुड insist that your mind should have to improve to mechanization. तो mechanization में जाना है तो आपको you need to take the machineries inside, you may require declines. So इसलिए आप लोग थोड़ा बहुत उसमें प्रेशराइज कीजिए कि आपको मॉडर्नाइज करना है माइंड को, तो you require machineries. And machineries के लिए शाफ्ट में खोल करके ले जाना is very very difficult. Limitation है, छोटा छोटा पार्ट्स ले जा सकता है, but some of the machineries come with large parts. वो शाफ्ट में नहीं जाएगा, so it is very important.
प्लीज प्लीज एक तो माइक दे सकते हैं क्या?
माइक
क्या इधर से दे दीजिए, हम तो जोर से बोल लेंगे।
बेस्ट फिलिंग में सर फिलिंग फैक्टर कितना रहेगा सर?
प्लीज
बेस्ट फिलिंग में फिलिंग फैक्टर कितना रहेगा? कितना परसेंट हो सकता है फिलिंग फैक्टर?
फिलिंग फैक्टर
यस सर।
Efficiency, efficiency you mean efficiency?
फिलिंग में मैंने परसेंटेज ऑफ
सपोज एक स्टॉप से सपोज 100 टन निकालो और मक निकालो, उसमें बेस्ट फिलिंग कितना टन फिल कर सकते हैं?
नहीं वो पॉइंट इज उसमें कुछ रेस्ट्रिक्शन व्हाट यू सेड इज राइट, से आपने एक वाइड क्रिएट किया, तो इसमें जो आप बैकफिल करते हैं तो बैकफिल कवर्स द एंटायर थिंग, बट ऊपर में कुछ जगह खाली रह जाता है, बिकॉज यू हैव टू पुट योर पाइपलाइंस एंड ऑल, at least up to 2 meters height they can fill, उसको ऊपर fill नहीं कर सकता, so some volume remains open there. इसलिए उसको reduce करने के लिए जो ऊपर में जो आपका जो क्रॉस कट है, जो ड्राइव है, वो ड्राइव को पूरा ब्लास्ट नहीं करेंगे, ड्राइव का साइज जो है शोल्डर्स को रख देंगे, तब क्या होता है कि वो रोडवे का फ्लोर तक बढ़ जाएगा, या थोड़ा और 1-2 मीटर और बढ़ा सकते हैं, थोड़ा बैरिकेडिंग करके बढ़ा सकते हैं, so very little volume remains, so almost 90-95% of that volume can be backfill. That is what you are asking, na?
Yes,
factor.
सर क्वेश्चन सर उसमें आरएमआर का सब सपोज हिंदुस्तान जिंक में उसका आरएमआर कम रहेगा सर, 40 to 50% रहेगा, वो भी इसमें उसको वेस्ट वेस्ट अपना टैलेंट था ना, टैलेंट से उसका आरएमआर भी कम होता है। अभी सपोज मलस्कन में आरएमआर
नहीं प्लीज आरएमआर को आप बेस्ट फिल सर रिलेट मत करो, बेस्ट फिल का आरएमआर नहीं होता है
सर, उसका स्ट्रेंथ आपका स्ट्रेंथ पूछ रहा हूं,
उसको आरएमआर मत बोलो, आरएमआर रॉक मास का होता है।
नहीं सर, रॉक स्ट्रेंथ पूछ रहा हूं बस।
पार्डन?
रॉक स्ट्रेंथ पूछ रहा हूं।
स्ट्रेंथ बोलो, स्ट्रेंथ बोल दो।
बेस्ट का स्ट्रेंथ यस सर।
हां आरएमआर
सपोज इसमें हिंदुस्तान जिंक में रॉक स्ट्रेंथ कम रहेगा सर, अभी मलस्कन में कॉपर में रॉक स्ट्रेंथ ज्यादा रहेगा, इसमें डिफरेंस दे सब रॉक स्ट्रेंथ कम रहेगा, उस हिसाब से कंप्रेस पेस्ट फिलिंग को करने टाइम पे वो कंप्रेस ज्यादा रहता है सर, ऑप्शन कम रहेगा तो
नहीं व्हाट ही मींस भाई वो सीमेंट आपका पेस्ट फिल में केवल ये कोई दिक्कत नहीं, पेस्ट फिल में सीमेंट परसेंटेज कितना है, वो स्ट्रेंथ जो है ना पेस्ट फिल का जो कंप्रेसिव स्ट्रेंथ है, उसका जो इंस्टेंट कंप्रेसिव स्ट्रेंथ डेवलप होता है दैट इज आल्सो कंट्रोल्ड बाय द परसेंट ऑफ सीमेंट इन दैट पेस्ट।
ओके सर।
Look, one thing I want to tell you, ये जो पेस्ट फिल है, ये पेस्ट फिल रॉक मास से कोई कंपैरिजन नहीं है, कोई कंपैरिजन नहीं है। रीजन बता रहा, रॉक मास का जो मॉडुलस है, यंग्स मॉडुलस जो भी बोलेंगे, डिफॉर्मेशन मॉडुलस, वो एमपीएस में रहता है, 20 MPa, 30 MPa, इवन 100 MPa तक जाता है, इट इज वेरी सॉलिड रॉक। और ये पेस्ट फिल है वो किलो पास्कल में रहता है उसका मॉडुलस, it is hardly 1 gigapascal भी नहीं पहुंचता है, it is 100 kilopascal 200, तो रॉक का रिप्लेसमेंट नहीं है, पेस्ट फिल इज नो रिप्लेसमेंट फॉर रॉक, वो आप अच्छा से समझ लीजिए, it has got enough strength to drive ड्राइवेज थ्रू इट, रीजन क्या है कि उसमें स्ट्रेस नहीं होता। जैसे फॉर एग्जांपल ये एक हार्ड सरफेस है, ये सॉफ्ट सरफेस है, मान लीजिए ये रॉक है, ये पेस्टल है, ये हार्ड है, ये सॉफ्ट है। इसके ऊपर आपने वेट रख दिया, ये सॉफ्ट पोर्शन तो दब जाएगा, अब सारी वेट ये हार्ड पोर्शन लेगा। ओके, तो स्ट्रेस ट्रांसफर इनटू द पेस्टल इज वेरी वेरी लेस। इसमें 1 मेगापास्कल भी स्ट्रेस नहीं होता। जब रॉक में 25-30 मेगापास्कल स्ट्रेस है, इसमें जो ट्रांसफर होता है बहुत ही कम। So it is not a 100%, it is not a comparable at all. रॉक मास बहुत ही सॉलिड चीज है, उसका कोई आर्टिफिशियल चीज से आप कंपेयर ही नहीं कर सकते।
और एक क्वेश्चन सर, इस सीआरएफ है सर, सीमेंट रॉक फिलिंग है, इसमें सीमेंट कितना परसेंट यूज करते हैं?
वो डिपेंड करता है, बट 5 to 6% सीमेंट उसमें जाता है। एक स्लरी बनाता है 5 to 6%। टू कंपेयर द वेस्ट रॉक एंड कंपेयर द सॉलिड्स, उसमें जो सॉलिड है थोड़ा वाटर उसमें रहेगा, वो इट विल बी अब्सॉर्ब्ड बाय द सीमेंट। एंड जो इफ यू सी द रॉक एंड द सीमेंट 5% का आसपास 5 to 6%
फिलिंग कितना रहता है? सपोज रॉक मतलब रॉक में डालेगा तो बीच में गैप भी, स्पेस भी बढ़ेगा, स्पेस भी ऑक्यूपाई करेगा, इसमें कितना परसेंट फिल कर सकते हैं सर?
देखिए ये जो वेस्ट फिल है, जब सिंपल वेस्ट डालते हैं उसमें 10-20% वॉइड रहता है। ओके, बट पेस्ट फिल में 0 वॉइड है, वो पूरा सॉलिड बन जाता है।
फिलिंग एफिशिएंट 100% है।
सीमेंटेड हाइड्रोलिक फिल में भी कोई गैप नहीं रहता। तो होमोजेनियस केवल सैंड फिलिंग जो है उसमें अराउंड 5% to 10% वॉइड रहता है। बट ये सीमेंटेड फिल का कंसेप्ट वही है कि उसमें वॉइड ना रहे, वॉइड नहीं रहेगा उसमें। सीआरएफ में भी बहुत ही कम वॉइड रहता है, उसमें भी रहता है, थोड़ा वॉइड रहता है, बिकॉज सीमेंट द स्लरी may not go into all the crevices, so some void will remain, 5% to 10% maybe a void, but it becomes solid. It's like a concrete जैसे बनाता है ना, जैसे आप कंक्रीट बनता है, जैसे ग्रेवल सैंड और सीमेंट मिक्स करके बनता है, इट बिकम्स कंक्रीट, वो सेट हो गया कंक्रीट। सीआरएफ भी वैसे सेट होता है, रफली 1 मेगापास्कल to 1.5 मेगापास्कल का स्ट्रेंथ गेन करता है।
In literature even 7 megapascal is obtained in laboratory test. Some say it is reported.
ये आर्टिफिशियल रॉक मास हो गया एक प्रकार से, है ना? इट इज एज गुड एज आर्टिफिशियल रॉक मास ऑफ लोअर स्ट्रेंथ एज कंपेयर्ड टू नेचुरल रॉक मास।
The strength of rock, this CRF will depend also on host rock also, right? Because you are taking some lumps, some host rock. So how, what kind of host rock is there? It will depend on your strength also.
उसमें सिल्फर ने काफी एक्सटेंसिव टेस्टिंग किया। उसमें क्या है कि आपका जो मिक्स करते हैं, ये जो वेस्ट रॉक है, उसमें कुछ फाइन्स रहता है, कुछ लम्प्स रहता है। तो उसमें देयर इज अ परसेंटेज 10 to 20% अगर फाइन्स रहता है और बाकी सब लम्प्स है, तो इट गिव्स द मैक्सिमम स्ट्रेंथ। तो वो स्लरी का फ्लो के लिए वो ये हेल्प करता है। सो दे हैव डन डिफरेंट फाइन, इसका रेशियो में स्टडी किया है, एंड दे फाउंड दैट अराउंड 10-20% जो फाइन्स अगर है तो इट विल ऑलवेज हेल्प इन। और कुछ क्वेश्चन?
फ्रॉम प्रैक्टिसिंग ऑयल से ऑलमोस्ट कितने
मॉल माइंस सर,
नाम बताइए आप।
from Balaghat mine. On Moyle sir in 13.5 level, which has a level interval of 45 meters sir. Simper is recommended in the traverses of 2.1 by 2.4 meters. We are supposed to drill 2 meters RV, but we find it really difficult to put a 2 meter RV because the roof height is barely 2.1 meter. Because we have a tram line on the bottom, and we find it very difficult to place an RV over there.
Okay. Balaghat travel में 2.4 मीटर ऑफ कोर्स इस के
2 meters sir, and the roof height is 2.1.
मतलब इंग्लिश की बात कर रहे हैं क्या?
नहीं, मैं ये सर 13.5 लेवल जो है सर, जो 45 मीटर लेवल इंटरवल वहाँ पे चालू किया हम लोगों ने, तो वहाँ पे जो 2.1 into 2.4 मीटर्स के ड्राइव है, सर जो ड्राइव में जो आरवी रिकमेंडेड है सर, उसका लेंथ है सर 2 मीटर। तो 2 मीटर का जो आरवी हम लोग जब लगाने जाते हैं तो उस समय उसमें दिक्कत आता है सर, क्योंकि नीचे बॉटम में ड्रम लाइन भी रहता है।
मैक्सिमम 1.8 कर सकता है, मैक्सिमम 1.8 कर सकता है। कितना आपका रोडवे का साइज बढ़ाना होगा?
कितना कंफर्टेबल लगा सकते हैं आप एज हाउ लॉन्ग यू कैन पुट कंफर्टेबल 9 मीटर
सर earlier it was 1.5 meter rock bolt with the cement cathode.
अच्छा 1.5 with cement.
1.8 must be recommended. 2 meter recommend किया गया.
Into 2018
साइज बढ़ गया होगा इसलिए आपका जो स्टिफनिंग का साइज बढ़ गया ना.
Usually 2 meter height है तो आप maximum 1.5 to 1.8, 2.4 है.
2.4 है.
2 मीटर से सर आरवी का 2 मीटर रिकमेंड किया गया है.
height of the drive is 2.1 and width is 2.4
meter.
Yeah.
2.1 में maximum 1.8 कर सकते हैं. Comfortable है. ये आप कैसे लगाते हैं? मैनुअली लगाते हैं क्या?
हाँ सर मैनुअली अभी चल रहा है सर. और हमारा जो एक हम लोगों ने वहाँ पे लोकल फिटिंग एडजस्टमेंट किया है सर. तो जो जैक हैमर है उसी के इसमें हम लोग लगा के एडेप्टर लगाया है.
नीचे खड़ा रह के करता है बोल्टिंग.
हाँ
ठीक है सर. ये सब जो है वेरी प्रिमिटिव टाइप ऑफ माइनिंग है. तो हम लोग विकसित माइनिंग में नहीं आता है. इसके लिए जो है ये सब कौन जमाने में ऑब्सोलीट हो गया. एंगल ये जो जैक हैमर से ड्रिल करके ये सब बोल्टिंग है. उसमें प्रॉब्लम क्या है कि यू आर गोइंग टू बोल्ट ए प्लेस विच इज नॉट सपोर्टेड. अब बोल्ट करेगा तब ना सपोर्ट आएगा. तो बोल्ट करने जा रहे हैं विदाउट एन अनसपोर्टेड ब्लॉक. और वहाँ पे अगर थोड़ा इतना साइज का एक रॉड चैन भी अगर लूज है उधर आप ड्रिल करने जाओगे तो सीधा आपका सर पे गिरेगा. ये सब प्रिमिटिव मेथड्स है. इसके लिए यू नीड रॉक बोल्टर्स नाउ. एंड ये 2 मीटर का रोडवे में वो नहीं चलता है. यू नीड एटलीस्ट 3.5 मीटर हाइट चाहिए.
हाइट की चेंज नहीं कर सकते हैं.
रीडेवलप करते हैं. रीडेवलपमेंट करते हैं बट वो सब के लिए मशीनरी चाहिए. ये
मॉल में सर वो लिमिटेशन है सर कि हमारे जो मैक्सिमम माइंस है सर उनका एवरेज वेट है सर 8 से 10 मीटर. तो हम लोग इस बार जो स्टडी किए है सर बेसिकली हम लोग देखे जाए तो 25 to 100 मीटर स्टोक वेट के इसमें हम लोग देखे एग्जाम्पल्स वगैरह जो है सर. तो जैसे 3 सिम माइनिंग हमारे यहाँ पे 2 मीटर्स के भी सिम है. 8 मीटर क्या ऑन एन एवरेज
8 मीटर मेरे वेट एवरेज
सब लेवल जैसे है तो उसको इम्प्लीमेंट करना बहुत प्रॉब्लमेटिक है.
नहीं कोई प्रॉब्लम नहीं है. उसमें क्या होता है कि यू द कॉन्फ़िगरेशन यू चेंज टू लॉन्जिट्यूड. ये ट्रांसफर स्टोक है. ये 20-25 मीटर का जो बताया वो ट्रांसफर स्टोक है. दैट इज व्हेन यू आर ट्रांसवर्सली आप माइन करते हैं. ये आप लॉन्जिट्यूडली माइन करेंगे. उसमें जैसे आप इधर जाइए. आप वेस्ट मोचिया माइन जाइए. सेंट्रल मोचिया माइन और बलारिया माइन. देयर ओवर बॉडी विड्थ इज थिनर. कुछ जगह थिकर है बट मोस्टली वेरी थिन. 4 मीटर 5 मीटर. वो कल हयानगिरी साहब ने जो बारोई माइन का दिखाया था 2 मीटर विड्थ है. So that there they do longitudinal. There the strike length of the stope is 60 meters. 60 मीटर का strike length.
वैसा लाइन करना पड़ेगा.
तो आपको longitudinally माइन करना है. longitudinal mining में जाना है.
Another problem is the inclination. In Balaghat and majority of the portion in the northern side, we have an inclination near about 30 degrees.
30 degree is flatter. उसमें आप cut and fill mining कर रहे हो ना. ना उसके लिए तरीका है. नहीं इन साइड माइक का जो एक सेक्शन है मैं इसमें नहीं दिखाया. उसमें क्या है कि दे हैव अराउंड 30 डिग्री एंगल है. व्हाट दे आर डूइंग इज दे डू पार्शियल वेस्ट माइन करते हैं. वेस्ट माइन करके आर्टिफिशियल 45 डिग्री फुटबॉल स्टाइल में बनाते हैं. एंड देन यू माइन दो. तो इसमें क्या कर सकता है कि मैंगनीज में बहुत इजी है. वो इसमें क्या है कि वो जो रिंग्स है वो रिंग्स में 2 पार्ट में ब्लास्ट करेंगे. वेस्ट का पार्ट वाले पार्ट ब्लास्ट करेंगे. चार्ज करके ब्लास्ट करेंगे. उसको मक आउट करेंगे. उसके बाद उसको प्लग इन करता है. कोड को प्लग करता है. देन यू ब्लास्ट द कोड. ऐसा इस तरह करके कर सकते हैं. अभी कांद्री माइन के लिए हम लोग वही सोच रहे हैं. वहाँ पे भी 30 डिग्री एंगल है. तो वहाँ पे भी थोड़ा वेस्ट माइनिंग आपको करना पड़ेगा. और वेस्ट को सेपरेटली ब्लास्ट करेंगे. मोस्ट ऑफ द रिंग्स पार्शियल ब्लास्ट करेंगे. रिंग्स का जो है इस तरह जो है इतना पोर्शन वेस्ट है. मान इतना पोर्शन पहले ब्लास्ट करेगा. देन यू चार्ज द नेक्स्ट वन इन नेक्स्ट साइकिल. तब और वेस्ट को सेपरेट आउट कर सकते हैं.
बालाघाट में सर एक प्रॉब्लम ये भी है सर फुटबॉल इतना कॉम्पिटेंट नहीं है सर.
फुटबॉल अच्छा है. बालाघाट फुटबॉल तो अच्छा ही है.
बालाघाट में सर हैंडबॉल में बनाया है. शाफ्ट हैंडबॉल में
फुटबॉल में
बालाघाट में फ्लैट का भी है सर. और शाफ्ट भी अपना हैंडबॉल में है सर.
पोलिंग करता है ना इधर कुछ जगह पाइप्स डाल के सीमेंट
हाँ फुल पोलिंग करना है सर बिना तो आगे नहीं बढ़ पाओगे थैंक यू सर
कांग्रेस से कोई है क्या? कांग्रेस से आप हैं? Any questions? Okay.
Yes, yes. How can you differentiate the uphill fault and the downhill fault in the field? नहीं समझ नहीं आया। Down to कैसे differentiate करें? Fault sir, fault. How can you differentiate the uphill and the downhill?
आपका इससे क्या बोलते हैं जो फॉल्ट का जो फॉल्ट ट्रेंस ही करना पड़ेगा फॉल्ट ट्रेंस ही करना पड़ेगा ना कि आपका हैंडवॉल ऊपर में है कि नीचे है उसी से पता चलता है
शेप से बेस्ड ऑन द शेप और
शेप नहीं
डाउन थ्रू हुआ है अप थ्रू हुआ है पता चल जाएगा ना
in the field sir generally you can differentiate by definition but in the field I am asking
देखिए फील्ड में क्या रहता है कि बहुत बड़ा इन जनरल क्या है मेजरली जो है ना फॉल्ट को आइडेंटिफाई करने के लिए बहुत सारा जियोलॉजिकल ये है सिस्टम है जैसे आपका जैसे मान लीजिए ओल्डर रॉक किधर मिल रहा है यंगर रॉक किधर मिल रहा है उसके ऊपर डिपेंड करता है क्योंकि फॉल्ट जो आपका इसमें दिख रहा है जो आपका बुक में दिख रहा है वैसे तो फॉल्ट नहीं मिलता वो ह्यूज एक मान लीजिए बहुत बड़ा किलोमीटर्स में मिलता है सिस्टम्स है चारों सिस्टम उसको फॉलो करना पड़ेगा
how can you differentiate the shear zone and the fault zone?
Shear zone basically क्या है shear zone क्या है जब रगड़ता है तब shear ठीक है वो shear zone क्या है मिनरलाइजेशन बहुत ज्यादा है सिलिकॉन साइट्स जैसे सिलिकॉन साइट्स मिलता है दूसरा क्या है कि मिनरलाइजेशन बहुत मिलता है इनके फॉल्ट में वो नहीं है फॉल्ट में डिस्प्लेसमेंट ज्यादा होता है और इसमें आपको फ्रिक्शन ज्यादा होता है
I think the time is up. It's time for the value.
But anyway, any question, any doubt, any issue which you want to take up with the silver scientist, please feel free to contact us. Our emails, our addresses are there. We are in Nagpur only. So feel free to contact Dr. John, me as scientist in charge, anytime, anywhere, over phone or email. You are most welcome. आप लोग आगे आ जाओ पूरे खाली पीछे से कोई सुनाई आएगी तो आगे से आएगी आ जाओ ओके आ जाओ उसके आप लोग आ जाइए ना बार बार एक चीज क्या रिपीट करें
एक पूरा राउंड क्या आ जाए
आप लोग सामने आ जाइए एक दो आ जाओ
हेलो हेलो
हेलो मार्केटिंग के अकेले साहब नहीं चलेंगे, फौज आएगी नहीं। चौधरी साहब फौज को बुलाओ। गुड इवनिंग सर। गुड इवनिंग एवरीवन। जैसा कि जानते हैं कि 2 दिन का ये नेशनल वर्कशॉप रीसेंट एडवांसेस ऑन अंडरग्राउंड मेटल माइनिंग जो आज संपन्न हुआ और इसके वैलिडिटी फंक्शन में मैं आपका तहे दिल से स्वागत करता हूं। मंचासीन परम आदरणीय हमारे चेयरमैन कम मैनेजिंग डायरेक्टर श्री अजीत कुमार सक्सेना साहब को प्लांट सैंपलिंग से स्वागत करने के लिए मैं ईडी टेक्निकल माननीय श्री करैया साहब को आमंत्रित करता हूं।
हेलो 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 आर्टिस्ट।
इसी श्रृंखला में मैं जीएम प्रोडक्शन श्री चंद्राकर साहब को निमंत्रित करता हूं। CSIR सिम्फर के नागपुर रिसर्च सेंटर के हेड माननीय श्री डॉक्टर रावण साहब का प्लांट सैंपलिंग से स्वागत करेंगे। कचरेकर साहब को मैं आमंत्रित करता हूं कि डायरेक्टर फाइनेंस हमारे श्री राकेश तुमाने साहब का प्लांट सैंपलिंग से स्वागत करेंगे। मैं आमंत्रित करता हूं हमारी डायरेक्टर HR श्रीमती उषा सिंह का स्वागत प्लांट सैंपलिंग से करेंगे। साथ ही साथ मैं निमंत्रित करता हूं हमारे डायरेक्टर PNP माननीय श्री अब्दुल्ला साहब का प्लांट सैंपलिंग से स्वागत करेंगे। इसी श्रृंखला में मैं श्री परिया साहब को निमंत्रित करता हूं कि हमारी डायरेक्टर कमर्शियल श्रीमती रश्मि सिंह का प्लांट सैंपलिंग से स्वागत करेंगे। साथियों, ये भी बता रहा हूँ कि मैंगनीज उत्खनन के हमारे 125 वर्ष पूर्ण हुए हैं। इसी उपलक्ष्य में ये CSIR सिम्फर के साथ एक नेशनल वर्कशॉप ऑर्गेनाइज किया था और आज एक अच्छे दिन के होने के कारण भी हम लोगों ने एक फैसला किया कि MOU साइन किया है WCL के साथ में। ऑफ द डायस मेरे बीच में श्री दिनेश बिशन बैठे हैं जो जनरल मैनेजर रेस्क्यू हैं। उनके स्वागत के लिए मैं आमंत्रित करता हूं श्री भाटी को। मैं चाहता हूं कि इंटरनेशनल रेस्क्यू प्लेटफॉर्म पे श्री विजेंद्र के लीडरशिप में प्रथम बार किसी भारतीय टीम ने द्वितीय स्थान प्राप्त किया, इसलिए एक जोरदार सदन से ताली हो जाए। एक इंटरनेशनल प्लेटफॉर्म के लिए इंडिया के लिए बहुत बड़ी बात है कि लास्ट ईयर कोलंबिया में हुए फंक्शन में WCL की टीम ने द्वितीय स्थान प्राप्त किया। इसी श्रृंखला में उनके मित्र साथ में आए रेस्क्यू सुपरिटेंडेंट श्री मुरुगेशन का स्वागत के लिए मैं श्री पुजाड़े को आमंत्रित करता हूं। कार्यक्रम के प्रथम चरण में मैंने फैसला किया कि अभी हम लोग एक MOU साइन किए हैं, रेस्क्यू सेफ्टी एफिशिएंसी करेज, जिसका लोगो है, और साथ में हमारी जो भूमिगत खदानें हैं 7 खदानों के साथ में इनकी ट्रेनिंग के लिए, इनकी एफिशिएंट फंक्शनिंग के लिए, इसके साथ हम 2 रेस्क्यू रूम भी स्थापित करने वाले हैं और हम इसमें WCL का साथ ले रहे हैं। तो मैं आदरणीय श्री प्रशांत करैया साहब को मॉइल की तरफ से तथा श्री दिनेश बिशन साहब WCL की तरफ से आमंत्रित करता हूं कि मंच पे MOU एक्सचेंज करें। आइए समस्त सर आपके साथ। बहुत बहुत धन्यवाद सर। ये भी एक मॉइल की तरक्की में एक ऐतिहासिक दिन साबित होगा, जिसमें एक रेस्क्यू सर्विसेज के साथ हम खदानों, भूमिगत खदानों की और सुरक्षा की ओर, बढ़ोतरी की ओर अग्रसर होते हुए वापस हम नेशनल वर्कशॉप की तरफ आते हैं। और मैं चाहता हूं डॉक्टर जॉन लुई जो कोऑर्डिनेटर है, ये आपको जानकारी देंगे माननीय सदन को और मंच को भी कि गत 2 दिनों में हमारा वर्कशॉप कैसा चला। आदरणीय श्री जॉन लुई साहब।
Respected CMD Moil, Mr. Saxena, and all other dignitaries on the days and off the days. We had very interesting sessions in the last 2 days, lots of deliberations, lot of questions and discussions. So I would just like to give a brief what we all heard from various speakers. From Hindustan Zinc, there were 3 very, very important, very interesting lectures here, and that invited a lot of participation from the, because they were really amazed, we were also really amazed to see that Sindeshwar Kurd mine is one of the best mine in the whole world, and it is the second largest silver producer in the whole world. And the kind of technology, the kind of advancements they are using, they are even controlling their LHDs from the surface. Sitting in an AC room, they can control their LHDs loading and dumping into the trucks. So we were really amazed to see their presentations and the technologies they are using, which even even though I am associated with all their mines for their designs, even I could learn many new things what they are doing. And the mine planning aspect, the way detailed mine planning they are doing, it's really amazing to see that even in India we have this kind of mines. So I truly recommend most of you to visit those mines. Maybe during your free time or so, you can take proper permission, and they are very open to visits. So you can visit them and of course learn many, many things from them. So I am really happy that they could come here. Of course, it was very difficult to bring them here because they are always in a tight schedule. So, but they took out their time, came here and presented here. So I'm really happy that we all could be enriched by their progress. I also thank Mr. Shanoy. He is the executive director. He came today and presented the Manganese copper project and the advancements they did. One amazing thing which we found that they transitioned from open pit to underground without any drop in their production. So the timing of transition was very crucial. That is very important. That usually what happens, open pit khatam ho gaya, abhi plan karna hai. Tata Steel made the same mistake in Sukinda, but Manganese copper project, they timed the transition so perfectly that they maintained the production, annual production, and now it is rising from there, from underground, fully from underground. So these are some of the highlights of his presentation. And Mr. Sarkar presented a very good paper here on this origin of manganese ore of Sauser group and all. It was also very interesting. And sorry. And from Simfer, we had 5, 6 lectures here. And this was all from various topics, including mine backfilling and blasting, ring blasting, and underground stope blasting, and underground development blasting, and also from numerical modeling methods and numerical modeling the tool as a tool being used for design of pillars. It was all very interesting, and people had a lot of queries on that. Even just before this function, we were answering the questions, and when the session started, we had to stop. So, in fact, the questions were continuing. And Dr. J.C. Jawar presented the importance of slope stability, even though we are thinking of underground mining as of today, because many underground mines work below a pit. So the pit induces a lot of stresses at the top levels of mining, and that becomes very crucial. So importance of slope monitoring and slope stability was deliberated, and there were some very good lectures on instrumentation and monitoring. Various instruments we used. From SK Mine, Mr. Pradeep Kumar, he presented the seismic monitoring system they have. Because their mine has now gone to 1.2 kilometers down. Their stoping is right now going from 1.2 kilometers. So he presented the seismic monitoring system they have established. And it is very wonderful that every event, seismic event, including artificial event like blasting also, is every event is recorded. And it gives a trigger action plan as well, and to evacuate people to, because as we go deeper, the stresses are more and the, what you call, the risks are much higher. This bumps takes place, rock burst take place. In some of the roadways, they have seen that from the corner, just soon after blasting, the pieces of rock that shoots out. It's like bullets. So this is rock popping, they call. So that takes place for quite some time. So at that time, you have to remove people from that place. So how to deal with high stress mining? Of course, oil mines are not that deep, but sooner, within years, those things you will experience in your own mine as well. And Hatti gold mines, we have participants here. So they have also experienced this kind of, 2 weeks ago I visited Hatti mines. They also said that a couple of times, sudden rock bursts they have experienced. So when people are really scared, soon after a blast, there will be rock noise, sound, like the rock is breaking and falling. So workers are afraid to go there. So these kind of things. So it was very interesting, and we had participants from many organizations. I'm very happy that you have traveled all the way. We have people came from Orissa, Rajasthan, everywhere, Karnataka, everywhere. So we had participants from Hindustan Copper, SMS Limited. SMS, we are delegates from Tumalapalli project as well as Manganese projects. And we have participants from Hatti Gold Mines and AP Trivedi, Orissa Mining Corporation, Gemco Technical Services, So all this, it was very lively, and I really liked this workshop. I don't know how the participants felt. If something has been missed out, or please update us so that at least in the next workshop we can make the corrections. So I wish all of you that when you go back to your mines, please try to implement some of those. Of course, we cannot overnight transform into like SK mine. That is not possible. But little by little, you can bring out the changes. And then, of course, I wish that Moil mines will also look fantastic one day and one of the best mines in the world. I believe so. With willpower, we can always achieve that. So with these few words, I once again thank Moil for allowing us to conduct this workshop and for sponsoring it and making all the arrangements. The arrangements were fantastic, sir, and impeccable, I should say. So we had little work to do. Of course, Moil did most of the work. So we are very happy. And I would like to congratulate Moil as well as all those who are associated with manganese mining for completing 125 years. It's a very big milestone. So congratulations to the entire Moil family. Thank you all very much. Thank you for the patient listening of the lectures. Thank you for allowing us to be here. Thank you all, sir.
बहुत बहुत धन्यवाद सर. अब मैं चाहूँगा कि पार्टिसिपेंट्स में से कुछ लोग इस नेशनल वर्कशॉप के बारे में अपने विचार व्यक्त करना चाहते हैं, तो ये सदन उनके लिए ओपन है. मॉइल से आकांक्षा.
Thank you, sir. It is with a deep gratitude that I, Akansha Sahu, on behalf of Moil, stand before you today to deliver the valedictory speech for this enriching 2 days workshop on recent advancement in underground metal mining. Over the past 2 days, we have immersed ourselves in mind-blowing discussions, groundbreaking ideas, and thought-provoking advancements in mining industry that India has witnessed in last few years. Dear speakers, your presentations have sparked new ideas and inspired us to think beyond the conventional boundaries. The speakers from the CSIR, the scientists, have paved the ways towards the challenges we are facing in the mining industries. The Hindustan Zinc Limited speakers are very helpful to bring us towards the excellence that they have achieved since last 5 years. And our motivation, the first lady mining engineer, also strike the importance of details that they have gone through to convert an open cast mine to an underground mine, and many other speakers like the speaker from Hindustan Copper Limited take us to the tour to the journey of the majestic Malajkhand project, and our gem of Moil, Dr. S.K. Sarkar, have provided the excellence knowledge of genesis of manganese ore in Saucer Group. So I thank all the speakers and dignitaries to overwhelm us with their knowledge, and we really hopeful to apply all these knowledges and advancement in our Moil as well. Thank you, sir.
Thank you. Anybody else? Raise your hand.
थैंक यू सर. मंच पर उपस्थित आदरणीय CMD सर और सारे डायरेक्टर्स, जावर सर, डॉक्टर जावर सर, यहाँ उपस्थित सारे सर, आप सबको गुड इवनिंग। ये 2 दिन का जो वर्कशॉप था सर, पहला ही दिन एक चीज़ बहुत अच्छा लगा कि एक प्लेटफॉर्म में जहाँ DGMS, IBM और इंस्टीट्यूट और इंडस्ट्री सारे इकट्ठा हुए, वो पहली बार देखने को मिला और उसको मोबाइल ने कंडक्ट किया। ये बहुत ही अच्छा प्लेटफॉर्म था। उसके बाद सर, जैसा कि पहला दिन आपने ही बोला था सर कि ओपनली माइंड से आप इस सेशन को अटेंड कीजिए। इसमें कुछ कुछ चीज़ें हम लोग को सीखने को मिला, फ्यूचर का जो है वो भी सीखने मिला। जो जॉन सर ने बहुत ही अच्छा हमको सिखाया है, उनसे बहुत ही डिस्कशन चल रहा था। लेकिन जो अभी रिसेंटली हम सीखे हैं सर, जो इंस्ट्रूमेंटेशन को लेके सीखे हैं, जो मेथड ऑफ माइनिंग में कुछ चीज़ें जो हम लोग अभी फेस कर रहे हैं उसको चेंज कर सकते हैं, और पेस्ट फिलिंग और हाइड्रोलिक फिलिंग में बताया, पर उसके लिए जो प्लांट का जो कॉस्ट है उसके ऊपर सर डिस्कशन तो ऊपर लेवल में ही करना पड़ेगा, क्योंकि हम लोग उसको पहले सोचेंगे कैसे एप्लीकेबल होगा, क्योंकि वो बहुत बड़ा कैपिटल कॉस्ट है सर। और ब्लास्टिंग डिटेल भी कुछ सर कल बहुत ही अच्छा, धनबाद से सर आए थे, सिम्फर से, उन्होंने बहुत ही बढ़िया बताया, उनके साथ भी डिस्कशन हुआ। हम लोग जो फेस कर रहे हैं प्रॉब्लम, वो प्रॉब्लम भी सर ने बहुत अच्छा बताया। और भी अभी भी डिस्कशन चल ही रहा था, आप लोग आने से पहले सर क्वेश्चन चल रहे थे, और आगे भी अगर कुछ क्वेश्चन रहा तो जॉन सर तो सर है वो बोलेंगे ही। बाकी बहुत ही अच्छा सेशन रहा सर ये 2 दिन, और बहुत ही एंजॉय किया सर हम लोग को। मैंने एक अच्छा, मैंने फील्ड छोड़ के सर एक एजुकेशन इंस्टीट्यूट में लगा आए हैं, अच्छा लगा सर। थैंक यू।
थैंक यू। और कोई ऑर्गेनाइजेशन से कोई कुछ? समीर।
हेलो, नमस्कार सर। इस 2 दिन के रिसेंट एडवांसेस इन अंडरग्राउंड मेटल माइनिंग कार्यक्रम में जो 125 ईयर्स का, जैसा कि हमारे ऑनरेबल CMD ने कमोमोरेट लास्ट अपने स्पीच में बोला था कि इसको कमोमोरेट करना है, मतलब यादगार बनाना है। और ये टॉपिक्स जो कवर हुए लास्ट 2 डेज में ड्यूरिंग दिस फेज ऑफ ट्रांजिशन ऑफ माइनिंग इंडस्ट्री, अभी वॉल्यूम्स में जो एक्सपांशंस होने वाले हैं, उस प्रकार से जो हमारे मॉइल की नीड है इन टर्म्स ऑफ मेथड ऑफ माइनिंग सपोर्टिंग, या आने वाले जो टेक्नोलॉजिकल अपग्रेडेशंस है, वो सारे मैक्सिमम इस पेपर्स में कवर किए गए, जिसमें बैकफिलिंग जैसे एरियाज़ है या मेथड ऑफ माइनिंग है, जिसमें जॉन लुई सर ने भी काफ़ी अच्छा न्यूमेरिकल मॉडलिंग के बारे में बताया। डॉक्टर चंद्राणी प्रसाद वर्मा मैडम का जो एक असेसमेंट का पेपर था, वो भी ओवरऑल इंडस्ट्री का ओपन पिट को अंडरग्राउंड में कन्वर्शन में आज बहुत सारे जगह पे वो चीज़ें हो रही है, उसका भी एक अच्छा ओवरव्यू मिला। उसके अलावा न्यूमेरिकल मॉडलिंग में एक एकेडमिक एक्सरसाइज है जो कि याद दिलाता है पुराने दिनों की, और एकेडमी इंडस्ट्री का अच्छा ब्लेंड यहाँ हुआ। इसलिए मैं सिम्फर का बहुत बहुत धन्यवाद देता हूँ, और एंटायर मैनेजमेंट का धन्यवाद देता हूँ, उन्होंने हमें इस कार्यक्रम में शरीक होने का मौका दिया। धन्यवाद।
थैंक यू समीर। और कोई है कि मैं आगे बढ़ाऊं? मॉइल के अलावा और कोई इंडस्ट्रीज से सर? सिम्फर से? मैं आपको बताऊं सर, कल जब शुरुआत हुई थी तो हम लोग एक प्लेटफॉर्म पे, साइंटिफिक एजेंसी थी सिम्फर, रेगुलेटरी बॉडी DGMS और IBM भी थी, साथ में हम 4 मेटल माइंस के कंपनी थे, हिंदुस्तान कॉपर के, मॉइल के, हिंदुस्तान जिंक के, और धीरे धीरे लोग जुड़ते गए, बहुत सारे लोग हैं। और आपको मैं बताते हुए मुझे फक्र हो रहा है कि ऑलमोस्ट हिंदुस्तान के हर कोने से सारी कंपनियों से लोग आए हैं यहाँ पे। मॉयल है, HCL है, सिम्फर साइंटिफिक एजेंसी के तो हैं ही हैं, AP त्रिवेदी एंड सन्स से हैं, इंफा से हैं, जेमको से हैं, हाथी गोल्ड माइन से हैं, उड़ीसा मिनरल कॉरपोरेशन से, SMS और DCS से भी हैं। तो काफ़ी लोगों ने पार्टिसिपेट किया। और कोई बोलना चाहता तो बोले, नहीं मैं आगे। हाँ जी प्लीज़।
Thank you so much, sir. Really, today's session was very wonderful. In industry, sir, myself Malleshwar Rao from Gemco Technology Services, CK Birla Group. Really, this today's session was wonderful. in India till date, Simfer is pioneer in giving solution for so many problems, either it is metal mine or coal mine or open cast or underground or transition from open cast to underground or from underground to open cast. Simfer is the only solution for so many research problems. And Moil is the 125 years experience and manganese ore pioneer in India. Both organized an event which given in 2 days they tried to give their entire experience to us. It is really wonderful. In addition to that, HDL came and given wonderful presentations, especially Janwar sir का जो slope stability का है और John sir का जो है, they started from basics, what is stress. From that onwards, they have taken to the advanced, the most advanced techniques. Really, it is a wonderful session. This type of sessions definitely rethink the industry people, and they will try to implement at their locations. And also sometimes what happens, people will have the problem, but they don't know how to approach and to whom to approach. This type of workshop will help how to approach and do this type of similar problems might be dealt in some other mines. So they can contact and they may visit those mines and they can solve their problems also. Really, this type of workshop should happen very frequently. Very much thankful to Moil and Simfer. Thank you so much, sir, for giving this opportunity.
Thank you, sir. और क्योंकि अब आता है सर्टिफिकेट बांटने का समय, मैं माननीय श्री अजीत कुमार सक्सेना साहब, अध्यक्ष प्रबंधन निदेशक से आग्रह करूंगा कि मंच के समक्ष आकर एक एक कंपनी के एक रिप्रेजेंटेटिव को सर्टिफिकेट देंगे, क्योंकि मेरे को मालूम है बहुत लोगों ने अपने फ्लाइट और ट्रेन का टाइम बता दिया है, मुझे वक्त की पाबंदी है. मैं एक कंपनी से एक रिप्रेजेंटेटिव बुलाऊंगा. मॉइल की तरफ से सारे पार्टिसिपेंट्स का सर्टिफिकेट ग्रहण करने के लिए मैं श्री आर.यू. सिंह को निमंत्रित करता हूं. हिंदुस्तान कॉपर की तरफ से मैं आमंत्रित करता हूं श्री आशीष दड़वाल को. सिम्फर की तरफ से मैं आमंत्रित करता हूं श्री नागेश्वर राव को. एपी त्रिवेदी एंड सन्स की तरफ से श्री मधुसूदन जी. इंफा की तरफ से श्री आशीष पंडा जी. जेमको की तरफ से श्री राव साहब. हट्टी गोल्ड माइन लिमिटेड की तरफ से श्री अमल रॉय. ओएमसी की तरफ से श्री सुमित गुप्ता जी. ओएमसी की तरफ से कोई ठीक. एसएमएस की तरफ से श्री किरण कुमार जी. और डीसीएस की तरफ से शिवानंद नायक जी. शिवानंद नायक, थैंक यू सर. आज का एक कार्यक्रम संपन्न हुआ इसके पीछे एक शख्सियत हैं जो CSIR सिम्फर नागपुर रिसर्च सेंटर के हेड हैं, और उनके और जॉन लुई साहब के कोऑर्डिनेशन में जो वर्कशॉप के कोऑर्डिनेशन है, मैं समझता हूँ एक नेशनल वर्कशॉप ऑर्गेनाइज करना, इतने सारे फैकल्टीज़ को और इतने सारे लोग को एक छत्र के नीचे जमा करना एक बहुत ही बड़ा कठिन काम है। मैं माननीय श्री दावर साहब को निमंत्रित करता हूँ अपने आशीर्वचनों के लिए।
वेरी गुड इवनिंग। सभी को बहुत बहुत हार्दिक नमस्कार। आदरणीय सक्सेना साहब, CMD मॉयल लिमिटेड, आदरणीय अब्दुल्ला साहब, डायरेक्टर प्रोडक्शन प्लानिंग, आदरणीय तुवाने साहब, डायरेक्टर फाइनेंस, मैडम उषा सिंह, डायरेक्टर HR, मैडम रश्मि सिंह, डायरेक्टर कमर्शियल मॉयल लिमिटेड, distinguished officers, high senior officers from Oil Limited, my distinguished colleagues from Simfer, my other colleagues from Simfer, and distinguished participants from across industries, from Oil Limited, from Hindustan Copper, Hindustan Zinc, SMS Limited, Orissa Mining Corporation, AP Trivedi and Sons, GMT Limited, and other organizations. So it is really wonderful. मुझे बहुत आश्चर्य होता है कि इतने कम समय में इतने अच्छे कि वेल स्टेशन हाउस फुल है एकदम. So as a scientist, it's really very heartening to see this thing. So before commencing anything, I would like to place once again मेरे हार्दिक बधाई मेरे इंस्टीट्यूट की तरफ से, मेरे अपनी तरफ से कि 125 years of manganese mining, it is really incredible for the nation's growth that this manganese mining has been undergoing under different names and now since so many years under the name of Oil Limited and really progressing very well. And for the last so many years under the leadership of Saxena Saab, it has really made wonders in terms of both volumes, in terms of profit, and in terms of overall brand value. So, very hearty congratulations, sir. Secondly, from my own behalf, from my behalf of my director Simfer, and from all colleagues of Simfer Nagpur Center, I would like to place upon a deep sense of thanks and gratitude to the Oil Limited for sponsoring this event, from arranging everything. Whatever we are seeing here is all due to the Oil Limited, sir. And this is really very commendable. In my whole career of 38 years, I have seen this. I think I am seeing for the first time how an industry can sponsor an event solely for the benefit of all industries, mining industries. So it's really very, very good. So once again, my thanks and gratitude on behalf of Simfer, sir. Some 8-9 months back, my director, our head of institute, Professor Mishra, rang me and told me one fine morning that Dr. Jhamar, you have to organize one seminar, symposium, workshop on hard rock mining at Nagpur Center. I told, sir, let me think. I will reply you within 2-3 days how we can organize this thing. No, you have to organize this thing. अब क्या करना है, workshop करना है, क्या करना है, ठीक है, we'll do it. Then I called Dr. John, my colleague, my distinguished colleague, Dr. John. We interacted. मैंने बोला कि सेमिनार सिम्पोजियम में क्या होता है कि हर पेपर प्रेजेंटेशन 2 मिनट का प्रेजेंटेशन होता है, सब चले जाते हैं, बस मिलना हो जाता है, इंट्रैक्शन. बट आई थिंक मुझे जो जरूरत थी इंडस्ट्री को, जो मेरा अपना अनुभव है कि द वर्कशॉप ओनली कैन गिव द रियली व्हाट इज नीडेड फॉर द पार्टिसिपेंट, फॉर द माइनर्स, फॉर द प्रैक्टिसिंग इंजीनियर्स. So really, I'm very heartening to see that we have achieved success in terms of what we have looked for. So in terms of that, I think really we are successful. So Doctor, yesterday he was yesterday when we met in the evening, he was appreciating very well, Dr. Jhamar, the function was really very good. And please convey my heartfelt thanks to the Oil management, CMB and the directors, sir. So thanks once again, sir. We can see the enthusiasm, the kind of interaction between the speakers and the participants, that itself gives a sense that yes, really you achieved the function. Because in my own experience, I have seen that we are a triangle basically. One is a minor, one is a scientific body, and regulatory body. In the inaugural function yesterday, we had seen that all 3 pillars are assembled together and deliberated, and that is really very incredible and really very needed for the mining industry to move forward. My own association with Oil Limited dates back to 95, when after 7-8 years of industry and Simfer experience at Dhanbad, I was transferred to Nagpur. And my first assignment was at Bongri Buzurg Moil Limited. The very first project which completed Moil was Moil of air deck blasting. That was my MTech topic also. And I'm very happy to share that we have published 4 papers in international journals based on a case study about the work we have done at Moil Limited, Dongri Buzurg mine. I hope the air deck blasting is still being practiced there. I don't know. We have used wooden spacer bears at that time. So my own affection with the Moil is really good. And I think I visited all the mines of your Moil Limited since '95. We have done support design also for drivers for all underground mines of Moil Limited. And till date, in one way or the other, we are closely associated with Moil mines, Tirodi open cast, Dongri open cast, and all the 7 underground mines of Moil Limited. So that way also, I really thanks once again to the Moil Limited for enabling this function, for enabling we at Simfer Nagpur Center to organize this. Otherwise, it would have been not possible, sir. Because we don't have infrastructure, our small building, we have small resources here at Nagpur Center. So, but you had made it possible for providing all facilities, and really to see this kind of gathering and this kind of satisfaction on the faces of participants is really heartening. It really touches because we have achieved this function. As a scientist, I really feel very happy when I listen to the participant, lady mining engineer from industry. Yes, it was really wonderful. So that gives a deep sense of satisfaction. So thanks once again, sir. Thanks all my speakers, my colleagues from Simfer, colleagues from industry who spoke on these topics. And I think this process should go on continuing because it never stops. My own experience, scientist, that mining itself is unpredictable because we are dealing with rock masses. Today we are exposing certain area of rock mass. This undergoes different changes of different types. The characteristics of rock mass undergoes changes when we move laterally, when we go deeper. So we have to periodically conduct investigations, interpret the data, go back to scientific bodies. So regulator, junction of regulators, miners, and scientists has to be there continuously on a sustained basis to achieve the overall objective of developed mining in India. So I wish all the very best to all the participants. I wish all the very best for the Moil mines and the Moil family to move and touch newer heights under your leadership, sir. Because I'm here to retire in just 2 months only, but I will be always available for all kinds of support and my all the very best wishes for everything you look forward to, sir. Thank you very much.
बहुत बहुत धन्यवाद सर अपने आशीर्वचनों के लिए। और इस सभा के अंतिम परिणाम में आज के कार्यक्रम अध्यक्ष और जिनके मार्गदर्शन में भी इस वर्कशॉप का भी आयोजन हुआ, और मॉयलियंस चाहते हैं कि हम अपने अध्यक्ष और प्रबंध निदेशक माननीय श्री अजीत कुमार सक्सेना साहब को सुने, उनका आशीर्वाद लें और आगे की रणनीति की अपने को तैयार करें। माननीय श्री अजीत कुमार सक्सेना साहब।
Good evening, everyone. 2-3 points which people have mentioned. So having worked for more than 38 years in industry, I feel that जो आपने बोला था कि स्कूल वाला कॉलेज वाला माहौल बना रहना चाहिए, learning. So that learning part, learning organization is really the need of today, where the only thing which is permanent is change. And we started with this workshop with one thing in our mind, that we have to change our way of mining, because it is not safe, it is not that productive as it is required by the industry today. So I assure you we'll maintain this learning spirit of the organization and keep this tempo high. Secondly, I'm sure when regulatory bodies and academia and working managers have met, today you may not see any tangible benefits arising out of it, but you could have said, you could have expressed many more things which you otherwise would not have expressed in a formal atmosphere. Many things you wanted to say to DGMS, many things IBM wanted to tell DGMS or to academicians or to practicing managers. So I'm sure that communication must have taken place. You will not see the benefits of it today or tomorrow, but in long run, when you develop this kind of informal communication channel, it definitely helps industry as well as regulatory body. Third thing, what sir has said about the continuity of this, I propose in the month of April, why this 125 year should be celebrated on 1 or 2 single day. So perhaps we can think about series of lectures or series of such workshop. So if everything goes well, I think we can propose another workshop in the month of April, and maybe at some of the mine location. May not be in Nagpur, maybe at some mine location. And the way, I mean, I was getting feedback that what Hindustan Zinc has told, what Hindustan Copper has told. So I'm sure that good interaction has taken place. So I invite all those who are attending this program today for next workshop in sometime in April, and also through you and through YouTube and the other media to all those who want to participate in our next workshop. Because this is spirit of learning and a spirit of interacting, and what I said, not reinventing your own zero and own wheel should continue, because it impacts us all, and time is too short for all of us to develop and to achieve whatever we have dreamt of. So we'll continue with this kind of series, and all of you are invited for the next one sometime in April. Thank you very much. Thank you.
बहुत बहुत धन्यवाद सर अपने आशीर्वचनों के लिए। और सभा की अंतिम कड़ी में मैं वोट ऑफ थैंक्स के लिए हमारे ईडी टेक्निकल श्री प्रशांत करैया साहब को निमंत्रित करता हूँ।
मैंगनीज माइनिंग के 125 वर्ष संपन्न होने के अवसर पर CSR सिम्फर द्वारा आयोजित 2 days वर्कशॉप, जो उसका टॉपिक था रिसेंट एडवांसेस इन अंडरग्राउंड माइनिंग। सर्वप्रथम मैं मंचासीन अतिथियों का स्वागत करता हूं। आदरणीय श्री अजीत कुमार सक्सेना साहब, CMD मॉइल का मैं तहे दिल से इस अवसर पर मेरी तरफ से स्वागत करता हूं। ऐसे ही डॉक्टर जावर साहब, जो कि सिम्फर के हेड ऑफ दी हैं यहाँ नागपुर में, उनका भी स्वागत करता हूँ। मंचासीन डायरेक्टर्स मॉइल के श्री राकेश तुमाने साहब, श्रीमती उषा सिंह मैडम, श्री अब्दुल्ला साहब, श्रीमती रश्मि सिंह मैडम, सभी का मेरी तरफ से हार्दिक अभिनंदन करते हुए मैं इस मौके का फ़ायदा लेते हुए जो मुझे वोट ऑफ थैंक्स देने का लिए बुलाया गया है उसको थोड़ा विराम देता हूँ। और मैं भी अपने 2 शब्दों से इस कार्यक्रम के बारे में बोलना चाहूँगा कि जो ये वर्कशॉप थी, मैं जनरली पूरे टाइम नहीं बैठ पाता हूँ, फिर भी मैं भरपूर कोशिश किया, जहाँ जहाँ मौका मिला मैं यहाँ इस कार्यक्रम में उपस्थित रहा। और कुछ लेक्चर्स जो स्पेशली मुझे लगे कि माइल जिससे अभी डायरेक्टली रिलेटेड है, जो माइल के लिए अभी सोचने का विषय है। एक सब्जेक्ट मैडम जो पहली फर्स्ट माइनिंग इंजीनियर चंद्राणी मैडम ने दिया कि हाउ टू कैलकुलेट द बैरियर या क्राउन पिलर व्हेन यू ट्रांसशिपमेंट फ्रॉम ओपन कास्ट टू अंडरग्राउंड माइन। तो एक हम लोगों का ये विचाराधीन सब्जेक्ट है। आने वाले समय में हम जो प्रोजेक्ट लेके आ रहे हैं, तो ये एक सोच को डेवलप किया है। ये एक दिन में कोई सीख के नहीं जाता है, यहाँ पर एक सोच बनती है। ऐसे ही जो हमारे जॉन लुई साहब ने न्यूमेरिकल मॉडलिंग के बारे में बताया, और जावर साहब स्लोप स्टेबिलिटी के बारे में बोले, और विशेष रूप से जो 2 कंपनी से पार्टिसिपेंट जिन्होंने लेक्चर यहाँ डिलीवर किए, हिंदुस्तान जिंक के 2 जो वक्ता थे, उन्होंने काफ़ी डिटेल यहाँ पर बात की, कैसे वर्किंग कर रहे हैं, क्या उन्होंने इंस्ट्रूमेंटेशन में, हम भी चौंक गए सोच के। और ये चीज़ हमने सोची भी नहीं थी कि इस हद तक का इंस्ट्रूमेंटेशन इंडिया में शुरू हो गया है। और जो आज तक हम यही सोचते थे कि भाई डिजिटाइजेशन है, कोई रूम में बैठ के सॉवेल चला दिया रिमोट से या ये कर लिया, पर जिस तरीके का सेफ्टी से अवेयरनेस के साथ उन लोगों ने अपने बताया कि वो लोग क्या क्या एक्टिविटी कर रहे हैं, सिस्मोग्राफी कर रहे हैं, ये सारी चीज़ें एक सोच हमारी भी बदल रही है कि आने वाले समय में जो अभी जान साहब ने बताया कि हट्टी गोल्ड माइन में जो बम्स और रॉक बस्ट के प्रॉब्लम हुए हैं, निश्चित रूप से 1 किलोमीटर गहरी खदान में ये सारी दिक्कतें होंगी। और हम भी धीरे धीरे 500 से 700 मीटर की डेप्थ पे अब काम करने जाने वाले हैं। तो मॉइल भी इसमें काफ़ी इंटरेस्ट हम लोगों को भी आना चाहिए। और एक यंग टीम हमने यहाँ बुलाई थी मॉइल से भी, माइनिंग इंजीनियर, मैकेनिकल इंजीनियर को, कि वो भी जियोलॉजिस्ट भी थे, इस विषय पर चिंतन किए। और ऐसे ही जो ट्रांसशिपमेंट का पीरियड एक और जो मलाजखंड का बताया गया, सिन्हा साहब जो ईडी यूनिट हेड मलाजखंड के आए थे, उन्होंने अपने लेक्चर में आज डिलीवर किया। उन्होंने जिस तरीके से बताया कि किस तरीके से उन्होंने ट्रांसशिपमेंट किया और अपने प्रोडक्शन को मेंटेन करते हुए अंडरग्राउंड में चले गए, और आज 2024-25 में ओपन कास्ट से जीरो प्रोडक्शन के साथ वो अपना प्रोडक्शन जो उनका था उससे भी ऊपर 2.5 मिलियन टन पर पहुंच गए हैं। तो कहीं उन्होंने इस चीज़ को अपने कार में नहीं आने दिया। तो ये एक हम लोगों के लिए भी एक चैलेंजेस है, हमारी भी सोच उस तरफ जाएगी। और निश्चित रूप से इस तरह के जो वर्कशॉप्स होते हैं, काफ़ी कुछ उसमें हमको इस तरह का ज्ञान मिलता है। सबसे बड़ी चीज़ है कि हमारे दिमाग में ये चीज़ बैठ जाती है कि ऐसा भी हो सकता है। हाँ, एक दिन में कोई उतना सीखता नहीं है और एक लेक्चर में आप ज्ञाता भी नहीं बन सकते, सिर्फ आपका दिमाग खुल जाता है कि इस बारे में सोचा जाए। मैं जॉन लुई साहब को, डॉक्टर जावर साहब को बहुत बहुत इसके लिए धन्यवाद देता हूँ कि इस तरह का सेमिनार और वर्कशॉप उन्होंने यहाँ हमारे बीच में लाए लोगों को, और हमको मौका मिला इसको सुनने का। अब मैं सर्वप्रथम हमारे सीएमडी साहब का इस मंच से धन्यवाद प्रेषित करना चाहूँगा, जिनकी सोच के कारण आज ये दिन यहाँ उपस्थित हुआ। उन्होंने कहा था कि 125 साल हम सेलिब्रेट करेंगे, पर कोई ऐसा जलसा नहीं करेंगे, उसमें एक सेमिनार या वर्कशॉप होनी चाहिए जो टेक्निकल सेशन हो। आज वो हमारे बीच उपस्थित हुए हैं, इनॉग्रल फंक्शन में भी थे, आज समापन समारोह में भी है। मैं उनका तहे दिल से धन्यवाद करता हूँ कि उन्होंने अपना कीमती समय इस के लिए दिए हैं। ऐसे ही डॉक्टर जावर साहब जो लगातार काफ़ी दिनों से हमसे संपर्क में थे और पिछले गत 2 दिनों से तो पूरे दिन यहाँ हमारे साथ रहे, मैं उनका भी तहे दिल से धन्यवाद देता हूँ। हमारे डायरेक्टर तुमाने साहब भी अपने सेल्फ इंटरेस्ट से आज आए, 2-3 लेक्चर उन्होंने भी अटेंड किए और उनका लगातार हमको सहयोग प्राप्त होता रहता है, उनका मैं धन्यवाद देता हूँ। श्रीमती उषा सिंह मैडम, उनके अभी पहले दिन से ही उन्होंने अपना एग्रेशन दिखाया था कि ये कार्यक्रम कैसे होना चाहिए, क्या होना चाहिए। लगता है मेरी टीम ने भरपूर उसमें खरी उतरी है। डॉक्टर साहब जावर साहब के उद्बोधन से ऐसा लग रहा है कि मेरी टीम ने वाकई जो मैडम चाहती थी वैसा काम किया है। और हमारे जो मैं मैडम का धन्यवाद देता हूँ, ऐसे ही हमारे माइनिंग के डायरेक्टर पीएनपी श्रीमान अब्दुल्ला साहब जो कंटिन्यूस हर चीज़ को मॉनिटर कर रहे थे पीछे से और पूर्णतः इसमें इन्वॉल्व थे। मैं उनके मार्गदर्शन के लिए उनको बहुत बहुत धन्यवाद देता हूँ। श्रीमती उषा सिंह मैडम जो हमारे साथ हमेशा रहती हैं और अपने जहाँ भी उनका सहयोग की ज़रूरत पड़ती है वो तुरंत आगे बढ़कर सहयोग प्रदान करती हैं। मैं उनके यहाँ आगमन के लिए उनको धन्यवाद देता हूँ। आज के कार्यक्रम को उन्होंने सुशोभित किया, उसके लिए धन्यवाद देते हुए मैं सिम्फर से हमारे कोऑर्डिनेटर श्री जॉन लुई साहब को भी धन्यवाद देता हूँ कि वो अपने बहुमूल्य समय देते हुए यहाँ लगातार पूरे टाइम इस प्रोग्राम को आयोजित किया है और पूरा कोऑर्डिनेट किया है, कहीं कोई कमी नहीं छोड़ी उन्होंने। उनके इस अथक प्रयास के लिए मॉयल की तरफ से मैं आपका धन्यवाद देता हूँ। सभी जो स्पीकर्स लोग विभिन्न जगह से आए थे, सिम्फर से और इंडस्ट्री से, जो उन्होंने अपना अमूल्य मार्गदर्शन हमें दिया है, मैं उनका विशेष रूप से धन्यवाद देता हूँ। और मेरे सभी साथी जो यहाँ माइन से आए थे, मॉयल के, हट्टी गोल्ड माइंस के, एपीजे त्रिवेदी, मलाजखंड कॉपर यूनिट से और भी जो दूसरे यूनिटों से इंफा, सभी को मैं तहे दिल से धन्यवाद देता हूँ। आप सभी यहाँ आज उपस्थित हुए, अगर किसी का नाम छूट गया हो तो वो मेरी गलती है, मुझे क्षमा करेंगे। मैं सभी को धन्यवाद देता हूँ। आपकी इस सहयोग से हमारा कार्यक्रम संपन्न हुआ है। मैं सभी को धन्यवाद देते हुए इस सभा का विसर्जन करता हूँ। धन्यवाद।
अब ये सभा समाप्त करने की आज्ञा लेता हूँ और सभा समाप्ति की घोषणा करता हूँ। आप सभी को अल्पाहार के लिए आमंत्रित करता हूँ। धन्यवाद। जय हिंद।